I know it has been like I think around 4 or 5 days since we last connected, so wasn't keeping well, and basically few things were there. But I hope you have like gone through all the previous classes which we had, right? Which we have taken and everything. So last I remember, I think we covered on the outlier analysis and missing value. We'll give you a quick brief. Okay. Meanwhile, just I hope everything is clear. So just let me open. So let me first actually run through all these steps which we actually have to do for new students and everyone, and then we can basically go through the same. Okay. Thanks, Divya. So see, okay, I see the count people have joined. So here, then I think we can begin. So few things to just remember. First, we are taking this course. 1 second, yeah. We are taking this course on iNeuron. Okay, so you can go to our website, check all the other awesome courses. For this particular course or for other courses which I take normally, you can go to here, then instructor. Okay, and then you can go to Mayank Agarwal. Okay. So this particular course is your data science foundations. Okay, data science foundation. I have also taken a course on machine learning foundation. Please feel free to check that out. It has already been done. Will suggest to enroll here only. So if you enroll here, you will basically get an idea that okay, once you complete this course, highly suggest to complete this course after that. Okay, everything will be available for free and you will get a certificate as well. So the good thing overall would be that if you will be doing all both of these things, you will be have a pretty good base, I would say, in machine learning journey. Okay, so very important this thing. Just a second. Just a second, everyone. Great. Let me actually just do one more thing. So it is helpful. I can see your comments meanwhile. Yeah. Great. I think we should be good now. So cool. Yeah. So what I was saying is that yeah, after we complete this course, which should be most probably today is Wednesday. So yeah, tomorrow I intend to start the case study because we will be done with most of the stuff. So this is completely free, as you can see. Then you have to enroll here. You can explore the course for all the things as well. So just log in. You might have to sign up when you do that for the very first time. Then once you log in, you will be able to see all the previous videos, some assignments, quizzes, and everything. So very important thing, you have to make sure that you complete each and every of these things if you have to get the certificate. Okay. So you have to complete all these things so that you can get the certificate. There is a overall resources, everything which I'm using will be shared here. Then notes, you can make your personal notes here. Okay, I think I showed this for the very first time as well. Like with the timestamp, the notes will be made. Then all your doubts, okay, and your feedback and everything you can also provide. Okay, so feedback, everything you can provide like this. So this should all be pretty straightforward. Okay. Divya will be discussing on that. No worries. I will taking an example as well. So we'll be doing that. Okay. Should be fine. Great. I think yeah, we should be good. So we'll be covering all of that also. I hope all things here are fine. Now you can actually see all the classes here. Okay, just giving this a quick recap so that most of you are have an idea on the same. We have had 4 things here. Now let us go another place where you can take these videos. So the next place is you can go to iNeuron channel, iNeuron Intelligence here, and then if you go in the live, basically here is where our classes are happening. Okay, so previous classes are also on that thing only. So we can go here and we can see that okay, this is the live class. Okay, so for anyone who is new, I will suggest see the live classes on, I would say, or YouTube, like and basically share that, comment and everything should also be done. And along with that, I would suggest to basically meanwhile enroll in the course and then do the same. Okay, let me open the previous as well so that I can help all of you remember and basically have an idea on the same. Okay. Great. Okay, so I hope everyone till now everything is clear. We are good to begin, right? Can I get a quick yes or thumbs up in the comments if everything is good? Give me a yes or thumbs up so that I'm aware that okay, we are good to begin. Great. Everyone else? Cool. So I think we should be good to begin. I will just quickly help you revise all the things. Okay. So we started with introduction of stats. Okay. Then we saw different area of statistics. They were your inferential, and descriptive. Okay. I hope each and every one of you remember the same. Then we saw measure of central tendency. Those are mod, mean, median. Okay. So this is okay. This is a little bit about me. So I think I've covered that a lot. But few people who are joining for the very first time, I am Mayank Agarwal. I am a machine learning engineer, educator, data scientist. Like these are the few, I would say, the designations which I have. But I would say that from heart, I will mainly try to basically make products which makes life easier. So I'm simplifying data concept one concept at a time. Worked previously as Goldman Sachs, Myntical, Oyo Rooms. Okay, I worked in my career. I have worked actually as a software developer or data scientist majorly. Okay, so I have a very good idea on exactly how things, when we are working in an industry level, what are all the experiences and everything, what kind of problem one faces. Okay, so you can feel free to check me out on LinkedIn. So you will get a more idea about me and connect with me there. So this is actually the second class after we have done mean, median, and mod. So we started with variance. Then, if everyone remembers, so variance we saw that okay how variance is calculated between two variables. Okay, it helps us to understand that okay how sorry variance, yeah, variance basically measures how far a set of your numbers are spread out from their mean. My bad, it is not, that is covariance and correlation. Variance is basically for a particular, say, your variable. Let that variable be, let's say, where. Okay, how much of, let's say, values are like this, how are they basically spreading from their mean. Okay, so we also saw the graphs and everything with respect to the same. Okay, then we saw that okay how the graphs changes and everything based on that thing. Then we learn about standard deviation. Okay, it is the square root of your variance. It is helpful for us to basically make sure that when we are making something like this, okay, so this is a new, then one standard deviation for is what are this lies, then let's say nu minus sigma. So basically standard deviation is used here when you have the Gaussian curve. Okay, when we have the your overall I would say normal or bell shaped curve. I hope you all remember the curves and everything which we discussed. That is very, very important. Then we of course did some practice. Many of you did calculated that, and I know that if you have done the same, you will remember the formula. Then we went to covariance. So if you all remember covariance, we calculate between two variables. Okay, so covariance tell us that how change in one variable is causing an effect in another variable. Again, very important concept. We will be doing that a lot. Not exactly covariance, but how two variables basically have a, I would say, relation with each other. Okay, I also, if I remember right, I showed you the iris data set and showed you the example as well, right? Can I get a quick yes if you all remember the practical as well for what we did here? Great. So when we found covariance, the only issue we have is that it is not bounded. Like there is no, I would say, value which tell us that how good or bad is it, or how if we can compare it with other covariances. Okay. So if you remember, let's say I gave an example as well. If say covariance of A and B is equals to 1000, covariance of say A and C is equals to, let's say, 50,000, then I can still not take an answer that okay what will my covariance of B and C will be. Okay, how much it will be there, whether they will all overall be correlated and everything, that idea I don't get. Okay, Now moving forward, we saw these limitations and then we actually got to know about correlations. Yes, Divya, exactly. We solved a lot of problems. I made sure that practical with respect to code, exercises and everything is there in this course. So you all remember that, okay, if and when you will have to do your revision, you can see those questions and you will be able to have a quick, I would say, fall back upon a revision plan so that you can just quickly understood everything. Okay. Then we saw about correlation. We saw its formula as well. Okay. We in correlation, what happened is that these x and your y, okay, for two variables for which we are calculating this correlation, this is bounded by your this and this. Okay. This thing is exactly, yeah, this thing is very important to understand. Correlation we will actually be calculating a lot. We will be making correlations graph, correlation metrics, okay, correlation heat map. I will show you the everything in the case study as well. So your graph will something be like this. Let's say if let me take A, B, C, D. I think I showed the same in the iris data set as well, but it was with respect to value. Okay. Then we see the heat map kind of that, okay, where the values normally A and A will of course be highly correlated. Okay. Then your, let's say, B and A might be a little bit more correlated. So if value around 0.7, it will be filled. If it is 0.1, then it will be very lighter. Okay. So something like that we will see when we will do our practicals. But it is very important to remember that what correlation basically happens. So I have covered everything in your case study. I have made sure that everything which we are learning and extra thing as well, I have covered in our case study. Okay. So we will be doing that. No issues with respect to that. This was one of the then very easy examples which we took. Okay. So that you all can calculate the same. Then again, now very important concepts, types of graph distribution, basically in our this overall this thing, statistics which we normally deal with. Okay, normal, then your bell-shaped, and your Gaussian. Okay, so I also showed all these things with you with respect to I would say code, where we selected inbuilt function which can provide us with those distribution through which we can make this overall, I would say, graph. I also showed that for a log normal distribution, when we took the log, we were getting a very close to normal graph, which is expected because that is what log normal distribution overall is. Okay. So I remember each and every one of you remember these graphs. I will just quickly draw so that you remember the same. So your normal or bell-shaped curve is something like this. Okay. Log normal is normally skewed at one end. Okay. But the property is still there that if you take a log, so it is not that if your normal distribution is skewed, it will become log normal. No, it is if you will take a log, then everything will basically come around here. Then your Bernoulli one was very easy. Okay, something like this was happening. So it was for your categorical variables. My bad. 1 second. Yeah, something like this was there in your Bernoulli. Okay, and overall your power law distribution, again very important. I personally feel this as one of the main thing which basically which is applicable everywhere. 20-80 rule, 80-20 rule, all these things are very important. So I hope each and every one of you remember these graphs as well. Let us now move forward. I showed you with that thing also with the code. So people who are joining new, please refer to the last recording which we have done, as well as go to the resource section and see exactly all the codes and basically PPTs and codes which I have provided. So that would be very helpful. Okay. Then we learned a little bit about our hypothesis testing. We saw that what exactly hypothesis is, and we learned about your null hypothesis and your alternate hypothesis. The best way to, which personally feel is the best way to just remember about it is if your car has, let's say, stopped suddenly, then the very first thing which you check, okay, is the petrol, because that is your null hypothesis, which is the generic thing. In a similar way, what we do for our population and sample, whenever we take a sample out of our population, we assume that this sample is representative of our population. And then we have few tests in our hypothesis testing which tell us if a particular hypothesis is true or the other one is true. And based on that, we basically select that if we can move with our experiment or not. Now, what happens if your population sample is not representative of your population? Then we have an issue, right? Any result which we will be making that won't overall basically be applicable to your population, and hence your all the effort will fail. So of course, very important, I would say, use case, very important concepts. So this all has to be very clearly understood. Okay. Then let us move forward. We saw a few ways: ANOVA, chi-square, t-test, f-test, and A/B testing. These are few things to basically validate our hypothesis. Then let us move forward. Chi-square, someone asked that as well. So chi-square is used to check independence between two variables. Okay, so for two categorical variables, normally it is applied. Okay, from a single population, so they should also belong to a single population. Okay, and which basically help us that if there is significant association. Now, what I mean by significant association, if let's say one variable has an effect on other variable. Okay, so those things are basically checked via chi-square test. We will see examples as well, so should be fine. Like we will basically make sure that I have made sure that I will be covering another community class where we will be discussing in detail about all the your hypothesis tests. Okay. Then your next is ANOVA. So ANOVA, what you can normally think of is that let's say there are different kind of your samples. Okay, let's say something like this. So what we assume is that samples. So these are your distribution. Okay, let's say this is the first one, this is the second one, this is the third one, this is the fourth one. This is your new. So we assume that new one equal to new 2. So it is used for I would say more than one samples as well. And we assume that their mean is equal. Okay, so they are all representative of the population. Okay, and based on then we basically check. So the very good example of that can be, let's say a school is having students who are underweight. Okay, so we feel that students are underweight, the mean weight is this, the standard deviation is this, and you take 3 groups. Okay, now the 3 groups which you have taken, the mean is coming out to be this with let's say this much confidence interval. So this kind of problems are normally solved by your ANOVA testing methodology. Okay, great. Let us quickly move forward. So these were some problems which we basically deal with. Okay, if anyone has any issue, I'm just giving a quick revision so that we are on track to start today's topic, because today we will be covering with all the easiest I would say things, and tomorrow we should be good to then start with the case study. Okay, so yeah, these are basically your all the problem which normally a data scientist has to deal with. I'm not talking specifically about ML or any other engineer, but yeah, ML or AI engineer also has to basically the problem in a crux become that. So a very important thing is to of course always keep the thing simple. So in the crux, a person who is doing let's say an AI engineer, he's also trying to optimize on something, the response and everything. Okay, so that thing is very important. Then let us move forward. Then CRISP-DM methodology, of course, discuss this a lot of time. Won't be now actually giving you an idea on the same, but very important methodology. Anything which you are doing, I actually make sure that any project which I am doing, it fits this methodology. Okay, that is very important. Then machine learning applied to your big data. Then big data has a lots of other concepts as well. Your Spark comes into picture, Hadoop comes into picture, then your Kafka, all these things. Now, because we are becoming, data is getting more and more generated, so of course we are becoming more and more sophisticated with the ways we can handle the same. Okay. Then let us actually, if this thing's all is clear, then we actually should be good. Everyone else, please let me know if all things are clear till now, what all we have discussed, just a basic idea on what all we handle. So we'll be now discussing, starting with today's class. So predictive analysis. Okay, and these are all the few things which we will be covering today. I think we have covered on the missing and outlier analysis, but I will like to give a quick review on that as well, because I think if I remember, 1 second. Yeah, so last we checked, basically I explained about the outlier analysis and everything, but that was still just this quartile and all these calculation, the maths part of that was done. So we'll explain on the same. Okay. Can I get a quick yes or no if everything is clear, each and everyone? Great. So let us move forward. Very first, we covered about the missing values, why we get the missing values, and if we have to ignore or compute the same. We discussed statistical as well as ML model on the same. If you remember, mean, median, and mode we discussed, and then as well we discussed about the k-NN imputation. I give you an idea on what exactly k-NN imputation is and how it worked. Basically, a very basic idea. Of course, there is maths and everything behind it, but we will see that as well. Okay. So I hope that thing was clear to each and every one of you. And moving forward, we saw that okay, impute the missing value. We have the central tendencies measures, mean and median, and similarly we have distance weight, which is KNN imputation. Normally we saw an example, so I also show you the full process on how we do that. I think it is on the next slide. Then there is statistical imputation KNN. Yeah, this is the whole process which I am telling about. So what we do is, let's say if we have the full data, okay, say we have the missing values, few of the missing values here, okay. So let us take the green approach which we will follow, and of course this is very important from interview point of view as well, okay. Let's say we just take some subset of data, okay, the filled data, which is this subset. Now what will happen is that once you have this subset of the data with you, basically, then we will ourselves, okay, make one missing value here, okay, one or multiple we can do, that should be fine. Then we basically calculate this missing value with different process which we have, okay. It can be as easy as just mean, it can be as easy as just you are applying same value to everything, okay. Then once we have these values, let's say 1, 2, 3, 4, 5, like there are lots of ways, so you can do check with each and every way. And let's say we have our truth value which we have basically removed. We compare truth value and all the values which you have calculated. Then based on that, what the value I am getting, what is the value which I am getting, okay, and what was the truth value, we basically make sure and finalize what overall I would say algorithm I have to go with. Now this can actually be extended where we are making sure that we are taking multiple missing values, okay, or we are basically doing this for different columns where the missing value is present, as well as I would say more than one missing values at a single time, okay. So it can very well happen that we are taking two values as missing at a single time. Or what can happen is that we first took one missing value, we calculated it, then we did the same for other missing value, okay. But the main point here is to understand the whole process. You cannot just directly say that this process will be better or this process will be better, okay. I hope this thing is clear to each and every one of you. Can I get a quick yes or no if this thing is clear or not? Let me meanwhile also try to open the code so that you get a good refresher. Okay, I think my Jupyter lab has gone down. Let me relaunch it. No, I think we can just go away with the update as of now. Great. So I see this has started. Okay, starts community. This is the one I'm talking about. So if each and every one of you remember, we did this exercise. So our true value must be present somewhere here. 5.1 was the value. So the value which you're calculating, 5.8 we got in one thing, 5.8 we got, and via the imputed distance one, we got the 5.0. Okay. So I hope this thing is you all remember and this thing is clear. Now let us move forward. If everything is clear here. Okay. Then we discussed all about your outliers. Okay. What exactly outlier is and where it lies. So this is actually what we were on the last class. Then we discussed that, okay, what exactly is an outlier, how they can occur and everything. Then what are the different causes how outliers can occur. Okay. Then how mean basically is affected by outliers and medium is not. Okay. That's a very good, I would say, insight, because of which we were then able to then go to your all these things, right? The IQR, interquartile range, all these things. I hope each and every one of you remember around the same as well. Okay. Then there are percentile and quartiles are basically one of the methods by which we create the box plot. So that is a very important, I would say, measure. Let me just quickly revise the same. Can I get a quick yes or no in the comments if everyone remembers what all we did? We did spend a very good time on the same, right? We did a problem on there as well and everything. Okay, everyone, I hope you remember what all we have done there. So that is very important before we move forward. Yes, exactly. Divya. So 5 number summary we learned about. Then we saw that how we can calculate. We can make graph like this. Okay, when we how we can make graph like this, where this is minimum, maximum, and everything, and basically then our IQR, let's say outliers can basically be seen there. Okay, so I hope each and everyone, if you remember these things. Yes, so I also covered. I also covered one thing in very depth, so that might be a lot useful. So we discussed the difference between percentage and percentile, very important concepts. Then we went to our quartiles. Okay, what exactly are quartiles? And we saw that how we can calculate Q1, Q2, Q3. Okay, how Q3 minus Q1 is your IQR, interquartile range. Okay, so again, all these things are very, very important. Okay, so please remember them for any exam point of view, for your, I would say, overall any competitive exam, for your interviews. All these things are very important. Interview will very well give you this, I would say, overall problem where he can ask you to calculate all these things on the spot. Okay, so normally you might not be required, but it is very important to basically understand and remember the same. Okay, great. If all is clear there, just let me remove this thing. We have done this thing via example and everything, so let us move forward. Okay, so normalization or feature scaling, this is our next topic, each and everyone. This is actually the new topic which we will be starting. Okay, so let us see what exactly happens. First, let us see that why we might be needing this. Okay, say you have some data where age is present and income is present. Okay, now also think about from either a child perspective or a machine learning perspective, who doesn't have an idea what exactly age or your income is. Okay, age will of course be, I would say, in the number, uh, say 25, then say 27, 29, say 31, and 35. Income we can take, say per month income, let us take 50K, then somewhere it can be say 29K, it might be 55K, at 31 let's say it is 90K, and at 35 say it is 99K. So what our model think, and what basically even a person would think, is that this variable overall overpowers your age variable by a lot, right? Because the values are very high there in the income range, the values are very high. Anything which you will calculate, the distance, the mean, median, everything will be very heavy, very high value for your particular thing. So let's say if you have a linear model or any model where based on the absolute values things are happening, so your mean, okay, what happened here? 1 second. I think I by mistake. Okay, I think we lost all our drawings. Yeah. Great. Good. We had this overall income. I hope this is clear. Not sure how this happened, but anyway. Yeah. So we have this age, we have this income. Okay. So for any model or anything, what will happen is that, let's say age mean is around 27, but the mean for your income can be as high as, let's say, 45,000. Okay. Now anything which you will calculate, this is very insignificant as compared to your income. Okay. I hope this thing is clear to each and every one of you, why this particular problem exists and why we have to solve that. Because if our variables are not in the same scale, then it is a lot difficult for our model even to make sense. It will of course think that this overall this value has a very high effect on everything, right? A lot of variance can be in this value. Income can start from 30,000 and can go to, let's say, 1 lakh, but your age can go from, let's say, maybe around 20 to just 70. Okay, so not a lot of variance is there. Can I get a yes or no in the comments if you are understanding why the problem which problem we have to face with the same? And there is one very important thing. This is only valid for your numerical data. It is not used on your categorical data for sure. So only numerical or continuous variables. Can you give me some more examples in the comment where otherwise also we face issues like this? Let's say where two variables in a particular data set, they are having a lot of variance between their values. Any example from day to day or anything? I think we should be able to think of one other example, something maybe. Where we might have to do this thing, all these, I would say, feature engineering. Okay, can I get another example? I'm giving you an example of age and this, right? So we must have another example, I believe. Purchase, number of item and cost of item. Okay, the way saying purchase, number of item will of course be less, cost of item would be more. So that is another good example. Number of item, cost of item. Let me clear all this. Maybe your, I would say, HbA1c value and say your this is your hemoglobin value and your sugar diabetes value is another example. So this normally range from 12 rather normally 10 to 16, and your sugar or diabetes values can basically range from 100 to 300. Very I would say idea where like very common in your medical use cases. Okay, so the way your example is also right, but it's just that it's still money is something. I want to show you an example where let's say money is not there. Okay, then if we are talking about money, one more can be number of bedrooms in a house and price. Okay, of course, because the norm thing is that price basically takes overall leap. Okay, few currencies are there. Okay, that's why we normally age and health is there, Raghunath, for sure. Then basically few currencies conversion are there, right? So in many countries the currency is very high. Okay, we want them that they are on the same scale. Okay, one such country I know is Indonesia, where notes of 1 lakh is very common. Okay, so the 1 lakh note in Indian currency is just 5, I think 40 or 30 somewhere around here, and for dollar it might be even less, like $7 to $8 something. Okay, so we also standardize each one of them, right? Majorly whatever we are doing with the US currency, where what happen whenever we are doing some international thing or anything, we want everything in US dollars, right? It happens a lot in the international, at an international level. Let's say where we decide that okay, what is the price of oil today, so it is quoted in dollars, maybe because that's a kind of a global currency. Okay, so that is also normalization being done to your data. Okay, that thing is very important to understand. I hope this thing is clear to each and every one of you. So normalization also brings, let me remove this, all your variables into proportion with each other. So all your variables into proportion with each other. Okay, so very important to understand this thing. That's why I've written it. That what happens is that then after seeing a particular value, you can say that if this value is, I would say, overall comparable, they make sure that they are in the same proportion. Okay, normally that is 0 to 1. We will see different ways we can do the same. Let me remove this here. Let us move forward. So see, now this is how can we do the scaling. Okay, so if let's say this is your age, let us take the age variable for now. What we will do is from a value which we take, we will minus the min value, then max minus min. Okay, so for this example, 65 is our max, 24 is our min, and then you will see that 24 minus 24, this will happen. So this will of course be 0. right? And it will also be large because, okay, so just let me go to the whiteboard to explain this thing. Okay, so let's say we have this age with us, right? 24, 26, 28, and say 30. Then we also have, let us take this variable only for now, okay? So our formula for doing scaling is, which we learned just now, is that x new, I would rather say x scale new, okay? So the value which I will change our age variable with is that it is the value which we have minus minimum upon max minus minimum. Now what will happen when this value is minimum? When x is minimum altogether, it will become minimum minus minimum upon max minus minimum. So the numerator will become 0 and this will be 0. I hope each and every one of you understand this. Similarly, when your x max will be there, max minus min upon max minus min, and this will become 1 because both are equal. I hope you understood that why your scaling or normalization stays between 0 to 1. Can I get a quick yes or no if everything is clear? Or if anyone has any issue, please let me know as well. Also, one question for each and every one of you: is this sensitive to your outliers or not? Is the scaling or normalization sensitive to outliers or not? Please let me know answer to both the questions if all is clear or not. And the second one is that, is your normalization thing sensitive to outliers or not? Okay, Divya is saying sensitive. Anyone else? What do you feel or what do you think about the same? Is it sensible? Is it basically sensitive or not? And I hope each and everyone is also able to understand this thing, what I have just explained. Okay, let me know in the comments if all is clear, everything is fine. So let us see if it will be sensitive or not. Meanwhile, let me know. See, what if someone is at 80 here? Okay, then because we are using this max value, of course, this makes in the formula max, this will basically have an effect and it will overall take your, I would say, values a lot. So what will happen is 0 to, let's say, 0.5, a lot of values might be there, and then 0.5 to this one, only one single value is there. Okay, so for sure your this thing is sensitive to outliers, but we now know that how we can handle outliers. Okay, Karthik is saying, can you explain normalization again? Okay, no worries, Karthik. Okay, see. So Karthik, what happened is, let me actually take it with an example altogether and then try to explain you. What happened is that, let's say whenever we are training a machine learning model or we are doing any kind of modeling or trying to understand the data, think of that as a perspective from a child, okay, who doesn't know what age is, what income is, or anything. Okay, he just maybe have a basic idea about numbers. He know that, okay, this number is greater than or smaller than a particular number. Okay, I hope this thing is clear. Now what happened is that, let's say when our machine learning model, okay, it is presented with variables who are in different ranges. Okay, so for example, age and your income is a very good example to explain and understand this thing. But let's say your age and income is there, right? When your variables get this kind of input, okay, then of course your age will be around, say it can range around 25, then 35, 40, 45, even 50, let's say, for example. Okay, but your income on the other hand can range from, let's say, 50k. Okay, it can be around 59k, say 65k, Here, let's say it is around 90K, and just to make it all equal, it is 99K. Okay. Karthik, I hope till now everything is clear. What I have, like I've just taken a data set and we will be basically doing and learning something from this data set. I hope this thing is clear. Can you explain the same? Can you just let me know in the comment if everything is clear here? Okay, great. So now what happened is that our model, when it normally sees these values, it will be calculating your mean, median, or any other thing, and also doing some other, I would say, let me take a red pen. Yeah. And anytime it does basically any try to understand the patterns and everything. What happen is that this variable, your income variable, it will completely overshadow your, let's say, age variable. Okay. Let's say if we are calculating your overall, say, covariance between these variables, age won't even have a play, right? If you will subtract 50K, or let's say if we are calculating distance even between those two variables, see, this will be negligible with respect to this thing, right? Is this thing clear? Let me explain you with this with a very important another example. Okay, so let's say till ninth, what happened is that there are few schools where students are getting, let's say this is the case. Let me take another example. This should be very easy to understand. Okay, let's say this is school A and this is school B. Okay, in ninth, what can happen via, like in this particular school or everything, what can happen is that, let's say students are getting 99, okay, 95, all these things and everything. Okay, but in this school it may happen that in ninth class students are getting, let's say, at an average 88, okay, 92, something like this. But normally what happen is that till ninth, the checking the result and everything is not standardized. We see now that it is not standardized. Okay, that's why we have these standardized tests, like CAT is there, your GMAT is there, SAT is there. All these have your standardized, I think, test, something like, if I remember the full form. But anyway, these in this particular schools and everything, what will happen is that they are not comparable as of now. But when in 10th, let's say when we have boards in 10th or 12th, okay, when your checking becomes centralized, when it is standardized, where now the school doesn't have any role to play, okay, then is when we can actually compare these marks with each other, right? Then is where we can compare that, okay, who is better, who is not. This is a very, I would say, big thing, right? In ICSE versus CBSE board, it always happened. So in terms of absolute percentage, CBSE normally is very lenient. I won't say lenient exactly. The number which basically CBSE student gets, they are pretty high. Okay, so it may happen that a person who is getting your, let's say, 78% here might be a topper here, but let's say 91% one, okay, he is not a topper. Okay, but if we standardize these data sets, so that is why standardized exams are there. We have to come up with standardized techniques. Okay, we have to make sure that everything is standardized so that we can compare them. The same thing is an issue for our machine learning models, or whenever we are doing any data science. Okay, if let's say you don't know about a particular variable and is ranging in, let's say, crores or anything, okay, maybe country's GDP, okay, and let's say we have the age of country, then say the age of country, basically when it, let's say, got independence or got recognized or something like this, let's say one is age of country and 53 trillion is, let's say, its GBT, let's say 5.3 trillion, 53 trillion is a lot. Anyway, then let's say 2 is there, it is basically, let's say, 5.1. Then let's say company might be a lot old, let's say somewhere around 80 years old, and then its overall, I would say, GDP is coming out to be, say, 75 trillion or something. Then these are not comparable with each other. Okay, we need to come up with some standardized formula for the same. Okay, so the same problem, of course, we face a lot in ML models, and that's why it is very highly suggested, and it is actually one of the steps which we always do, that for us to standardize all our values. Okay, that thing is very, very important for us. Okay, in a similar way, we have some techniques. So I showed you the formula as well in the first slide. So see, Karthik, this is one of the formula which we use for standardizing. Okay, so for this particular value, it will become 0. This will become 1. And let us calculate this one. So 30 minus 24 upon 80 minus 24. Let me know in the comments, everyone, what this value will be. 56, I'm not right. So around 3 by 28. Okay, so this should ideally be somewhere around, I think, 0.1 something, basically 28 by something, right? Yeah. So yeah, 0.1 something, this value will come. Okay. Let me calculate this quickly so that you have an idea on the same. 0.107. Okay. So we will see all this in our case study as well, why we do it and everything. 0.107, somewhere this value is coming. So we did this for 0.107. Okay. So yeah, 0.10, Praveen, thanks a lot. So yeah, this is actually the way, Karthik. So what happened is that it is sensitive to outliers, but we know how to handle outliers and everything. Okay, in the overall like knowledge discovery process, basically in the knowledge discovery is where we are getting the values and everything. Okay, all the speech processing steps, everything which you are doing to your data before feeding it to your model plays a very important role. Okay, we have to make sure that the data which we are presenting to our model, or let's say the way we are getting the insights from our model from our data, that is very, very important. Okay, now normalization is actually done. So normalization is done to make sure that all our variables and basically all our overall predictors, they should have, they are all in the same range, they are having the same weightage and everything in your I would say in your prediction, or let's say regression, or anything which you're doing on that note. So all your variables, basically if they are on the same scale, then they have the same effect. Okay, that thing is very, very important to understand. We also make sure that this happens so that our one particular variable will not, one or let's say some variables will not dominate in our data set. Okay, if the values is basically very high for few data set, then they will of course dominate a lot, right? I hope this thing is clear, each and every one of you. No worries, Karthik. Everyone else, can I get a quick yes or no if everything is clear till now? Great. So just one more important thing to remember, this all is just done to your 1 second. This all is just done to your numerical variables. And this thing should also be clear as well, that we can only do this to numerical variables, not categorical. Numerical or your continuous variables. Okay. So this is one way we normalize, or I would say we basically make our variables fall in the same range. Now let us come to other, basically another, I would say, metric, that is your standardization or z-score. Okay. So this is actually the formula for your standardization or z-score. Okay. Your x is the value, your nu is the mean, and your sigma is the standard deviation. Okay. I hope everyone this thing is clear as well. What the formula is now, standardization works better. It is also known as z-score, as we have written. Standardization works better when your data is normally distributed. Okay. So when we are getting a bell-shaped kind of a curve, let's say something like this. So we just basically take a smaller version of this curve and we calculate that, okay, if this is the mean, how much my values are basically away from mean, how much standard deviation. So this is how much away, subtract, divided by standard deviation. Okay, I hope this thing is clear as well. So your Z represents basically the difference between your raw value, okay, and your population mean in terms of standard deviation. I will repeat it again. This z-score which we are calculating, it represents the difference between, let me take a green pen, your this raw value or your data point with respect to population mean in terms of standard deviation. In terms of standard deviation. I hope this thing is clear to each and every one of you as well. tells you how much your value is away from your population mean with respect to standard deviation. Okay. So this is just one, I would say, how it changes. Okay. So see, let's say this is normally a graph which we get. Okay. So this is your X overall. This is your full X. So earlier your sigma is, let's say, 10 here, your nu is 100, this is 110 nu, this is your mean. This whole will get transformed like this. So your nu is 0 and your sigma becomes 1 here. Okay, so here also we have basically done shrinking and everything. Okay, sure, Divya. So we discussed about the normalization technique first. Okay, so it is normally said that okay, normalization and standardization is basically ways by which we are able to do feature scaling on our variables. Why feature scaling is required? That is very, I think that I have covered in a lot of details via examples that we have different variables who can be in different ranges. Based on those ranges, if let's say one particular variable can dominate in your ML model, in your statistical model, to avoid that particular thing, that is how why we do feature scaling on our variables. Okay, I hope this thing is clear to you. Z score, I'm coming, Divya. So normalization is something then we saw the very first technique. The second technique is standardization or Z score, which we normally calculate when our data is normally distributed. Okay, understand from this example, Divya, majorly. So what we will do is we will take each one of these values and we will transform that. Let's say X is the value, subtract the mean from that and divide by your sigma. Okay, your standard deviation. So on that way, Divya, what happened is that we will be getting our values in the form. So this is your Z score. They will tell us how far our particular value is from the mean in terms of your standard deviation. So I remember, if you remember, you saw these kind of graphs as well, right? So we saw that, okay, how this is 65. I think it was, yeah, then 95. Then this was 99.7. So we discussed that rule as well, right? 99.7 for 3. So I hope you remember the same way we discussed that rule as well. So to make sure that, see, now our values we want in terms of mean and standard deviation. Okay, that overall gives us a benefit instead of, let's say, our values are. So here, if you will see, okay, the nu is 100, the mean value can be anywhere between that. So we try to basically transform that such that we are able to get that, okay, how away they are from your mean. Okay, and in terms of standard deviation. So yes, exactly, the way that was the empirical rule. Okay. So these are just few things which we normally do to scale our data, I would say. Everyone understood? Please let me know in the comments if everything is clear or if any doubts are there. Everyone else, meanwhile? Great. Just give me a second. My bad. Yeah, I hope my would be. The Z score, yeah, we use the population mean on that. Okay. So basically, we see the whole population. So basically, population as in like what all the data points which we have. So we'll be using them and then doing the Z score transformation. Okay. Standardization we do like that. Okay. Now let us discuss a little bit about sampling techniques. Okay, if everything is clear till then. So this is of course very important, I would say, particular use case. Okay. It's also part of your pre-processing. So sampling, part of your pre-processing. Pre-processing, I mean before we basically send data to any model or before we work on all these of our model. So ideally, whenever you get any data, we have to take a sample out of it, because normally what happens is that data is very huge. Okay, so if we take an example of Amazon or Flipkart from our use case, okay, let us take few examples. You won't be working on all the data of Amazon. Okay, Amazon, it will be a very huge data. For your particular use case, you might be taking a sample. Let's say if you want to increase sales of, let's say if you are a data science scientist at Amazon tomorrow, okay, you might be given the task where you have to increase the sales of, uh, let's say, products of Amazon at in Bangalore, okay, and maybe let's say a particular location. So the obvious thing which you will say is that, hey, let's say this is my Bangalore area, this is what I'm concerned with. Let me get all the previous orders, or maybe let's say the last 3 years of order. Okay, so this is some sample which you have taken from this all the data, right? I hope this thing is clear. Similarly, let's say if you are a data scientist as, let's say, some hospitality company like Oyo, Fab Hotels, or let's say Marriott or anything, then you might be given the choice that, okay, hey, you have to increase the conversion for these properties. Okay, let's say some properties are there. Okay, maybe they are at some position, let's say they are around your religious places or they're at tourist attractions, then you have to increase their conversion. What I mean by conversion, that people are booking them. So maybe you will see that, okay, what is the overall, I would say, prices, okay, of people who book the around the property on my website, or let's say what is the prices, okay, around this area where people are booking, or let's say in my population what is happening. So you will end up taking a lot of samples from your data always. Okay, this happens always because of two reasons: because maybe your problem is constrained, or second is because of computational resource issues. Okay, so we cannot just always work on a lot of data. Data might not, and whole data might not even be representative of our population. Okay, for example, let's say Amazon initially when it would have started 1 year, maybe the order was not very good. Okay, people were maybe ordering less, but then it picked up and everything, and then basically everything, the order basically increased and everything went fine. Okay, so this thing is very important to understand, that sampling is actually done normally now, because a lot of data is getting generated. It is done a lot. Earlier I would say it was a little optional because the data was still in the, I would say, volume which can be handled. But now the overall thing which is happening is that data is getting a lot generated. Overall aim of any sample is that it should be representative of your population. So for this, of course, we have hypothesis testing as well, which I will be covering a lot in detail. But this for sure is your overall aim of any sample which you are taking. If tomorrow we have to do exit polls, okay, and let's say you are not taking, let's say, people from each, I would say, area, religion, or other I would say diversity, you are not covering that, then your result will not be right. Similarly, let's say if I started to feel a little unwell today, and you are taking my blood somehow from the blood report you are generating from last night, or let's say yesterday's blood sample, that is also not right. Okay, so all this thing is very important, that your sample. So this is normally drawn, right? Actually, this is drawn like a circle. So let me draw it like a circle only. Okay, nice. Somehow the color changed. Pretty good. So this is your sample, and it should be representative of your population. That thing is very important to understand. That is, I think, the most, uh, like the place where student face the most issue, that it doesn't happen. Okay, so this thing is very important to understand. I hope each and every one of you are getting the same. Okay. Now there are different methods via which we can collect sample from our data. Okay, so these are all the sampling techniques only which we will be discussing. Okay, so I've written all these things here as well. The aim of any sample is to represent the characteristics of the whole population. There are different methods to generate a sample. Okay, so we take our, I would say, samples via different ways. Okay, so all this thing is very important to understand. Okay, we have taken the example as well. Let me know if anything is not clear meanwhile in the comments or anything. Overall on the sample idea basically. Everyone can get a quick yes or thumbs up if everything is clear, that what exactly sample is and everything. We'll be coming to that, Divya. That is like which thing which we'll discuss. First, let me know if what exactly sample is, that is clear. Okay. Sampling, I would say, like the way I remember, it's a very shortcut method to basically get all the inferences about your whole population. We don't take a lot of data, it increases our time and everything. Okay. So for example, even chat GPT, like it has been trained, but it will be trained on all the website data and everything which is normally available. Okay. Not, I would say, few of the data even they would have left, because if they try to train on all the data which might not even be relevant, like companies report and everything, which is confidential as well. So we have to make sure that where we are able to cut the data, we are able to make sure that we are just taking relevant data. That thing is very important. Relevancy becomes very important in that, and of course, then making sure that your data which you are selecting that is representative of the whole population, that is also very important. Okay. Great. Let us move a little forward with this thing. Then let us actually cover all the sampling techniques which we have. So the very first one is simple random sampling. Okay, it is like very easy. It's a random. This word is there. Random. Okay. Let me take an example here. Let's say this is our population. Say 5 people are there. So I have to select one out of this. What is the probability? For each of these 5, what is the probability that I will be able to select this person or not? Like, what is the probability if I want to select one person out of these 5%? It should ideally be 1 by 5. The reason? Because in my simple random sampling, it is the purest form of sampling. Okay. Here, overall, what is happening is that each of my data point, each and every of my data point, it has equal chances of getting selected. Okay. Very easy to understand. Of course, it is not biased as well. It is not at all biased, right? Because everyone has equal chance. Okay. It can be kind of like a lucky draw where you have the chits. Okay. You are not basically any chit is not having, hopefully, any chit is not having any, I would say, bias or any, I would say, more chances of getting selected. So the way lucky draw happen, that is a very good example of your this sampling. Let me draw it like this. So what normally happen in your lucky draw is that we have a box like this. This is the chit, and in your box, these chits are present, right? So each one of your, let's say, chips are present. Now I hope you remember that each chit has an equal chance of getting selected, right? There are no overall, I would say, uh, bias towards any chit. Okay, anyone who will come, they will just select a particular chit and that they would be done with the same. Okay. So examples is the lucky draw. One example is selecting, let's say, 5 out of 10% randomly. Okay, can anyone tell me any other example in the real life? Other example of this random sampling? Any other example which you can think in your life, like okay, where we do random sampling? There should be a lot. Random sampling, I think, is the most common one which we do in our real life as well. Like randomly, we are just selecting anything. If you have any, Praveen, any example which you guys can think of for a random sampling? Let's say in an event it happens when we have to select randomly someone, right? And if we go on any event in the mall, then that is happening. Okay, they ask us to basically raise our hand and randomly someone selects the same, right? That is one of the use case when it happens. Any other example? Please let me know once you think of some examples. But meanwhile, conducting random surveys, yes, we need, that is also one case where we are randomly selecting it. Now let us see our how we will be doing this on data, because it is also very important to understand. Say this is our data which we have with us. There will be rows. So there are 10 rows. And even say there is a label also attached. Okay, say yes, no, 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 and all are yes. Now what will happen is, so let's say there are 7 yes and 3 no's. What can happen is when you do random sampling, each of your data set, each of your data point, they have an equal chance of getting selected. Equal chance of getting selected. What I mean by that, each one of these rows have 1 by 10 chance of getting selected. So it may happen that when you select 3, you can get some data like this. Then it can very well happen that you can get 5 yes, 0 no's. It can also very well happen that you are getting all the no's. Or let's say any combination which one can make of. Okay. It is used a lot in doing your train test split as well. So when we do, so normally in our data, what we do is that we divide our data. 80%, let's say we will train, and on 20% we will do our testing, right? So random sampling is used a lot in this. Let me show you that via basically on the, we just sampling skykit sklearn. See, so this sample without replacement. Without replacement mean we won't be replacing and everything. There is train test splits. This is a function which is used a lot. I think you all will be aware of this function, right? Where we provide train test splits, test size. Okay. Then train size, these are few things. Then random state is normally done to make sure that we can have a constant randomness every time. Okay. Then shuffle and everything. But there is one very important, I would say, application which is stratify none. Okay. So let us, if not none, data is split into stratified fashion using this as class label. So we will learn about this a lot as well. But meanwhile, let us go back. And you will see one disadvantage of, I would say, simple random sampling here, which is what if this kind of a case is coming? Because each one of my values is basically having I would say, we have already seen the advantage. Advantage is that it is not biased. Everyone has equal chance. Okay, it is used a lot in your 80-20, all these kind of a thing. Divya saying for visa process or sponsorship. Yes, Divya, that also basically happens. I have a little less idea on that, but yeah, I think in the USA, the way they do for H1 and H1B visa, they do that basically on a random note only. Okay, hopefully that is random, but yeah. So we have already seen the positive for our random sampling. Now coming to a few negatives, it can basically lead to our data which is a poor representation of say our population. Example, I hope you can see the example here, right? Are you able to see the example why this is a poor representation? Can anyone let me know in the comments why this is a poor representation? Your 5 Y and 0 no's. The reason for that is that here you are not getting any no. So someone will think that all the data is basically having yes only. Okay, we are not dealing with no kind of a data set. So this can basically give your, I would say, give rise to a data set which is not representative. So for that, we of course have different techniques which you will see, but before that, it is unbiased. So that what happens is that let's say even if your data is, okay, let us take an example again here. if your data is such like it has a lot of one class which is basically overpowering the other, let's say 95% one class is there and 5%, let's say fraud and non-fraud data, right? So 95% of your data is non-fraud and 5% of data is fraud. Now, because all the data points here have the equal chance, okay, it may happen that your test sample which you will take will be very, I would say, heavily based on your non-fraud data. Okay. So, because of that simple random sampling, sometime it can happen that if your data is imbalanced, only that imbalance will basically get carried on your sample as well. Okay. So we might have to, someone will think that all the cases are non-fraud only. Okay, your model will basically never be saying that, okay, some fraud can happen. Okay, this thing is, I hope each and everyone you understand this thing. Can I get a quick yes or no? If this thing is clear, what are the disadvantage of your simple random sampling thing? Quick yes or no, everyone? If data is imbalanced, can't we use simple random sampling? No, Divya. So that is the case. If your data set is imbalanced altogether, then simple random sampling is not the best you can, I would say, you can use. The reason for that is that your imbalanceness will basically come into, okay, let us take an example. Okay, the same example which I took. Now, if let's say on this data, if you will try to not train your model, it will never basically come up with that thing, right? And ideally it will basically just show your data as it is completely, basically it is not having, I would say, any that value. Okay, but ideally even if your sample is to be representative of the population, it basically makes sure that those kind of overall let's say the ratio is even maintained. So let's say even 95:5 ratio is there, that is also maintained. Okay, so let us first, okay, let me actually tell you that how we go about ML model as well here. Okay, that will also be helpful. I think few people are not aware of the same. So we normally get our data, say we get our data. Okay, it can be any kind of a data and everything. So the way it happens for our ML model, the way we learn about them is, so just taking a little bit detour on this, so make sure that I'm explaining you. We select few data for our training and we basically have few data for our testing. Okay, this thing should be very easy to understand, no worries, I hope in that. Now what happens is on the training data, okay, this is done via sampling. Okay, and if I also explain you, actually let me take, just before taking the sample, yeah, okay, so before this we also do all these things which we are discussing, right? All these standardization, normalization, outlier analysis, missing value analysis, everything we basically understand here. So we basically do on our data to make sure that we are able to get the full insights of our data, your mean, median, mode, all the statistical approach which we have done. Okay, we do all these things to make sure that we are doing good with respect to our data selection the way we have done. Then what we do, this is basically your sampling step. We sample our data. Okay, it gets converted into your training and your test. So train and your test. Okay, this is how it happens. So we have the train and we have the test split. On this train, we basically normally train our model. So we have our machine learning model is there. Of course, we will check if our sample is representative of our population via, let's say, different techniques we have. Okay, all the hypothesis testing, which we discussed, then checking that on the imbalance and everything, all these things we will check. Then we basically train our model. So our ML model or DL or any other model, we will train our train our this on the data, and then we have the model. We will get basically this model. We will pass our test data to this model and get the predictions. Okay. Meanwhile, we will also save the actual predictions here. What were the actual predictions? And then we compare our actual with your predicted. say how good or bad our model has done. Now, one thing which you will see here is, which I mainly want to explain, is that overall all these things your error propagates. Okay, if you have done some mistake in, I would say, making your data like let's say standardization or normalization, you have not done. If let's say your data was like 95 yes and 5 no's, and all your training data is coming out, let's say, as 90, okay, say 80 is 20, so 80 yes, then your ML model will of course be very, I would say, not so good model. The reason is that it will feel that okay, all the ones are yes only, so it will predict yes only. Okay, I explained the same, I think, in the classification metric thing in my ML model ML class. Okay, just have a look on that as well. But here, if each and every one of you will explain is that if simple random sampling can fail here. I'm not saying that it is not a good, I would say, sampling technique. No, we do use this a lot. Okay, simple random sampling is used, I think, by far the most. But you have to also understand your data and then choose your how you are sampling based on that data. Okay, so one second, quickly just let me know this. Yeah. So your error basically propagates on these things. Then you have to. That's why I always say that the how much time you will spend on basically your data understanding, data cleaning, and all these things. That same information will go to your ML model. Okay, this thing is very important to understand. Okay, cool. Let us now see systematic sampling. So, how many of you are aware of systematic sampling? Can anyone tell me what exactly it is? One, two, three, four, five, six, seven. Let me draw 8 only here. Okay, can anyone let me know what exactly happens in systematic sampling? It is also known as your kth, I think kth selection technique or something. Let me explain by this example. Okay, so say 1, 2, 3, 4, 5, 6, 7, 8. So your n, the whole size is 8. Let's say I want 3 people out of this. So I will divide 3 by 8. Okay. Oh, sorry, my bad. I will actually divide your 8 by 3. So this is coming somewhere around, let's say, 2.66 something. Okay. So what I will now do is I will select, say, every third person out of it. Okay. So first, maybe I can start with this thing. One second. So let's say sorry, I will select every second person. Let us take this thing. I will select this. Then next two I will leave. I will select him. Next two I will leave and I will select him. Okay, so I will keep on going like this in this order till my sample size is complete. Okay, till I have selected the number of people I wanted to select. So of course I will be leaving people in a kth selection model. This is also known as kth selection technique. Kth selection technique. Okay, pretty easy to understand, but yeah, can anyone tell me what can be the case where this technique might fail, where this not might be the good technique to follow? So I will just repeat what all we done here. Okay, we first make sure that we have our population size, how much sample I need, although both the things we need. Then what we do is basically we calculate that okay, at what position I have to select the person, and then basically I start with the person and keep on selecting the person after that k, after leaving the k positions basically which I have calculated. Okay, so this is known as systematic sampling. Okay. Anyone, when can this fail? Systematic sampling. This is also done in a lot in schools and everyone, right? Like let's say we have to make two groups. So what we normally say is that uh, everyone on the third, let's say everyone who is on the third population, third number is basically coming to one thing. Okay, so we made say na that okay, everyone who is let's say at an even position, they will form one group. Let me take a red pen. Okay, or also I remember this happening a lot in your that exam setting plan and everything. Okay, that everyone who is having an odd let's say odd number, they will have their practical at this time, odd roll number, and even roll number will have your practical at this time, right? I hope this used to happen and you were able to understand the same. So the way this is not specifically biased. Where is the biasness coming? We are not biased for anything. If let's say when in school it used to happen that in a class, okay, teacher used to say that all the even people, all the even roll numbered people will have their let's say practical on in the morning, and all the odd will have their practical in the evening. Where is the bias coming here then? So it actually can be biased, okay, but that is when, let me remove all this, there is some hidden order. Okay, if it is not there, it is as good as your random sampling. If that hidden order is not there, setting k leaving in between data points are no Divya, so that's the case now. If you are sure, so if we are sure that all the intelligent students, they are not having odd roll number or even roll number, then it is as good as your simple random sampling. Okay, it just fails or it basically faces an issue just I would say when your data is having some hidden order which we are not aware of. Okay, so maybe let's say in some way in a restaurant or anything, we are selecting a very odd table. Okay, that we will serve every odd table first, but we have not made sure that we have done some, I would say, uh, case where we are just seating our favorite people on odd table. Okay, something like that. If we have not done, then overall this basically sampling technique, this doesn't have any effect. Okay, this is as good as your simple random sampling. I hope this thing is clear, Divya. You can think of the school example which we basically covered, the school roll number and everything example. That should be clear, I think, right? And I hope you are also able to know that when it will fail, right? Great. So the next one, I think most of you are aware, stratified sampling. Let me remove everything here. Your stratified sampling, I hope each and everyone has an idea on this. This is better than your random sampling. If your data is basically imbalanced or anything, what we do is we basically have our, okay, let's say this is yes and no. So we will be based on the category which we have present. Yes, Divya. So the systematic sampling, if your data set is having some hidden order in that, if it is having some hidden order, then there is an issue. Okay, then it will fail. So that thing is very, very important to understand. And the example can be that if let's say all the students who are say intelligent were given odd roll numbers in the starting, and then you are saying that hey, we will see the just the odd roll numbers result. Okay, let's just randomly select a sample where all the odd roll number students are we are selecting. Okay, So I hope this thing is clear. So stratified sampling actually get its name from stratum. Okay, let me remove this first to explain you how it came into being. So stratum is a group which shares at least one property with other members of the strata. So it is not that it is always to be done on your dependent variable or your result. Okay, you can also basically divide, let's say, on the basis of some other case and then basically choose the same. Members in the data. I hope this thing is clear, each and every one of you. What exactly strata is? Let me know if any issues are there or if everything is clear. So let us now see the process. What happened in your stratified sampling? Okay, it's pretty straightforward. We first make our strata. So strata I have already explained. So let's say if we are having males and females in our, let's say, group, right? So say 70% are males. So we will divide them into this way: 70% males and let's say 30 females. And now we will basically select from this group. Okay. So what the exact steps are that we will first divide our population into strata. Basically, we will see that, okay, on which we have to divide them. Second then is, okay, we do random sampling then, okay. Random, or let's say even your systematic sampling you can do from each strata. Now, where is it helpful? Where, let's say, there is some imbalance between your data. Okay, so the case where we saw that, let's say, 80-20 is there, 80-20 thing is there, 80 male, 20 female. And if, let's say, we want to select 20 people out of that, okay, so what we will do is we will basically make sure that we are first dividing them into strata and then selecting randomly from them. Okay, so that we can we can avoid basically having the case where all the males are there in my final, I would say, sample. Okay, I hope each and everyone this thing is clear. We just make sure that we are basically getting relevant strata and their actual representation as well. Okay, so here the actual representation of your male is like 8:2 is the ratio. Okay, so in our final, basically our final sample which we get, the ratio we will try to maintain. Okay, so let's say if I want to select 20 out of this 100, then my 16 can be male and my 4 will be female. 16 male, 4 female. I hope this thing is clear to each and every one of you as well. Pretty straightforward, easy thing. And we can, of course, use your this thing here. That should not be an issue. Your random sampling after we have divided the strata. Okay, everyone, give me a quick yes or no if everything is clear or not. How to identify property between data sets? So that is very easy. Like, see, in my data here, I had this gender thing. Okay, this was male, female. That is one of the cases where I have selected it. Okay, so it is as easy as making groups by a common property. So that property actually depends on what you are trying to basically. Let's say if you are trying to see the buying behavior of by different gender, then you will divide them into genders, right? So it is based on your use case. Let's say you are trying to understand buying behavior by your location or by your, let's say, region or pin code, then you will divide on the basis of pin code. Okay, so based on what property we are basically working on, and let's say you are doing some classification problem where you have some variables, okay, classification variable, let's say 3 variables are there, then you will divide on those variables. Similarly, let's say if you're working on the regression problem, then some houses are there who are, let's say, more than 10 cr, okay, if you are less between 5 cr to 10 cr, and let's say less than 5 cr, so these kind of categories which you can make and then divide the same, okay. So it is based on your particular use case, on what you are thinking and how it has to be done, okay. I hope this thing is clear to each and every one of you. Like, I have not gone a lot into definition. I just tried to basically explain the same to you intuitively. Okay. Everyone, can I get a quick yes if all thing is clear? Great. So now let us move to the next one. I hope stratified sampling is clear. Stratified sampling we will be doing a lot. Okay. Whenever we are doing classification problem, because we have our variable, the final prediction variable, which will basically tell us that okay, if it is imbalance or some cases there, then we will do your stratified sampling. It becomes very important. We also saw that in your train test split we have a stratify that, right? So let me show you this again. See, we have a stratify argument here. Okay. So in your stratify, what is happening? Data is split into stratified fashion. Okay, let us see the user guide in the official documentation as well. See, it is a lot about stratified sampling and k-fold and everything which is happening. So we can do the same thing. Okay. Great. Now let us go to the next one more type of a sampling which we normally done. Okay, this is cluster sampling. Okay, so what we normally ideally do in cluster sampling is that it is actually in, like, we divide our population into your clusters. Okay, so let us take in this what we can do. What the easiest way I think of this is that, let's say schools are there, right? Here is school A, school B, school C, school D, school E. Okay, let me write A, B, C, D, E. Okay. Now, let's say you want to, these are the school in a particular area. Now, say you want to understand what is the normal marks and everything for the students and everything. Okay, something like this case is there. Okay. Now you don't have, I would say, like, it is very expensive to get the individual record of all the schools and everything. Okay, then maybe form those groups or basically then do some kind of sampling. Okay, so what we assume and what normally happen in this cluster sampling is that we see that all these schools are basically my sorry, mini representative of my population, right? And you will see that we do this a lot I would say in a lot of places. I will give more examples as well. And based on that, we will basically select any of these clusters. Okay. So in cluster sampling, what is happening is that our population is getting divided into your clusters. And based on our use case, we are taking any like few of these clusters and then basically doing our work. It can be very easily, I would say, be expanded to other example as well. For example, if you want to understand that how a particular tech park works, let's say in Bangalore, okay, or how, let's say, a particular company works, what is the structure, maybe you will just choose 3-4 companies and you will understand that, hey, get me these points for these companies, and then I will take a guess. Okay. So because we assume that each of your school or your companies will basically be a mini representative of how all your companies or basically everything is working. Now, why this might be needed is that whenever there is, I would say, difficulty in getting the all the individual properties and everything for all the data sets you are considering. So let's say you have to work on 100 companies. Okay. Instead of going to each of these 100 companies and everything, maybe you will select 5 out of those companies. Okay, 5 companies out of that, and then do all your working. Okay, so basically you have divided your data set into clusters, and then you have selected those clusters. Okay, because it was very difficult or very expensive for you to basically make sure that this kind of thing is happening, right? To get the individual data and to reach out to all these things. So in those ways, we basically come up with cluster sampling. Can anyone tell me if all these things are clear or not? This is used actually a lot. normally more than even I thought that it will be when I first learned about this. But then cluster sampling is a very inexpensive way of basically drawing all the conclusion about your data and everything. And normally you will see this is actually very true of your population as well. Like in a normally in any school, what happen is that, let's say if we are seeing the pass fail result, normally, and if we take, let's say, 3 and 4 of our schools, around 70, no, normally around 85 to 90% are basically pass their exam. Maybe 5% are there who have the backlog, and let's say the 5% are students who are failing. Okay, so this number will basically be very close to, I would say, different school. So it will be representative of all population. So instead of we going to each and every school and everything, basically because we have the clusters available, we intend to use them so as to make sure that we are able to get our all the I would say particular all the intuition or anything which we want to get for our use case. Okay, so cluster sampling is used like that. It is normally very better when it is very expensive to get insights about each and every data. Okay, so I hope each and everyone this thing is clear. All the sampling techniques are clear. Normally it can be asked and you have to define the different sampling techniques. I personally suggest to use your examples to explain them, because that stays with you and that even is very easy to explain. So all the examples which I've given you me while explaining this thing, it is very important to just remember them. Okay, great. Then I think let us move to the last topic which we have normally for our EDA. Okay, so that is your variable conversion and everything. Okay, so first let us see data types. Great. Cool. So we actually have seen. One second. Let me go here. Actually, it will be better. Yeah. So let us see data types. I think I've explained the same as well. Let me quickly do another. So we see that how they can be two types of data type. I have with me that can be quantitative and your qualitative. Okay. I think I've covered this in one of my previous classes, right? This thing, the quantitative with the types of data. Like I'm just covering this because I want to understand. I want to explain you all that how we basically change them now. So that thing is important. Okay, thanks, Divya. So just let me quickly then, I would say I will just cover it quickly then a little bit, because that will help us to basically then that will help us to basically come to the main point, which is the conversion which we have. Okay, which I want to cover. Okay, and I hope you remember that, and please don't get confused in that. Okay, because I must have explained you in very depth when I have explained you this thing. So we'll just quickly cover the same thing now. Your quantitative and qualitative. Quantitative is also said as your numerical or your continuous variable. I hope you remember the same. Okay, this is your categorical variable. This thing should also be very clear. Now your categorical can be of two types. There can be an ordering as well as no order is there. Okay, so for example, in your no order, it can have male, female. Okay, male or your female can be there. In your ordering, it can be, let's say, income group. Okay, so let's say we say that it is high, medium, low. Okay, some ordering or something is there. Then in your numerical also we saw that we can have continuous, basically where the ranges are, let's say 1.8, 2.9, something like this. And in other where we can have whole numbers, basically. Just let's say 3 is there, 5. So it is basically coming on your number line like this. While this overall, we need a histogram for this. Okay. I hope each and everyone, this thing you remember, this thing is clear to each and every one of you. Can I get an idea on the same? What were the name of these two numerical variables? How we used to define them? If I remember right, discrete and your continuous, right? Discrete and continuous, right? Exactly, yeah. So these are all the types of variable which we basically have with us. Again, very important to understand, like remember the same. Let me go back to the slides to show that what I want to cover. So that is completely different thing. Yeah. So now what happened? So there are few more things which I would like actually you to understand. See, it's always better if we are giving our model or our computer to deal with numbers. Okay. So let's say instead of male, female, if we are passing 1 or say 0 here, okay, instead of passing let's say some characters, maybe we are just encoding them. Okay, it is normally very better because the computer is very good with numbers. Okay, for if you are passing it let's say a particular character or some category or something, it will just treat it as number only initially, where it might come up that okay, what is some representation or other. So it is pretty good if we are normally, of course it is not possible in your text thing. We also though try to cover our like NLP based model into numbering as well, but it is a very good strategy to just send numbers to your computers. Okay, I hope you understood this thing properly. Now we have seen this like normally ordinal and nominal is the case. So ordinal is low, medium, high. Nominal can be this, then there can be male, female, and in your continuous and discrete we have also seen. Okay, so this comes into your categorical and this comes under your numerical. Okay, quantitative, qualitative. In normally what happens in your let's say languages, Python or R, when you try to basically load the data, they can be factor, character, numeric, this kind of a data. Okay, I hope this thing is clear to each and every one of you. Now let us go forward and see how we can actually change the data types. Okay, now why this change is required, that should be ideally the very first case, right? Very first, okay, why we need to change the data set, Mayank? What is the use case? Why are we doing that? The reason is that few models, let's say for neural network, we need all attribute must be numeric. Then for your naive base, we want all our this must be categorical, right? We have seen this thing that we have okay, like I in my machine learning class which I took, I explained that how in naive base we want that all of them should be categorical. Okay, we also then studied about the probability function where we can calculate the probability, right? I hope each and every one of you remember the same thing. So now to make sure, okay, that my overall I would say variable, a particular variable, okay, sorry, particular model, it gets the data in the desired form so that it can work on the same. That's why data types are changed. Okay, and the second is that normally if we change them and if we are basically passing that data type to let's say in a numerical format, that is better and faster for our model to handle. Okay, is everyone clear with this thing, that what are the different types of data set and why we might need to change them? Because if that is clear, then only I will move to the next slide. Just give me a quick yes or no if everything is clear or not. Wait, let me move this thing. Great, thank you. So now we will actually understand how we can change our numeric to categorical. Okay, so numeric is basically your continuous variable, and how we have to change that into categorical. So not just normally think of an example or how we will handle that in real life. Okay, so we normally say that if let's say someone is earning let's say less than 5,000, okay, we normally say that okay, according to the government reports and everything, I'm not like don't go on the numbers here, but just the mindset that okay, he is basically uh, poor or basically he might need some financial help. If someone is in the 50,000, maybe he is in the middle group of basically people who are earning. And if someone, let's say, is earning more than 1 lakh, then he is on the higher side. Okay. So similarly, let's say with respect to age for a particular thing, how we do that is, let's say if someone is less than 10 years, okay, then he is young. If 10 to 20, he is a teen. Okay, I think 13 is a teen when it starts, but anyway. And then basically after your 20 to 30, then maybe let's say we say middle age man, on 20 to 40, middle age. Then after 40, we say that okay, it is an old man or anything. So that is how we normally basically divide our data. Okay, so we basically makes bin. Okay, so we make different bin, we label those bin, and that is where we basically send our data. Okay, so let's say young, mid, old, and say senior. And now if any data is coming, we will just basically throw into that, right, on a different bin. Okay, that is how we normally also do the same. So the same kind of a mindset is basically followed here. So you will see we have basically sorted our data. Okay, so what happened is that normally bin is also done on this thing as well in our data, basically how it's done. So the previous way which you discussed, that is on your domain understanding and everything, which you can of course do, which is done at a lot of places. Then your equal width, let me do equal frequency first, equal frequency, and your equal width. Okay, so let us understand what happened in equal frequency. Pretty easy to understand. Okay, we get the following. So see, we are getting these bins based on your equal frequency. Like let's say we have 1 2 3 4 5 6 7 8 9 10 11 12. So we had 12 data points, we have made 3 bins. So we will just make sure that each of that remains, like get the same number of your overall values. Okay, in that. So let's say if n is 12, we want 3 bins. So now we know that each one of will get 4. Okay, I hope this thing is clear to each and every one of you. Can I get a quick yes or no on the same? Should be pretty easy to understand, I hope. Okay, I think I'm getting a yes. That should be helpful. Great. Then next come your equal width. Okay. So what we do in our equal width is that we want that our data, okay, that our data, it is having the same width. Okay. Something like that. So let's say if this is my data, okay, let's say these are my different data points. So I want them to be divided into like this. Okay, so an example of this can be, say I want that each of my data is having, let's say if we have different for the age group, let's say we want how we are dividing it, let's say in the groups of 10. So 10 to 20, 20 to 30. Okay, so like this we are dividing, where we know that the width is equal. Now I don't care how many this is getting. In the earlier one, what we made sure was that each of our bin, okay, each, like let's say if I have 3 bins, the n will be same in these, right? That is what we are making sure. Here I am basically just worried about the width overall. Okay, how will the basically width go? Okay, so in this, how we calculate this width is we calculate the max minus min, and we divide number of clusters we want. So let's say, sorry, bin we want. So let's say it is 3 in this case. How you can think of this is, let's say you have a competition where people are coming from all ages. Okay. So let's say you have a let's say you have a race or something where from 15 to 35 people of all ages are coming basically. Okay, max is this and this. So a very obvious division would be, actually I think I should have taken 45. Yeah, 15 to 45. Okay, and let's say I want to divide them into 3 bins overall. So a very smart one can be this. So how we come up to this? 45 minus 15 divided by 3, that is your 10. So 10 is my width. Okay. Now I don't care how many people are falling from 15 to 25. Okay, in the equal frequency one, I did care about that, and my bins were made by that logic. But here I'm more concerned about the width of my hair. The width is 10 years. So I know that any bin or any category which I have created, that will have the range as 10. Okay, if the people are present on that, but I know that okay, 15 to 25, if you ask someone, hey, where can I find 15 to 25 people, you'll say, hey, this is the category, this is the room where it will go. Okay, so it is used a lot, of course. Whereas if let's say the where equal frequency method is used is, let's say you have 12, let's say you have 15 people and you want to create 3 bins, so you will just say that okay, 5 each will basically come. But or let's say you have created a bin, okay, let's say small, medium and large. Now you don't care what are the ages. It can happen that let's say it starts from 10 and goes till 50. Okay, then it can have 52, 53, 59, 57, I've damaged 56 and 59. So something like this can also happen in your equal frequency or equal width. Okay, I hope this thing is clear. So the formula is your max minus min upon the width. Upon the number of bins we want. So in this case, it will be 3. Your max is 34 minus 4 upon this should be 3. So it is coming out to be 10. Now your first bin, if you will see here, okay, it is 4 to 10. Your next bin is 10 to 20. Okay, sorry, my bad. 4 to 14. 14 to 24. And then your next one is 24 to, so we have to also define, so let us make it that it is equal, so that thing we might have to define. Then say 15 to your 24 and then 25 to all the others. Okay, yeah, something like this will happen. Then 35. Okay, I hope this thing is clear to each and every one of you. What is happening here? Just have to write it again. 4, 14, 14 to 24, then 24 to 34. This basically, this value is the equal value. So we are seeing if it will be equal, it will come to the above bin. So see, for 24 is coming here. Then 34, if it is coming here. Okay, next one will become 34 to 44, something like this. Okay, I hope each and everyone this thing is clear with respect to the binning. What happened? This is one of the way we basically divide a numerical to categorical. Can everyone give me a yes or no if this thing is clear or not? Great. So I think just one slide is left. This is pretty straightforward, that how we change, let's say, our marital status if we have to change categorical to numerical. So we will just take it like this. Single is 0.1, 0.5. Okay. There is an issue in this thing which I think a lot of you would be able to tell me. Okay, what is exactly the issue? So let me take this example as well. What is the issue if I do encoding like this? 1 and 0. Pretty easy. Categorical numerical. We will just take the categories and assign some numbers to it. But what is the issue if I take our input like this? Male and female, 0, 1 and 0. I think this is okay. We are actually on time, so this actually can be your homework maybe. So I will ask this in the next class, that what is the issue here if we are doing coding like this and exactly the way we have done here. Okay, here we are just then find out what is the issue if I do like this. Okay, if let's say I label my male as 1 and female as 0, what is the issue with this thing? Okay, so this can be an assignment. Tomorrow we will start with a case study. I think we are on time. So, and this was actually the last slide which I intend to cover. If anything is not clear, can anyone let me know in the comments if any doubts are there or anything? This thing you have to find, and I will ask this tomorrow. Okay, what is the issue with respect to this? If I take male as 1 and female as 0, what will be the problem if this thing happens? Meanwhile, everyone else, please let me know in the comments if anything is not clear or if you want me to repeat anything or if any doubts are there. If no, nothing is there, then I think we will drop and we will meet tomorrow for the case study. Okay. So let me actually start with the basic overall walkthrough on the platform and everything. And meanwhile, people will join, so we will be good to begin then. Okay. So yeah, I think I have covered this a lot. But if anyone is joining for the very first time, uh, you are watching me either on the like most of you are watching on the iNeuron challenge channel only. So where we are going live and doing this community class. So I have personally done two community class, one on the data science and another on the machine learning. Okay, so once you complete this thing, this class basically today, like after today's class, hopefully it will be completed the case study. If not, maybe we will just take tomorrow's day as well. Okay, maybe 1.5 hour. But yeah, once we complete this thing, then you should be good to start the machine learning community class. Okay, so doing both of these community class will give you a very good idea on what exactly data science and machine learning is, and then you are very, I would say, at a very good base to even include that in your CV, include any projects or case study basically which we have covered, and as well as move to, I would say, advanced level of that. Okay, advanced machine learning or deep learning algorithms. Okay, so this is a platform. Make sure to check us out at iNeuron.ai. You can search about the same on Google so that you will get the website. Then to take this particular course, so we are also running other community classes as you are aware. So should be, please feel free to check them out. Okay, a lot of them are free, and that would be a very good starting point if you want to start anything. Okay, then just search by my name, and there's the Data Science Foundation. Now this is free, as you can see. Now, why I am always pressure, like I would say, pushing you and nudging you to join from here is that once you join from here, we will be able to track your progress and also provide you with a certificate once you 100% complete this course. Okay. So what you have to do, you have to just enroll now from here. So for all the other community classes as well, make sure that you enroll now from here. I am already enrolled, so it will just ask me to log in. You have to sign up maybe if you are new to iNeuron platform. Then once you enroll, this is the Data Science Foundation one. So you will see all the videos. Okay, you will actually see all the videos. So what we have taken along with quizzes and assignment. So till now actually we have done, yeah, till day 5 EDA to every video is available. Today we are starting with a case study. Most probably this will be the last thing which we will be covering. So today I will try to complete it, else we will take tomorrow's day as well. But yeah, this is what we intend to cover today. Make sure that you can take classes from here. You won't get any distraction or I would say video references from YouTube. Amazing recommendation engine. To avoid that and to actually study, let us use this. So that should all be, I think, pretty good. Then there is another way you can actually just 1 second, my bad. Another way to take our courses is that you can go on iNeuron. You get iNeuron Intelligence, and basically here you can see that live classes we are taking. So here you can join it like this also. Okay. So I hope this thing is clear as well to each and every one of you. There would be a little delay, I think, so the way I'm seeing. But yeah, these are the two ways. Live classes you can take from YouTube, and for previous classes or for assignment and quizzes and for a certificate, please make sure to check out our website and enroll there. Okay. So let me actually start with today's main agenda. That is a feature engineering basically and the EDA part. So let me take if any questions are there. So I had a doubt. I can able to identify the data set whether supervised or unsupervised. I had a doubt from model selection, which use case to fit for iNeuron. Prithvi, see what happened is that I will actually cover this thing in today's class as well. Once you identify that what problem of yours is, normally we deal with classification or regression problem, right? Okay. First, you have to make sure that you spend the time to clean and basically make your data ready. So let me write it like this: data ready. Okay. Then how the use case for your, I would say, basically model selection occurs is that we ideally try to apply more and more models because it is pretty straightforward to apply models. But if it is not possible, then we actually try to understand the data. For example, let's say if most variables are categorical. Okay, let me remove it from here. Yeah. So let's say if most variables are categorical, then naive Bayes is a very good algorithm. Okay. If we are dealing with a lots of, I would say, numerical variable or variable where you see that some kind of overall conditions can be made. Okay. Let's say in your EDA, you got to know that, for the example, we will see in the house browsing that how a number of bedrooms, number of, let's say, bathrooms, they have a play, right? So in this, what happens is that you can get actually an if kind of a condition. Let's say if houses bathroom is greater than 3 and something like this, then this can be less than 3. If you get in your EDA, basically you will get to know about this. Okay, when you will do a lot of, I would say, spend a lot of time on your data, you will get to understand on this. Then you are pretty sure that maybe decision tree, machine, or let's say random forest can be a good algorithm. Okay, random forests are the good algorithm. If let's say it contains a lot of, I would say, your numerical variable, and there is some, you feel that there might be some, I would say, connection between the dependent and dependent variables. So what I mean by connection, let's say something like this is happening, m1 x1, then let's say m2 x2, and a lot of maybe this kind of very complex thing is there. Okay, then what you will do is, then basically we will finalize that maybe neural networks can be used. Okay, so the model selection and application always depend on which kind of data you are dealing with. Okay, if we have a lots of features, then maybe we will do PCA first, that is principal component analysis, and then maybe we can try to see that if SVD or SVR, those kind of algorithms can be applied or something can be done there. Okay, if a lots of algorithms, if a lots of columns are there, okay, if lots of columns are there, then PCA becomes a choice first to basically reduce the overall, I would say, dimensionality of the data, and then basically work on the same, right? So the best way first is to understand your model, your data, and then apply your model based on the understanding which you have, and then see, okay, which is doing better, which is not. And normally what will happen, what I have seen in my experience is that certain, based on problem, okay, based on particular problem, certain kind of models, or I would say family of models. For example, these are your all tree algorithms, right? Based on tree or based on conditions. Okay, the other one is your statistical model, these your linear regression or logistic regression. Then naive Bayes is your probabilistic model. Okay, then there are ensemble model as well. Okay, so what I have seen is that one family of your particular model will basically do very good, okay, as compared to other family, because somewhere some hidden pattern with respect to stats, probability, or something would be there in the data, okay, which our model will be able to extract. Now, once you're able to get that, then it makes a lot of sense to see that, okay, what other algorithm in the same space you can apply. So, for example, we see that linear regression is basically doing us very good. Then we can basically try regularization, L1 and L2 regularization, to maybe see that we can reduce overfitting. Okay, we can try to come up with some other insights. We can have some feature importance, which basically can be added. So, all these things are basically, I would say, basically hit and trial kind of thing, which we try in real life majorly to come up with what is the best model. Okay. Prithvi, I hope your question was answered. Can I get a quick yes in the comment if everything is clear? Anyone else, if you have any doubts, please feel free to ask them. So this was 3 questions of Prithvi, so as to make sure. Great, Prithvi. And I will suggest one more thing. I will be taking few other community classes as well and everything. So please be with me, and the thing which I will basically share with you, right, based on my experience, especially in the industry, that will be a lot helpful. See, the thing is that right now, when I will say that whatever we are studying, right, that is 60-70% of what actually we will be using. There is no, I would say, fixed steps that you have to do this. It is always a lot of hit and trials. Okay, you have to, the more you will do it, the more projects you do, the more understanding you will get. Okay. Great. So I think we can begin with the same. Just before beginning, I would like to quickly just discuss that all the things which we have covered quickly once again. So we started with statistics. Okay. Of course, backbone of data science, very important. Okay, one must understand. Although I hope everything which I have covered till now, that was clear, right? I have make sure that the language is pretty easy, and I have just covered them as much as they are required. Okay, because if let's say you know that now what covariance and correlation is, if any other thing someone is using, you should be able to come out basically get what exactly that is. Okay, so your statistics we covered about mode. Okay, 1 second. Yeah, on statistics we covered about mode, median, mean, so mean, median, mode basically. Then we covered about your variance and standard deviation. So these are your overall central tendency measure, and these are central dispersion measures. Okay, so I hope each and everyone, if you remember this. Then for two variables, we understood that what covariance and correlation is in why one is beneficial while other might not be that much, but yeah, it is still makes sense to basically get an idea on what both are. Okay, so covariance and correlation. So along with that, we also covered all the jargons of your statistics, population, sample, all these things. Okay, so that is of course very important to understand, because if you're talking between data scientists, then it makes sense to use those jargons only. Okay, like it will be a lot helpful to make sure that you're using those jargons and they are heavy. They are like basically something which you are connecting with, so other person also think that you have an idea. Okay. Then what we next covered was about hypothesis testing. We took like had a little idea on the same. I will be covering this in the further class. This has to be actually taught like your maths concept, but it is of course very important with interview point of view as well. So we'll cover this separately. But hypothesis testing is something which we saw, where we took some examples and how we understood that okay, if this is your population and this is your sample, then how basically we come around them. Okay. Once this was done, then we basically move forward. Then we move forward to see what are the different kind of EDA. Like we also, of course, discussed the CRISP TM and big data methodology. So let me write them as well. And I actually use CRISP TM a lot because I think this is very intuitive. Like let's start first with business instead of data or your any technical thing, which does makes a lot of sense. Okay. Then we saw that how we have to do missing value. Okay. Then how we have to handle outliers. Then how we can actually handle different kind of variables, different variables type. And we also saw that how different sampling techniques are there. Okay. Along with that, we also saw that normalization and your normalization / standardization to basically get your data through. Okay. What all we discussed apart from this? And then basically all the different kind of data types and how to handle them. Okay. So I hope each and everyone, if you have the basic idea on what all we have covered. Okay, can I get a quick yes if all things are clear, so that we can move forward on the same? Great. Thanks, Divya. Thanks, Shalmeli. So yeah, I think we can now start and let us go back to our overall code. So actually, let me just also zoom this a little bit in. I hope this is clear now. Can I get a yes or no if this thing is clear, what you are seeing on my screen? Please let me know if this is visible, what I'm trying to show, or if I have to zoom in more. Of course, the code should be very clear to you so that you get an overall idea what is happening. Great. I hope everyone is able to see the code. That should be helpful. Nice. So I will actually, what we will be doing today is I have actually shortlisted few problems. Okay, and we will be doing our analysis, cleaning, and everything on those problems in steps. So we will first take up house pricing data set, a very important data set and everything. Normally, a lot of concepts are taught using this data set. It is present like one is present on Kaggle, then Boston data set is also present in your scikit-learn and other libraries as well. Okay, so we will get the data, and along with you, I will also ask that okay, what thing you see that something which is better in that in your data and everything, and then we will take 2-3 data sets. The reason being is I want to cover more and more types of problems. Okay, so this is a regression problem. Okay, we will not be applying model or anything. Let us not go into that because we have not studied till that. But of course, data science and feature engineering and EDA, all these also have a very good, I would say, importance, and that has to be done first before applying a model. Okay, so I hope all of you are clear with this as well. So now actually let us move forward. Okay, so we will actually perform the below things: handling missing values, temporal variables, we will see what they are, categorical variables, okay, rare variables and everything. So what do I mean by rare variable is that let's say student, teacher, and parent, these are some data, okay, which we have labeled. Okay, now it can happen that let's say 60% is student, 39.9% is basically your teacher, and 1%, like in a school data I'm saying, then 0.1% or somewhere is basically around which your parents' data lies. Now, of course, this label is kind of something which we might not have to deal with. Okay, so we will be seeing that if we can remove this or not, and then standardizing values of the variable to a range, to basically same range. So this all we saw also that, right, standardization is required. Before moving forward, I asked yesterday a question that what is the issue if I make change like this in our model? If I basically, so let's say my gender is there, okay, say age is there, say qualification is there, and then let's say income is there. Income is my dependent variable. Now, if in this variable M and F, what if I change it to 1 and 0? What is the problem? Have anyone spent the time to basically work on the same? Can I get an answer if anyone has any idea on the same? This was something which we discussed, right, yesterday. Anyone has an idea about will be the case if this happens? Divya is asking what is temporal variable. We will see the same. Divya, majorly temporal variables are the variables which, let's say, deal with your time and everything. So let's say if it is given 3 days, 5 hours, then AM, PM is given. Okay. If let's say distance or the time taken is given, so we have to handle them in a nice way, right? So that we can be sure. Anyone else who has an idea that what will be the case here? Should be straightforward, pretty. I would say, like, it is very easy to check also. Like there is some library also which we do to handle cases so that this doesn't one hot encoding or something, if you have heard of it. Okay, let me tell you what exactly will be the issue. Let us go to the board. Okay, because this is of course a very important concepts again. Now what we took was that we have gender. Second, we have our gender. We have our age. We have our qualification. And we have our income, let's say, which is the dependent variable. Okay. Let's say all of these are somehow numerical variable only, and in gender we are having male and female. Okay. Now, if all of you remember, qualitative variables we studied two type, right? So in qualitative variables, one was ordinal and one was purely categorical. So in ordinal, there was a basically levels, or I would say the variable, like let's say high, medium, low, something like this was happening, right? Something like this was happening where there was an order between the categories. Okay. So now what happened is that if you will change your males to 1 and female to 0 here, then there will be an issue. The issue will be that your model, whenever model or whatever model you are using, okay, let's say whatever model which you are using, that will basically feel that 1 is basically superior than your 0. Okay. Something like this will happen where it will think that 1 is superior than your 0. This would have been fine if we, let's say, do the same in qualification, where let's say qualifications are something like, say, high school, graduate, undergraduate, and PhD. Here it seems fine if I allow PhD as 4, undergraduate let's say as 2, graduate as 3, and high school as 1. Because there is an inherent level where PhD is ideally in a normal way, basically it is greater than your high school student, right? But if we do the same thing here, we are, let me just use it. Yeah, we are in a way telling our model that let's say 1 is greater than 0 or male is greater than female or vice versa. Okay, so something like this will be happening. Okay. I hope this thing is clear till now. Can I get a quick yes or no from everyone? If this thing, what I just explained, is clear or not? And this will be true like if let's say you take one anything as 0 or 1. Okay, if the ordering is not there in the category, then this thing doesn't holds true, right? Everyone else, is this thing clear? Can I get a quick yes or no? Okay. So now how will we deal with it? Anyone has an idea? Yes, Divya, one hot encoding, then you should have seen the same as well. So what we will do is, let me actually clear all this thing here. There's a library as well, and we can do that by ourselves as well. What we will do is, we will actually convert our variable in a way where, let's say this is red. So gender underscore male and gender underscore female. Okay. So if we see here, it will be 1, 0, 1, 0. Similarly, here it will become 0, 1, 0, 1. What I have done, so where male was there, I choose 1 in gender male. Okay, and for female or any other type, I will choose 0. Okay. Similarly, for male, let's say in this case, if female was there, then I choose 1 for female, and in other case, I choose 0. There can be other, I would say, genders as well. Okay, if let's say not specified, or if it was missed, or any other gender as well. Okay, so we will be able to handle the same. It will be 0. And I know that, like, I will share what I felt the first time I learned about it, that won't it become a lot heavy for my model? That let's say basically if we are sending these many variables, but that is not the case. Our model is able to handle the same. Okay, it is rather able to handle that better. Okay, and we don't get a case where, let's say, ordering gets introduced into our categorical variables. Okay, so that they can have an effect, right? Is everyone clear with this thing? Can I get a yes or no? Meanwhile, let me see your comments, and if anything is not clear, please write in the comments. Income is not dependent on gender. Can we drop? Praveen, that is actually not the case. So two things. First thing is, income is anyway your target variable. Okay, so anything in your ED and everything, we will be dropping it, and you cannot say by. I would say that if income is dependent on gender or not, right? A lot of reports actually in today's world show us that unfortunately still gender plays a role in your income and everything. Okay, so I basically had this thing discussed when we were doing a case study in ML as well, that you should kind of be like, I would say, a dumb child, where you are inferring like all the information from the data, not from your outside world or anything. You can use the outside data, that thing still works. Okay, but don't let your I would say your thinking or your prejudice come inside the data. For example, it can very well happen that in this particular data, let's say if we are given any data, okay, your female's gender basically has somewhere where the income is high. So if that is not the case in real world, you should not care about that. Okay, you should see if you can include something, that why is that the case, to basically, I would say, enhance your data. But if your, let's say, data is given from a particular use case or something, then you should not basically focus on making that right based on your understanding. Okay. Everyone, is this clear? Can I get a yes or no? Okay, great, Praveen. Divya, this is the one hot encoding only, na, which I did just. What else you understand by one hot encoding? Divya, I hope this thing is clear. And overall, let's like you can go to name, and this is what we're not encoding it, but I think you understand the overall intuition and idea about this, right? For our model, when how it will be better. And this actually is we're not encoding only, right? I hope you are not confused till that what exactly one hot encoding is and the other case. It's very important to get this thing clear. I don't want that you see two things are there. First is that okay, I understand that of course you should know the names and everything, but overall I have seen few data scientists which are actually they are able to make very good decisions even if they are not aware about the names and everything, right? So first, let me know if you understood this thing. Then we will actually also we can together see what one hot encoding is. Okay, let me actually just see and check that in front of you only. So that would also clear this up. If what we are doing is one hot encoding or not, let me go to the HDMI. Okay. So let us maybe check one hot encoder in your scikit-learn overall. See if they have given any example. Ideally, they do give an example. So see male 1, female 3, female 2. Okay, they are doing something like this where they are fitting it. 1 second. Let me try. Let me take this example. So what is happening here is that see categorical value of fruit was 1, 2, and 3. Okay, here the issue would have been that overall we would have introduced some, I would say, prejudice that let's say orange is superior than the other two. So what we do is apple, mango, and orange. Okay. I hope this thing is clear. Divya. So similarly, if you see, this example is also there. We can change the gender, and of course, also makes sense to change the remarks. Or remarks can actually we will see that grade can be 2. So it is basically if it is very best, then it is 5, right? Or let's say excellent. So we have the category poor, worse, poor, good, great, then best. So basically 1 to 5 star, 5-star rating we can basically come up with. Okay. So I hope this thing is clear to each and every one of you. Temporal variables also we have already told we will see the same as well. Now let me remove and basically start with our case study quickly. So here we have taken the house pricing data set. Okay. Now what is happening in this house pricing data set? Let me first explain each and everything to you. Normally import is the very first thing which we do. Import numpy, panda, matplotlib. Matplotlib inline. Why is this used? Can anyone tell me? Why matplotlib inline is used? And this is basically PD panda set option display max column. So this is so that we can visualize all the columns in our data frame. Okay. Why is matplotlib inline used? Can anyone tell me? So then we have the data. I will be sharing the code as well, the data with you. So you should be good to basically practice and basically include this as one of your project. Okay, sorry, my bad. I had to remove this, but no worries. Let's go back. Yeah, great. So here we are just reading the data. Read CSV dataset head. Let me run this as well. So data should be in the same directory. If you will see here, the data is present here. Let us see the data also once. Okay. So I think it has a lots of column. I think around 81, 85 columns are there. So the main column is your sale price. Okay. Where we are basically calculating the price. No, Divya, that is not the case. If we are using matplotlib inline, we will get the graphs inline only. It won't be opening in a separate tab or somewhere. So you can see all your graphs inline only. Okay. Hello Anand, good morning. I don't get notification of a live class and missing a lot of classes. No worry, Anand. I will highly suggest you to just see the recordings. I will check with the team advice that the case. Ideally, I think you should subscribe to the channel, and I think in the iNeuron you will get those notifications, right, for the live class how it happens. We'll still check with the team once. Okay, so that should be fine. So everyone okay, I have to see purpose of matplotlib inline. So you can just understand if anything is not there, please Google that. I think is the biggest skill where you are able to find the solution yourself as well. Okay. So if any code is given to you, try to understand that with the help of your overall knowledge as well as your internet and everything. Okay. So if you don't see, this is if we don't write our graph, the graph will be opening in a new window altogether. Okay. if we don't use matplotlib inline. But if we use matplotlib inline, then we will see the graph like this inside our notebook. Okay, I hope each and every one of you clear with this. Of course, very important function. We don't want that it is 1 second. Okay, let me run the first line. So it is saying PD was not defined, panda we haven't exported. And now basically using this panda set option display max column, we were able to also see the same. I hope each and every one of you is clear on what exactly matplotlib, all the libraries and everything, whatever we have imported. Okay, and then we have now basically, I would say, loaded the data. Okay. Now we will see the data shape. It is 146081. Okay. 1460 rows, 81 column. Of course, this is a very, I would say, heavy data because we have 81 columns to deal with. Okay. Let us see some of the columns to get an idea. Let us see what all columns we can understand. We have the ID, that makes sense. Each house might be having an idea. Then lot frontage, I think this is how much lot basically is for the front area. Then lot area. Okay. Then which street is basically going on. Then alley is present or not. I see most of them are NAs, so we might have to deal with them. Lot shape is there, regular IR1 or something. Land contour, then utilities, all pub and everything. Lot config, land slope, neighborhood, which neighborhood is it part of. Then few conditions, condition 1 and 2, I see most of them are norm. Some is coming as this one. Then building type, it is a duplex, it is one family. Okay, town something, basically we might have to see. Then house style, 1 story, 2 story, 5 unit, what all is there. Then overall quality, I think this might be something which is basically they're using. Overall condition, maybe the condition. So seems like this is your numerical variable only. If high, then condition would be higher. Year built, okay. Year remodified. So maybe let's say we can calculate the age of the house. Okay, we can calculate till it was last change or basically last modified. So all these things also we will be able to calculate. Then roof style, how it is the roof style, then roof material, okay. Exterior first, exterior second, all these things, okay. I think there are lots of variables, but I hope you get the idea that what all basically it has, right? Basement has all the variables for basement. So this is basically the data where all the details of a particular house is present. And this is very important. Like when you get that in your industry, right? Please make an Excel and write everything about the data. Like you can spend 2 days on this data as well. Okay. Like before doing anything, first understand the data. Okay, use Python as well to do the analysis, but you can do that before actually going into the data science of it. Okay, because that is very important to understand. This data is going to your, I would say, a bread and butter for the next 2 months. Okay, please spend that time. Please try to understand. Please read more about that. Okay, if this data you see is say from US market. Okay, then what exactly happened and what all these things that should be done. Okay. Now, if you will see, we are defining our X and Y. So X we are dropping the ID because ID ideally doesn't have any case in this, and then the sales price. Sales price is your. So if you remember, I have already told that how we define the data. So your Y becomes something which you have to predict or calculate by a machine learning model, and your X are all the other variables. Okay, we say them independent variables, and this is dependent variables. Okay, so this is what I'm doing here. Everyone is all the things clear till now? What I have done? Can I get a quick yes if all things are clear? Great, everyone else. I hope everything is clear to each and every one of you. It is very important to understand everything which I'm discussing line by line. I already know these things. I'm doing this for your benefit. If you want me to explain any other thing, please don't be shy and ask that. Okay, if any line is not clear or if you want to understand that, sir, why we are doing this, it's very important to understand these things. Okay. Great. If this is clear, then I think we should be good to move forward. The way we have defined X and Y, we can also define like this. So iLock, let me clear all these things. Sorry, I missed. Okay. Keep on pressing the notes button instead of the eraser. But anyway. Okay, it came there. Should be fine. Yeah. So what is happening is I can also define this x and y in this way. I think you have an idea, same thing but different way. So I lock all till 1 to 81 and then minus 1. So if you would have done list indexing or something, basically you would know that how this is 0, 1, 2, 3 and also minus 1, minus 2, minus 3, minus 4. Okay. Divya is asking a very good question. How to know about each feature without domain expertise while practicing, sir? Divya, so the case which happen is that you will be getting this data from somewhere, right? In around 70 to 80% of the cases, the overall, I would say, key map or all the things basically for your particular data is provided to you. That okay, what exactly is happening, what exactly this particular key is having an idea. So I normally divide it into two parts. Okay, let me explain this as well quickly. Well, this is a very important question. Okay, see what happened when like everyone also pay a very close attention. Once you get the data, in most cases you will get all the keys and everything that let's say what particular column means. Okay. Now to get the domain expertise, if let's say you're getting the house pricing data, what I used to do personally, I will tell you, and that used to do wonders to me. That let's say tomorrow you're getting a problem in a similar domain, let's say office prices or house pricing only. Okay. I used to basically go and see what all projects other people have done and their code as well. Okay. As well as read a lot about the same thing that okay, how the house prices, let's say in a particular area has affected. So for example, we know that in major cities in India, for example, post COVID, there have been around 13 to 15% of increase in the residential property. Okay. So 13 to 50% increase from 19 to around 23. Okay. Then similarly from US house market, we know that how it was peaking and then dropped a little bit around 2008. Okay. Then similarly, it makes a lot of sense to first get an overall idea on the data that okay, what is it, and read about the same. Okay, that say if this is the housing data which I'm dealing with, right? I will go on internet and read a lot about housing data, how the purchases are done and everything. What are the different, I would say, terminologies and jargon in the same. Okay, so for example, it makes a lot of sense to understand that what role garage has to play. Okay, let's say garage, what role it has to play. Then similarly, how many like if particular area is there, okay, what kind of area is that? Okay. So first you get the domain expertise in that way where you are understanding everything about the same. So a very good example for this is let's say if I give you food level data tomorrow, right? So you will go and understand that okay, what exactly is the effect of your calories in the food, okay, of added sugar. Then what are the different preservative? It is normally written INS 05. This is the preservative added. Okay. So first, I think it makes a lot of sense to actually get into that thing and spend 2 to 3 days to understand the full industry. Okay, read a lots of reports. Read, I would say, a lot of overall articles on the same to understand the same. Okay, for example, in a food data, you will get to understand that if added sugar is very high, that food doesn't qualify as healthy. Okay, then normally let's say price point is there. Try to understand how this price is decided and all these things. So all this will help you in understanding overall, I would say, the jargons, the industry pretty better. Because see, not each and every one of us cannot get overall full idea about any industry, right? So if today I am practicing and I get tomorrow a project which is the very first for the pharma industry, then I need to make sure that I am understanding that industry pretty well because that only will transform into my data. Okay. So in the pharma industry, what I will do is I will see that okay, what is the different kind of trials which are done, what is the efficacy of a drug, how it is defined. Okay, so you must have heard about drug efficacy, something. Then what is your recall rate, how clinical trials are performed. Okay, all these things I will try to understand. Okay, dosage, everything that okay, how in extreme situation if that is added, then what is the case. Then comes the second part where I will now see that okay, if similar problems have already been solved, then how did that help? How the insights helped with the data? For example, what I will do is I will now try to find someone who had done EDA or basically who has tried to understand a lot on the house data set. Okay, you can maybe go to Kaggle and see if a particular similar, I would say, information is present. Let me help you in the same only. So let's say house Kaggle. So you see house prices. Okay. Then what I can do is I can go to code and I can see other people basically doing their stuff on the same, right? So if let's say there is one page house price EDA. I will actually do the same in industry experience also. Used to do the same where we are actually seeing other people's code, and hopefully this was not in different language. Okay, sorry, my bad. I think my screen is not getting shared. Yeah. So what I've done is I went to Kaggle and basically pick up a notebook where person has done out EDA on the house prices, and I will see what all kind of stuff he has done, right? What graphs he has made, what all he has done. That I see that this is the correlation metric. Okay, this overall is your correlation metric which a person has made. And based on all these things, I should get a pretty overall idea that what all things even I can do on my data. Search screen is not visible, sir. Is it visible now, Divya? I'm sorry, I'm just proving a point. Like nothing on the screen is as such important as of now. But yeah, what I'm saying is that once I understand the jargons and everything, I will see that how the similar problem previously have been solved. Okay, so person might be getting few details from that data, which may be also relevant to my detail. A very good example for the same is that if you have done a project on Zomato, right? A lot of those insights will of course be also active on Swiggy. Okay, so or let's say in any travel domain, right? So to make sure like this, I basically follow this two-step approach, and after I would say a week, I have a very good idea that what all I have to do, and then I get into EDA. Okay, so this step you have to do. Okay, there is no I would say overall idea on the same that how you can basically make sure of that. One second, let me close this tab. Yeah, this step you have to do, Divya. Okay, I hope each and everyone was clear on this. If you want to be a great data scientist, believe me, this thing, the advice which I've shared with you, that will be a lot helpful. Like no one shares these because many people might not have worked in the industry, but believe me, that is how it happens. Okay, you have to yourself basically spare, like I would say, spend the time to gain the expertise in the field. Okay, in the domain. Great. That was a pretty big detour, but anyway, let us come back to our data. This is your same way. The way these two lines are basically doing the same things. Why am I doing this again? Sorry for that again. 1 second. Okay, so let me take the pencil here. Yeah. Okay, this is the thing which I have to do. Yeah. So these two are the same only, so should be fine. Then import train test split. Okay. Very easy code, I would say. Then test size we are putting at 0.1. Okay, we'll try to explain a little bit on this as well. What happens is that we are given some data, okay, and some data we have to test. Okay, test thing is there. So what we do is we divide our data into train and validation. You can say this as your test as well. So that's why I'm taking test. You can take validation as well. So whatever we are doing training on this, we will first test on our test data and then use that to test on the client's data, or I would say the new data. Okay, so pretty easy. Train test split is basically a library in, a function in your sklearn which you can use to just do your train test split. So we are training and splitting by 0.1. So 90% of our data will be trained. Okay. Great. Let us now see missing values. I will try to explain you the code. 1 second. Yeah. So features NaN. This is basically all the features where missing values are present. So feature for feature, this is a for loop. I hope you're aware of this overall syntax of writing the for loop in Python. In dataset.column, so all the columns in my data set, if data.feature is null. Okay, so what I'm doing, I'm taking one feature. So let's say if these were my features, I'm taking features one by one and checking if it has null values. If it has null values, I'm including that in dataset null. Features NaN. Now, after that, what I'm doing, I'm running another loop for feature in feature NaN. Feature is this. Okay, so this comes to your overall feature thing, and missing values is this percentage. Okay, so missing value I will calculate by just dividing by everything. Okay, let me run this thing. See, now we will get an idea on the same missing values, how many are there and if you have to build. So see, Ali basically is having 93% of values that's missing. Okay, this has 99%. So pool QC is having 99%. Okay, if you remember idly, we had a rule that let's say more than 70-80% of values if there are, okay, we will be just removing that column altogether. Okay, we won't be doing this here. So there is one very more important thing which I would like to stress here. When doing EDA, you just focus on getting the insights. Okay, you don't change anything in your data till now. You will share those insights, you will make a report on that, or basically you will make sure that you are writing those insights somewhere. So it's not like that because I have now get it, I know that all of us know the ways now. Mean, median, mod, KNN, and other ways are there. We will still not be doing anything to calculate that. Okay, we are just doing our, I would say, overall exploration of our data. That is exploratory data analysis. We will be doing and working on the features after and once we are make sure that okay, this is happening. So for example, why is that the case? Let's say feature alley is missing at 93% values, right? So maybe this data was wrongly inputted, or there might be a way where you can fill this data, or you can ask the client, hey, can you provide me these values? If that's the case, okay, then it will make sense to first fill it instead of directly, I would say, like directly, let's say, imputing them by the ways which we know. It's better if we can get them by a client or from the same source where we have got the data. Okay, instead of just filling it and then feeling happy, because 93% of missing value doesn't make sense. If let's say out of 100 students you have the score of 7 students and you try to fill the scores of 93 students yourself, you will of course be a lot wrong. Okay, I hope this thing is clear to each and every one of you as well. Can I get a quick yes? Everyone, can I get a yes if all the things till now is clear? Everyone else? Great. So let us now move forward. Then let us see for the categorical features as well. Okay. So 1 second, let me just show you all one more thing. If I do my dataset.info, yeah. So how many of you have an idea? Prithvi, what do you want me to repeat? Can you tell me what exactly you want me to repeat? Meanwhile, I hope all of you are basically aware of the info function. Okay. Now what happened? Okay, Prithvi, let me repeat the missing value part. Great. See, what I'm saying is that we will be calculating missing values in our data now. Okay, this is the code which we have in front of you. So first I will calculate what are the features which are basically, so let's say A, B, C, D, these are my features. First what I will do is I will calculate that which feature missing values are present. Okay, so let's say in this case B and C have missing values. Okay, rest all the values are there. Okay. So now what is happening is that what I'm doing is feature, I will taking each feature one by one. This is the for loop. For that, if dataset feature, okay, so how it will happen is first it will take A, then it will take B, then C, then D. Is null dot sum. So I will get total missing values, right? If it is greater than equal to 1, you can also use greater than 0 here. So you will get B and C here, right? You will get all the columns where missing value is present. Now, once you have this thing, what you are doing is now you are calculating the percentage of missing value. Okay. So how you are doing this for feature in feature NaN? So you are just taking B and C now. What you are doing, the feature is, so we first take the feature, that is just the feature name which are present here, and we calculate the missing value percentage. For example, here it is 1 divided by 4, which is 25%. So you will see that how we have done is np.round dataset feature.isNull.mean. Okay. So this is just what I am using. Okay, and 4 is basically till your 4 decimal places. Okay, so this is a syntax which gives me all the missing value percentage. So for B and C in the example, we would have got B, it is 25%. Like it is 0.25 coming as 0.25. Maybe I have to divide by 100, multiply by 100, and C also 25%. And the next thing which I said is that we won't be actually doing anything to compute or impute them as well. We are first just doing our analysis. Analysis again is very important. Then only can we basically move forward and say that okay, this much is the missing value. So instead of just, I would say, channelize your inner data science where you know all the things, because that is something which has even happened to me, where I used to do all these kind of stuff to just showcase my skill. That never happens, believe me. You have to be make sure that you are working with respect to the business. Okay, so here if the 93% values are missing, first try to understand why they are missing. Okay, can you get that from the data source from where you got the data? Those are better ways than to just going and applying your, I would say, libraries or anything to compute that. I hope Prithvi this was clear now. Great. Okay, Prithvi, no worries. So next, actually, I was moving and write a code. So dataset.info. So what happened is that it basically gives us all the info that what kind of variables each and every one is. So we know that okay, ID, subclass, and all these are in 64 variables, but you will see objects as well. So here you are seeing int, float. The 64 is 64 bytes and everything, and as well as your object. So object generally we take that it is a categorical variables. Okay, let us check for the same as well. MS zoning is one. Okay. So MS zoning, see, it does seem like something which is having a categorical things, right? So this kind of stuff we have to do. Just one thing here, we might have to also calculate this RCEP. If let's say somewhere 1001 is present, then Python might have treated this as your numerical variable in 64 or float 64, but we will have to correct that. Okay. But meanwhile, what I'm doing, so I explained that so the next code is clear. So see, I'm getting for all the things. So now, what I'm doing is I'm getting the categorical variables. So for features and features, if dataset.feature.d type is equals to O. Okay, so O basically translate to your object. Okay, let us basically get this thing now. And let us see what are all the categorical features. See, MS zoning we are getting, so last was sale condition. So we are getting sale condition as well. Is everyone clear on this thing? What I just explained, that how we can get categorical variables. So how to just, I would say, separate your categorical variables from your overall data. I hope this thing is clear, each and every one of you. Give me a quick yes if all is clear. I'm taking it pretty slow so that everything is clear. Great. Good to see few yeses. So now let us move forward. Just one very important thing, as you work on your data, always and always make copy of your data. This is very important if you're doing any analysis, so that you don't make any changes in your main data. Okay. So all the analysis which you will be doing on making the copy first. Okay. And also we don't want one more thing, which is, so let's say this is your data. Okay. Say you have changed something in this data. Okay. And make a copy. So let's say this is your data overall. Okay, in this you have maybe changed your male and female, you have done the hot encoding 0101, something like this. So we don't want that. Now we are working on the same data overall. Okay, let's say any other thing, all the other things we are working on same data. No. If you will be doing your analysis and everything, make sure, please make sure that you are doing these things by making the copy every time. So this is how you will work on categorical variable. This is how you will work on your numerical variables, or let's say missing value, because we don't want that, let's say whatever you are doing here propagates to your other thing. Okay, this may overall lead to, I would say, few things which you don't want, and that propagates to each of your analysis. Okay, this thing is very important to understand. 1 second, let me clear it. Yeah. Great. So I have defined a replace categorical feature. So it is a function. Okay, we have defined a function here. What it does, it takes your data set and your categorical variables, and data categorical variables, data fill NA. So what I'm doing is, for all the NAs, I'm filling them with missing. Okay. So it is another very important, and I would say, use case, where what we do is that in our categorical variable, let's say we have male. So let me explain you this pretty nicely. What we do is that, let's say we have male, female, and few of them are missing. Okay, so let's say this is NaN. So NaN I basically translate into another, I would say, your category which is missing over. Okay. So this is what I'm doing here as well. Okay. We already have our data, the copy one. We are not sending data set. We have our categorical variable, so we are doing this now. Okay. Define the function, replaced it. Then let us see the mod here. See. 1 second. Yeah. So we have replaced our categorical variable and we are taking the mod. Just one thing which we have to do. I think this makes sense. And instead of data, let us take data here. Okay. So lot frontage. If we take here, let us see lot frontage. What is it? Okay, so this is what lot frontage is, and we are taking the mod to check that okay, this is the value which is coming the highest time. Okay, so mean, median, mod also we similarly use by that way. Then what I'm doing next thing, I'm taking a copy again. Okay, in the main data set, as I said, I'm not changing or anything, and I am basically this time filling everything with the mod. So for the categorical variable, if you remember, mean and median doesn't work, right? I hope each and every one of you remember this. Mean and median doesn't work. We have to work with mode here, right? So this time I'm trying to be very easy. Like I know you might have an idea that sir, why we are doing this with mode and everything, but we always try with a simple thing and then go towards the, I would say, the heavier or the, let's say, more complex things. Okay. So in that way, what is the case is that we will be taking mode first, and then we will see if you have to do KNN imputation and everything. But yeah. So similarly, this is the code, and this majorly I have written so I can explain you on the same. Okay. So data we have made the copy. And now let us save this data where we have replaced everything with its mode. Okay. So I hope each and everyone is clear with the same as well. Can I get a quick yes? If you understood how we fill the mod and everything in the categorical variables. Anyone else, if any issue is there? Great. I think it should be clear, pretty straightforward and easy code. So now let us understand this code as well. What we are doing here. So we did our missing value analysis on your categorical data. Same we will be doing on numerical features. So here I'm calculating numerical features NaN. Very easy code. What I'm doing, feature for feature in dataset.column. If dataset feature.dtype is not equal to 0, or sorry, object, what we are left with, int64, float64, which are ideally my numerical variables, and dataset feature is null.sum is greater than or equal to 1. I hope this thing is clear as well to each and every one of you. So in this way we get the numerical features NaN. Basically all the features in numerical who are having the value as, who are having basically null values. See, these are the variables. We can check the same as well. Let's say, okay, we might have to see the lot frontage here. Okay, this will be a little difficult because the data is high. But yeah, these are all the variables where we are basically getting this thing. Okay. I hope each and every one of you are clear with this thing. And what we did there in the line 37, this line 37, how we calculate the numerical features and NaN. So this is actually the way you do your missing value analysis. You won't be just taking your data and just compute every missing values. Okay, first you'll understand where the missing value is and where it is not. Okay. I hope each and everyone is clear. I'm taking it pretty slow so that you understand actually how you will be doing it in the industry. Okay. Great. If because all of you are so smart, can you also give me the code where I can actually plot the your box plot for this thing? If we can plot the box plot. So see plot. See how we normally go and basically see the code. So what I'm doing, like I'm showing you this specifically that I have searched plot box plot Python for a column and pandas because we are dealing with pandas data frame. Okay. So that is how you have to basically go for the code and everything. Okay. It is very important that you know how exactly to search because this is what you will actually also be doing in your real job and everything. Okay. So see, it's pretty easy. I've copied this code, and what I might be just required to now do is data set. Okay, I take this feature instead and title outlier. See, pretty easy, right? So I've just took up the code in front of you and just basically come up with this thing. What I've done, I will explain you again. First, I got all the features where NaN is present. Okay, I specifically intentionally left this code open so I can show that exactly how you do it. Like let's say when you will working in job, right? Even if you don't remember the code, just do a quick search and you should be good enough to use that and basically get to the values. Okay, then just data set feature. So I run a loop. We have three features here we are seeing. Plot kind is equals to box, title we have outliers, and see, and we can do one more thing. Outlier in column feature. See, outlier in column lot frontage. See, it is having a lots of outliers. I hope each and every one of you this thing is clear. We took and understood outliers and everything in a lot of detail, right? Can I get a quick yes or no if everything is clear till now what I have done here? This should be pretty straightforward and like this is exactly how you should also do the same. My way of learning thing was different when comparing your lectures, as I need to spend a minimum 4 to 5 days in business perspective and data while practicing also. I'm clear till now, sir. Yes, Divya. So I personally always suggest that if you're doing anything, make sure that you spend a lot of time in that. So let's say if you're taking any project, okay, I'm not sure how you used to do it. You can let me know how exactly you used to do it. But this was actually some mistake which I used to actually do in the earlier, I would say, in the early phases of my career, where I was a lot focused on actually applying things, okay, directly applying the things, okay, which I know. But believe me, to work in a way that it transforms into something good for the business, it is easy to keep things simple and understand everything. Okay, now it is very easy for me to just write codes and basically make sure that I'm filling all the values in the best way possible. Okay, I'm using KNN imputer to get the missing values. Okay, but I think it makes very much like if you do that, there is no issue. You will be able to do your textbook projects, the projects which even I am telling you that should be all done. But the second you will go in the industry where you will actually be required to do a project and you do the same, believe me, it won't be that helpful. There's a reason that in projects in the industry take 2 months, while we are able to do some projects here in 2 hours, right? So that difference is actually the time which one has to spend on, let's say, your data understanding, on overall your building the business perspective, understanding the business. That is why it takes so much time. Okay. So great, you will see a lots of outliers are there. If outliers are there, which like I would say, how can we impute the missing value if outliers are there? If lots of outliers are present, which is the best measure to get to the missing values? Can anyone tell me? What is the best way to now come up with the missing values? If let's say I want to calculate this missing values, which central tendency measure is, I would say, independent of outliers? It doesn't have an effect on outlier. Okay, let me make it easy. Should I choose mean or median to fill the outliers? What it should be? Median. Thanks, Divya. So I hope you know that why we might be going forward with the median, because we have outliers. Okay, pretty straightforward. All this is, have done the same. If you will see here, clearing all this. See, for featuring numerical features, and there are outliers, we are going to replace with median. Okay, So these are all the median values for my feature, and I'm making a new feature. As I said, we are not going to make any change in our main data set which we got. Okay, so that thing is very important to make sure that you understand all these things. Now, once you will be making this new feature, that is where you will actually keep on changing these things. Okay. I hope each and every one of you is clear with this thing. Great. So I'm making this new feature and I will show you also that how it basically looks after doing this. We have fill in the median and see. That is where I see these features, right? So lot, frontage, NAN, these were the three features which you were dealing with, and now we have filled in all the values. We have not done any changes into the main column because we don't want to basically make anything which tinker or changes our data. Okay. Then let us do this. Lot frontage is NA sum. It will be 0, right? Because we have filled in all the null values with your median. Okay. I hope each and everyone is clear with this. Can I get a quick guess if everything is clear till now? Saying, are we doing changes in the copied set data set word? So there are two ways what you can do it. Is there in the initial only you have data set. Okay. You take this data, create a copy every time you are doing anything. Or you make sure that in the dataset column, even if you are doing it, you don't change the columns as were given to you. Okay. Anything which you are adding, please add others column. Okay. I hope that thing is clear to each and every one of you as well. I just want to make sure that my changes in this is minimum, because if tomorrow I have to run this code again and everything, and let's say if by mistake I saved this, then I will have to get this file and everything again and again, right? I hope each and every one of you is clear with this thing as well. Great. So now temporal variables, I think the way you were also asking on the same. So data set time and everything, all of these variable. Let us see few of the temporals variable where year will be there. So year built, year removed, and then carriage year built. These are the cases. So what I am doing is I am calculating age of your house, feature plus age of your house. So year built, age of your house, age of house, then year remodified, age of house. Okay, so based on these things, I'm calculating these ages. Okay, so see, once I have run this, and I've run this as well, if we'll go to the very end, see, you are seeing the year built and all of these things. Year built, age of house. So how old overall the house is? 531.7. Year remodified. So when the house was demodified, okay. So for example, it was built 7 years ago and then 6 years ago it was demodified. And garage year built. Okay, when the garage was built and basically what is the information. Okay. How should we treat date time features like day, week, number, month, and so that actually is completely different, Mohammed. Temporal variables, as we are seeing, we will be handling them like that. Okay. I will actually take another example so that all this thing is also clear to you. Like I will take another data set where we will be dealing with lots of temporal variables. Okay. Till now, I hope everything is clear what all I have explained here. Can I get a quick yes or no? Great. So yeah, if everything is clear, so this is one of the data set where we have done it. Now let me actually move to another data set to explain you a little bit more on your, let's say, this temporal variables which you all are facing some issue, right? So This is actually one more very flight price prediction is one more data sets, okay, which we can work with. Let me just collapse all the outputs. Okay, this should work. Yeah, great. So if everything is clear now, let us move a little forward. Okay. So this is now another data set. We are done with a lots of ED on your flight price, sorry, on your house. That was majorly on the missing values, if you would have seen, right? So now let us see on the flight price prediction, and here you will be dealing with lots of temporal variables. Okay. So see, this is your all the libraries, the way we import them. Then let us see the data train and the head of it. Okay. So see what this data is dealing with. It has your airline, date of journey, source. I think that is basically from where it flew. Then destination, so it went to Bangalore to New Delhi. Then route it take, departure time, arrival time, duration. Okay, that is how it departure. So these are not your categorical as well as your numerical variables. What they are your overall temporal variables. We deal with time and everything. Okay. So let me show this data from here as well. Okay, it is not UTF-5 encoded, no worries. Is there open with editor? Okay, it is XLSX, not CSV. We should be able to, we can see the CXV, that should be fine. Okay, I can show you the data on Excel. Okay, just give me a second. Yeah, just a lot zoomed out. See, this is all the data. Okay. I hope all of you are able to see the same. So we are moving to the new data. Because you are facing some issue with temporal variables, we will see how temporal variables can be handled as well. Okay. Nice. So this is the airline. Kind of seem like a categorical variable to me. This is your date of journey, right? Over your date of journey, then your source, your destination, okay? Then your route, so how it is going. Then your departure time and arrival time, duration, total stops, how many stops were there, and any other additional info, and the price. Seems like a very easy to understand data set, right? Is everyone clear in what data exactly is? What exactly your data set is? Great. So now let us move forward once we have understood the data. And here are lots of temporal variables are there, right? Great. So we have seen the data here as well. Let me just close this. Similarly, we have the test data set as well, but right now we are not, I would say, dealing with your overall ML model or something. So we are just joining both the data sets. So final DF, you will see that we are aligning both the data sets. Okay. So let us few things on the data now. Data frame object has no thing append. Okay, I think it is not loaded properly. Test DF is loaded. Train DF is loaded. Is there something known as concatenate? Okay, so if we face error like this, we normally just search for the errors and let us see what is happening. So as of panda student append has been depreciated, that's why the code is not getting used. So I was using the concat, that seems right. Concat. Okay, it is showing that data frame doesn't have concat as well. Okay, let us quickly see what can be done then. So it is kind of explaining that why everything was removed. So the code, if let's say we use previous version of pandas, that should be fine. Okay. So issues like this can actually happen, but yeah, we have to make sure that we are able to basically understand everything. So there is one more thing. What we can do is append. See, it worked now, right? So just function has been basically upgraded in the newer version. So we just have to see and basically make sure that we are able to come up with this. I personally believe to not remember any code. That thing is present on the internet. What you as a data scientist is to be done is basically make sure that you have to do is that you have to basically understand each and everything, okay, on the data and everything. Code and all you will be able to write after you do few projects, okay. Please don't remember the code. It is available on net. That should all be fine. If you don't know, for example, right now append has been depreciated and underscore append is present, it doesn't cause an issue. No one will be pretty sure that no one will be rejecting you on this thing in the interview, because see, the main aim is that you want that you have to join these data sets. Okay, that is what the main aim is, right? Let me know if any comments are there. Let me take up. Okay. Whether EDA should be performed before train test split or after train test split, sir, we need to understand whole data. EDA, Divya, ideally should be performed on your whole data. Okay, so that whole data is there. You can basically make sure that every of your data, you are able to come up with that. If test data doesn't have target, should we still concatenate the training data? Yes, Mohammed. So the case is that, see, how I normally do this is that, let's say this is your data where you are doing something, right? This is all your data where you are doing something. I'm talking about the EDA modeling and everything will be just done on train. Okay, so let's say if you do few things here, okay, if you are understanding and doing few things here, okay, then the same you will have to do here on this data. Okay, let's say anything which you are doing, same you will have to do there, then you will be sending this to your model. Okay, so that you understand the same. Now, ideally, just one thing, we don't do the EDA on the full train plus test data. Here I have concatenated because data was pretty low. And to understand this, because we don't want that, we don't want to see our test data before. Okay, that thing is of course always there. So all the fit and everything we'll be doing on my train data only. Here I've concatenated it because I just want to show you these things. Okay. But once you make sure that, let's say these are the steps which you have to perform on your EDA, on your train data, then the same you will be performing on your test data. But all the training and everything, all the decisions will be taken via this data only. Okay. Here I've concatenated it because we have less data, so I want to just make sure that we are working on the full data. That should be fine. But otherwise, you have to always work on your train data only, and all the steps of transformation which you're doing on your train data, you have to do on your test data as well. I will give you an example of this as well. So I was once working with the text data. Okay. So in text, you know that, okay, something like yes, okay, something like this is written. So we normally just remove these top words, these punctuation and everything. Now I then train my model. Okay, so this is, let's say, my machine learning model. So we have to make sure that we are doing the same thing on our test data. Okay, so let's say the yes, okay is written. Then I'm removing this the and everything so that my model gets the same kind of data. But you should not train your model on this test data. Okay, or you should not basically make any EDA things on your test data, like EDA decision based on your test data. Okay. But all the EDA which you will be doing on your train data, like all the changes which you finalized, which you will be doing on your train data, that has to be done on your test data as well. Then only your model will basically perform on the expected way, right? It is not that training, so you have done with a very clean data, everything is basically finalized and everything. Okay, everything is standardized, everything is basically normalized. But for test, you are not cleaning or you are not normalizing the data, right? So that thing has to be done, but all the decision you will be taking on the basis of that data only. Okay. I hope each and every one of you is clear with the same. Great. So just seeing few values. Tail is there 2670. Then info. Let us see on the info. We see that most of them are object, right? And the price is just this thing. So see. Now here is the date of journey. Where is date of journey? See. Now just understand with me what is happening. So this is 27/3/29. What is it? DD, MM, year, right? How I can break this? If I break this on this slash, right? I will get these things, right? Date, then month, then year, right? All this thing will be clear to me. So I'm doing the same thing. So in the temporal variables, you have to deal it in a different way, where you have to get all these values out. So you will see what I'm doing here. Okay. See what's happening here and what exactly I'm doing exactly. So if I split on this thing, if I'm splitting, I'm getting all these date, month, and everything. Now I'm creating a new variable, which is your date, your second variable, which is your month, and your third variable, which is your year. So based on this thing, overall your model will be able to understand a lot of things. Earlier when the date was written, it was not getting those all values, right? So this is something which you won't be getting to nowhere will be taught, but in the case studies in your projects only you will be getting to understand this, right? So see now this what I'm doing here. In the final, and see the question which people have, right? So it is not the case that in my test data, so I train data, I will make these dates, I will make these months, or I will make these years. But in the train data, test data, I will just send by like this only 27, 3, 19. Right? I will be dividing and basically doing all these things on my test data as well. So my model gets that value instead. Okay. So what I have done, date, date of journey, string split and string of 0. Why string of 0? Because see, this is where my date lies. This is where my month lies 1 and this is where my year lies. Okay. See, 1 second. Yeah. See, so I'm able to now see date, month, and year. If everyone clear with this thing, what we have done here, can I get a quick yes or no? Everyone else, I hope this thing is clear. Again, very important to deal how to deal with temporal variables. Not taught at a lot of places, but you deal with them in your real data for sure. Like everything has a date and time and everything attached to it, right? Great. So I hope you are enjoying the way basically I'm teaching you with explaining everything. Okay, please make sure that you remember all these things, and when you will be doing your practicals or let's say your case study or real life project, you understand and remember all these things. Okay. This is another way to do the same. I hope you know the apply and lambda syntax, right? So x lambda, we basically we are writing a lambda function x dot x split basically. So same way to do the same. Okay. Okay, I think it's not df. 1 second. What I have to do? I can actually just do simple thing. df is equals to let's say your final df. Now it should be fine. Okay. Then I've changed all this as type int. Okay. So they were coming out. Let us see what is the object. Basically, what is the type which we are getting. So df dot info. So I'm getting int 64. Let me change it to int and let us see the final df intro. Okay, everything is fine there, I hope. Yes, Mohammed, I will be sharing each and everything with you what I'm using in the class. Okay, that should not be the concern. I think till now also I've shared everything, like the PPTs which I made, the codes which I used earlier to explain you things, so that I know that once you will be revising them from there, that becomes very useful. Okay, so no worries on that. Everything will be present in the resource section. Okay, nice. So if now this is done, I think we are good to now drop the date of journey, right? Because we have extracted everything from this. We have extracted the date, the month, the year. Then date of journey can ideally be dropped, right? Let us drop them. I hope each and everyone is clear with this thing. Divya, just practice. Practice a lot. That is the best way to be good with pandas and NumPy. Like honestly, even I have done a lot of practice, so I am able to do stuff. Okay, because I know that okay what I have to do and how pandas NumPy kind of works. Okay, it is not that I remember each and every one of the code, and to be honest, I don't even want to remember any code. Okay, it is not. I tried that in the starting when, like I would say, during the initial 2 years of my data science journey, I used to just remember the code and feel that I know everything. No, that is not the case. You should have an idea that what you want to do, and you should basically then come up with the solution. The reason being that you will not be getting similar problems. Okay, you will not be getting similar problems in real life. You will be getting always. You will be getting your change, or I would say different problems altogether, and then it makes a lot of sense to, I would say, have a case where you are able to come up with the code on the spot, or let's say by referring to some material. But that will also happen when you do lots of practice. Okay, so what I will suggest you to do, take this data when I will share this with you. Okay, make sure you are understanding this data, then work a lot around this data. Okay, if I have divided, so I have shown you two ways, lambda function as well as split, right? Use this data and see, write 5 more ways the way you can do it. Okay, see on internet that okay, how you can divide the date to get the let's say particular month and year from that. Is there any other way? Then for month, how you can change that? All this thing is to be done, Divya. There is no shortcut to that, and even if there is, I won't suggest you that. Like, the shortcut will also limit your thinking and make you think that okay, this thing can be done easily and all these things. I want you to actually spend that time. Okay, because if you do that, your industry, like the when you will actually be doing your job, that will be a lot easy. Okay, great. So now the way we basically divided our date, I think we can also see the time. Time can be divided on this colon, right? So all this I am doing to explain each and every one of you about temporal variables. Okay, this is something which we didn't cover in our theory, but of course they come a lot. So I actually intended to cover this all in your case study as well. We will see a complete case study also tomorrow. That should all be fine. But yeah, this is your overall temporal variable. Okay. So do you want a complete case study as well, where we are handling all the different variables, univariate analysis, bivariate analysis? Let me know in the comments. And now how we are doing this is, if you see arrival time, we are splitting it. Okay. So let us see what will happen here. See, this is the case. I don't care with the, I would say, particular date. That should not be an issue with me as long as I have the time. The reason is that I already have the duration, so that all should be fine. But I am able to basically first divide it on this date, and then if I divide the first one, so see, if I divide the 0th one, okay, so see what I have done here. This, let us take this example. Okay, so 10, 25, 13, March. I divided on this thing. So this becomes into 3 parts. Now if I take the first part and I divide it on the basis of this colon, I will get the hours and minutes. Right? I hope everything, each and every one of you is clear with this thing. So see how it is happening. 1 second. See. Right? I got the time. Let me clear everything. I got the time here. Now, if I get the arrival time, applying the lambda function, I just got the time. If I get the arrival hour and minute, right? So this is the time. Hour is 01, minute is 10. That I get by splitting on this colon. Okay? So see, I'm splitting on this colon. So understand these three time very nicely. This is your arrival time. This is your arrival minute hour. This is your arrival minute. So arrival hour, arrival minute. Split on this thing and then taking 0 and 1. Okay? So let me quickly just go forward with this thing now. So doing this on the arrival hour and basically for all our column, and we can then of course drop the arrival time, right? Yes, Divya sure will do that. Should be fine. So see, final DF at 5. And then just doing it for the departure hour and minute. I hope this thing all should be very clear as well. What I'm doing here for your departure hour, departure minute and everything. Okay? Departure hour, departure minute and everything, right? So getting this thing clear. Now let us get the info. See. Let us get a head as well of this. Better if I do like this, yeah. See, I have a lot of extra variables which I have included now, right? Then total stops. Okay, so if I do unique dot counts, I think it is unique dot count something. Okay, so I think it won't work on uniques. Yeah, that should be fine. So here, if you see, this is your categorical variable. Stops are your categoricals, right? It can be 1, 2, 3, or no stops are there in a flight. So people who might not be aware what happened, let's say if I am flying from, let's say, A to B, either my flight can direct go or it can first go to C and then go to this, right? It is a lot common in places. So for example, if you are going, say, around somewhere in Europe or US, then there is normally a stop in Dubai, right? Where basically few people get down, few people then join you. Maybe it is doing some, I would say, overall replenishment of resources and everything, but that is the case where it happens a lot. Okay. So your non-stop, 2 stop, 1 stop, 3 stop, 4 stops, and NANs are also there. Okay. So let us change these variables into our this thing. So understand one more thing here. Okay. Your this non-stop is 0, 2 stop is 2, 1 stop is 1, right? I can change like this. Hopefully, I hope everyone is clear on this. So this is what I'm doing here. Non-stop 0, 1 stop 1, 2 stop 2, 3 stop 3, 4 stop, and NAN I'm also basically taking as 1 only because I think that is the majority. We can take it as 0 as well. Okay. So now his null should be 1 value only. Okay. Total stops. NAN. Okay. Yeah. Okay. No, it is not 1 stop. And let me see the total stops here. Yeah. So I have a lots of total stops still. This NAN I have actually changed, so it has the values as well. Okay, this NAN was a different category altogether. Like this was actually missed, and NAN and NAS basically just treated differently. Okay. So I see if you this are there. So we'll see how we can handle it. But meanwhile, let us drop the route, I think now, because this route information we already have now in our stops and everything, right? So route just tell you that okay, how many stops it is taking, right? So I'm dropping this route. We can maybe also see that if it can be required or not. But yeah. See. So I got the total stops and everything for the NAN part, and I'm just seeing that okay, what all is happening here. Then additional info, similarly, I will do this thing. This also seems to be your overall kind of a categorical only, that it is no info, in-flight meal not included, no check-in baggage included, short layover, no info. Around 9-10 basically ways are there. So it's better if we treat this as categorical. So this actually I'm doing with a very, the way it is done in the industry. Of course, you can do a lot of complicated Python and everything on that. But I hope you are understanding that what exactly is happening here, right? Everyone, can I get a yes or no if this is clear till now, what all I have explained? Great. So now let us move forward. Let us get this info again. Let us also see the next column which we will be working on. This is the duration R. Okay. So duration R dot head. Let us see this thing. What is this exactly? Okay, I think I have 1 second. Okay, it is not durations R. What is the exact variable? It is duration. My bad. See. So it is like this. 2 hour 50 minutes. What we'll be doing here now? I hope everyone got an idea how we will be getting the minutes and hour from this, on what we will be actually dividing it. Can I get an answer in the comments to get now the hours and minute? What will be the code if anyone can provide me that? We have seen a lot of this thing now. Everyone, can I get a yes or no? Like, sorry, can I get a code how we can divide it, or just a character on which we will divide to get our hours and months? Sorry, hours and minutes. This should be pretty straightforward, I think. Let me ask like this. I think this is better. Should I use this colon? So let me like this empty space is basically underscore or comma, what should I use to split it on? What should be the case? Out of 3, what all should I use? Split. Mohammed, there should be one thing now which you are splitting as well. What we will be splitting this on? Yeah, that is right. It is empty space. Okay. So that is what I have done here. If you will see, duration, string split this thing, string 0, then string split R and string 0. Okay. So what this gave me now, let us just quickly have an idea on this. See, it gave me the exact R's. I have also split on. So once I got this 15 R from here, this is after splitting on your empty space. I also split it on this R, okay? And I choose the zeros from it, okay? So I got this value. So that is what I have done here. Similarly, we will be doing the same for your minute, right? Let us write the code for that as well. So duration, minute, string split 1, and M. See? Let us actually see this in down below. Minute. See, I got the minute as well, right? I hope this works each and every one of you. We see that this NaN are also there. So the reason NaN are there is 19 hours is there. So what we can do is we can change NaN here, the NaNs basically which we are. So see, because it was 19 hours, I didn't get the minute part. And you can see the same that in second. So let us try to this. Yeah, see in second it is transforming to your NaN. Okay, so what I can do, I can change this NaN to 0 as well, right? I hope each and every one if you get this thing. So dot fill NA. I think this is the code. 1 second. So see again fill NA in Python with 0. Okay, so sorry, my bad. I have to just write 0 here. Yeah, this should now work, right? See, easy code, right? Just fill NA 0. I thought it has to be written after that, but yeah, overall this thing is fine, right? Can I get a yes and no, everyone? If this thing is clear to each and every one of you. So I hope overall now you get an idea on the temporal variables part, how temporal variables can be handled. This had a lot of temporal variables which we handled, and how can we extract those information from that, right? This should be pretty clear now, right? Can I get a yes or no? Okay, great. So now actually, yeah, we also saw that few of the flights, 5 minutes was the duration. Of course, that's not the right part. Like, I don't think Air India can make you travel from Mumbai to Hyderabad in 5 minutes. Okay, how you will get to know the same is that, second, so we might have to see the final duration R. Okay. Which was the row. See, so if we basically move forward with our, let's say, are you going to build this model on this data? No, Mohammed, like I can do that in the complete case study, but the thing is that model building is pretty easy, right? Once you have your data cleared and everything, and this class, like this community class, overall was dealing with your data science. Can do that on the complete case study, can do that on this as well. Should be pretty straightforward and easy. But right now, won't be doing that because I don't want to teach you about modeling as of now. I did that when we did the case community class on your machine learning, right? And normally, if you would have done few case study or something, you will know that applying model is pretty straightforward. Rather, I would actually like you to give this as a, I would say, work where you are applying models onto this and seeing, let's say, the result before EDA. Sorry, before EDA feature engineering and all this, and your after EDA, after your feature engineering and all this. Right now, I want to make sure that you understand these variables because you will be dealing with this a lot. Okay. So similarly, we saw that somewhere the information was wrong only. So it makes sense to basically drop these things. Okay. So we can also do one thing, filter rows where it contains a string in pandas. Okay, so let's see what I'm doing and what I'm searching, why I'm doing this thing. Okay, containing a string pattern from pandas. Okay, so contain is the function, not string. See how I will use it to get all these variables. Okay, one was this, then final DA dot your duration underscore r dot string dot contains m. Okay, I think we missed something here. What we have missed? Okay, makes sense. Yeah, 1 second. Oh, sorry, my bad. This is what I messed up. Duration should be defined either. Okay, my bad. Again, yeah. See, okay. Okay, 1 second. Then what we can do, because this is true and false, final DF. It is saying unmatch. Okay, I am making this many mistakes. Should be fine. See. So I'll explain what I've done here again. Yeah, they were like I messed up the column, but see, this gave me true and false here. Okay, and what I did was I just basically passed all these array of true and false to get the value where it is true, and I contain that it contains m. Okay, so on that way I was able to check. Maybe similar thing we can do for your, so let's say final DF, we made duration minutes, I think, right? So duration minutes, and let's say it contain h. Okay, I think, okay, it has NaN, so we might have to deal with them, but should be fine. So let us see for duration r only. So once we saw that, okay, 5 minutes is there, then of course this is a mistake, right? Now this thing is mistake. Now see, here it was no NA, no missing values, no outliers, nothing, but the value overall is wrong, right? Data is wrong. So this kind of condition you also basically get in your real life scenarios, okay, in the real life data. So what you will do, we will just drop it and basically in place, just make sure that our data is free of these things, because I hope you all are clear why this is wrong, right? Mumbai to Hyderabad, we cannot calculate by this. What I have done personally, another thing what I have done personally in this data is, I would have calculated, seen all the Mumbai to Hyderabad flights where the stop is 0, okay, or let's say stop is 1, and then try to basically fill that with this value. Do you think this is a good idea? What I am saying is that I would have see that how Mumbai and Hyderabad, basically all the other flights in this data. And one more thing, I will be just doing this with respect to this data only, okay? Not from outside as of now, because I have the data present with me. So Mumbai to Hyderabad, I will see the distance for flights where the stops are 0 and everything, okay, and then fill in this value. And let's say maybe I would have then applied other filter as well, like let's say in 2019 only, okay, because if let's say some data from 1980 is present where it used to take 5 hours, that kind of is irrelevant to me. Now these are few of the decisions which you have to take, and that actually are based on your business understanding, okay. I hope everyone is clear that the way I would have handled this. Let me know if any other way which you have handled this, like when you got this project or when you got this data. So right now I'm removing this, but yeah. Similarly, I'm changing this thing now. This duration that I'm changing to your int. Okay, we can do the same for duration minute as well. Now dropping the duration column, it doesn't use like no head case, no use cases there. This is one of the like how our data seems now. Okay, and let's see airline, unique airlines are there. Okay, so airlines, I hope you all understand it is a D type object, it is a categorical variable. Okay, and no airline, so in this airline we don't have any ordering, right? So in this airline we cannot say that one is greater than another. I hope you all understand the same. Shalmali, so what we do is that for hours and minute, you can do that. Like we know that 5 hour, let's say 5th hour is greater than 0th minute. So what our model, it might not understand that, say, it is 0 or it is, let's say, 23rd hour, but it know that okay, this is basically moving on to that. Okay, so it's better if you convert this to int only. Okay, I have covered a lot of cases and would have explained that in the previous basically code as well, but yeah, it makes sense to do that. So now pretty straightforward code now. I think all of you remember. So instead of changing this by 0, 1, 2, I told you the concept of male female, I hope, in the initial starting, right? So see what we will be doing now. Okay, here we have just fit transform on all the type of basically your I'll explain what I've done here. So from SQL and pre-processing, we got the label encoder. We fit transform on a labeled encoder for all the basically all of your categorical variables. Okay, so that is how we deal with categorical variables. So we fit transform on this data. So what I've done is airline. Now this code it would have understood that okay, what exactly is happening with the airline. Okay, and we will see the same. See, it has changed them into 3131 like this, source 03. Okay, all of this has been done, right? So let us see this variable as well. See, 0313, all these kind of things is happening, right? One second. I think this is one hot encoder which we have to use. So one hot ESK learn, we have to just import it. So what I might have to do here is the code basically why it is giving error. Just let me quickly see. So from sklearn.preprocessing import one hot encoder as OHE. Okay, it want your X as well. So let us give it your X as well. I think it will be final DF. Fit okay. I think you can see the same, that should be fine. But meanwhile, let me just see that okay, how we can use this one hot encoder. That should be fine. Okay, this is pd.dummies. Okay, this is another value how we can use the same. So pd.getDummies actually help us with the same. So source 1, source 2, true, false, like 0 and 1 it is giving, right? So airline also, either you can use one hot encoder, okay, or what you can do is you can use pd.getDummies. So in getDummies it is doing the same thing. See, so quickly let us see that okay, how many airlines we had? 11 airlines. So see, for 11 airlines, false, 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 right? Then source 2, source 1, source 3, like this it is doing. Then destination 1, destination 2, like this it is all doing everything. Okay, everyone, I hope this thing is clear. This is the same thing which I explained you for male and female, right? So 0, 1, it is basically dividing it into gender 1, gender 2, and similarly just doing true, false, right? I hope each and every one of you is clear on this. This is a very detailed case study on temporal variables. So now you should never face an issue with handling the temporal variables. I've covered most of them, right? Please let me know if any doubts are there. So we also do have a like case study which I covered in your ML thing as well, but I can try to find another case study as well. So let me know on that as well, ki what exactly you want me to cover on the case study. But here we will see different things, right? So this is your pre-processing where we are making lots of graph. Then this is your EDA. Okay, so you will be doing univariate analysis and bivariate analysis to get the things. But first, let me know that if this thing is clear, what all I have explained in the two data sets today. So we took the house data set. We saw that how to handle the missing values and what all we have to do, and the flight data set. This was majorly done to explain you everything on the temporal side, right? So let me know if everything is clear. if all things are clear and everything, what all is there anything which you want me to explain again? While filling data for missing values, we need to get data within the data set or with domain expertise. Divya, like it depends if we can actually get. We have to understand and discuss that with the client and everything. You can get that from outside as well. Let's say from outside is present. For example, in the Mumbai Hyderabad case, like the flights were there, right? Maybe if let's say Mumbai Hyderabad flight data is not present, like let's say the case is where all your flight, where your source is Mumbai and destination is Hyderabad, it is not present. Okay, in all your this data. Then instead of dropping it, what you can do is that you can make sure that you are getting this data from the internet, okay, and filling it. But one thing is very important to understand here, that we will have to connect and basically I would say communicate this to our stakeholders. Okay, so whoever has given you data, if let's say it's a client project or let's say if it's a project in your company, we will have to make sure that we are writing that, okay, this is from where we are getting the data. Okay, so the source is there. Okay, it is not the case that you cannot get the data from outside. It might be required to get from outside. The first way will of course be that if you can get that within the data and everything, but you can get that from outside, but you have to make sure that that has been well communicated, because else you can take data from anywhere. The resources or the source might not be, I would say, verified, and that will give an overall problem. Okay. So everyone, let me know if everything is clear. I think we are on time. Yes, it's 12:58. So we will be doing a case study tomorrow where we will be seeing other things as well. So in that, what all steps we will be doing is we will be getting the data. Okay. Doing your pre-processing, then your EDA and everything, along with that feature engineering, and then finally maybe we can apply the models as well to see that, okay, what is the final benefit and results which we are getting. Okay. So can do that as well tomorrow. That should all be fine. Okay. Give me a quick yes or no if everything is clear. If any doubts are there, please feel to ask them. And please make sure that you basically enroll in the course on iNeuron website so that everything is clear there. Okay. Like you are able to get the certificate for this course as well. Okay. Thanks, Divya. Thanks, Mohammed. Thanks, Meenal. Yeah. Divya, big data is a very big field. You need to have a lots of concept clear. We'll see if that is required, but I think should be fine. First, get the understanding on this data. This just gets transformed in there. So for the timing, I will suggest that understand this thing properly. Big data, you have to learn a few of other things: Hadoop, Spark, Kafka. Then how to handle then I would say streaming data. Okay, how to make sure that you are able to catch all the data, nothing is getting missed. So all this thing is there. Okay. So big data thing we'll discuss further afterwards. We will also have a case where maybe I will try and see if I can take a community class for big data, but not committing. First, I think we have few things which we have to cover in data science, statistics, and all these parts. So first we will cover on that. Okay. Then we will see. So big data also maybe 2-3 months down the line, maybe I can see and check if I can take that up. And basically, yeah, we should be good for the same. Okay. Great. If anyone has no other doubts, I think it's we can drop. It's thanks a lot for your attention, everyone. Okay. Please go through the code and everything. I will provide all the resources in the resource section. You will be able to get them. Okay. So thanks a lot for your time, everyone. It was really great. We did some good projects and everything. Like if you understand this, it will be a very smooth sail in your industry projects. Great. Let me end the stream. Thanks a lot, everyone. Great. So I think no doubts are there. Then I think we should be good to begin. Okay. Please let me know if anything is there which you want me to discuss. People are still joining, but I think we should be fine. It's already 11:06. So yeah, just let us first go for all the setup and everything, because many people would be joining for the first time. So iNeuron.ai, that's our website. You can also go search for iNeuron on the Google and you will get here. Then why are we showing this? Because this course, it is live on YouTube, but basically this is also as a course on our website, basically iNeuron. Okay. So how you can access that? You have to go to explore courses. Also on the same note, please, a very happy International Women Day to each and every one, and please make sure that you check out our courses. We are running the discount on the same. So next is like how to access the courses. There are of course many courses which we are running. Okay, so feel free to check them out. And for the specific course which we are taking, just go to instructor and Mayank Agarwal. Okay, so you will get data science foundation here. So this is actually the course which we are taking. It is live on YouTube, and here also you can. One second. Yeah, and here also you can actually access it. Next, I will highly suggest to once you complete this. Okay, this is the next course which you should start with. Okay, because now you have almost done with data science thing. Okay, few things will be there, but that you will get to know once you do the projects, and let's say once you will revise all the things and few things I would have said. Okay, so if you research those things, you will get to know, and that is always a continuous process. Like that will never stop. Please don't limit yourself even to what just I have taught. When you will do the projects, you will get to know about other things. Okay, I will discuss in the end that how you can now move from here so that your journey in data science is very smooth. Okay, once you complete this, so hopefully we will be completing the this community class today. Then you can actually be very good to start with machine learning foundations. So the videos are present on YouTube as well. I will show you the same. Okay, so you can enroll now on this thing. If you have already enrolled, you will just basically see the screen like this. The good thing here, all the videos basically in sequence along with your quizzes and assignments are present here. Okay, so just make sure that you are doing all of them pretty nicely, all the assignment quizzes. Once you complete each and every one of these things here, then is when we will be more than happy and be able to provide you with a certificate, okay, which you can basically showcase including your CV and everything. Okay, so another way to take this class is to go on iNeuron channel. One second. Great. So if you go on iNeuron channel basically, then if you go on live, this is where our class is happening, right? So this is the current class which is happening. Of course, there's a few delay, but this is from where you can access the class. And yeah, drop your like, comments, and share. All these things will be very motivating and everything. This is me on the big screen, but yeah. So let me also show you where you can access the ML from YouTube as well. So if you will just scroll down, you will see machine learning. Yeah, so here's the ML case study. We have done a case study on ML, then decision tree, and all these algorithm, name-based algorithm we have covered. I think in the playlist also we will, yeah. So basic of stats is there, and then machine learning foundation, this is there. Okay, so machine learning foundation is there, which you can start after this. Right now we are on data science foundation. So yeah, this basically connects after this. Okay. So I hope each and every one of you is clear on the same. Please let me know if any comments are there. Meanwhile, if everything is good, let us start with project because that is what we intend to do today. Okay. Today it will be a full project on data science, and we will be seeing the data. We will try to understand the data. I will tell you that what all things are there. If anything is there which you want to suggest to me, please feel free to write them in the comments, and we can also do that on the code. Okay. It is not that honestly there are just some lines which I will be running and just explaining. You know, if you feel that anything else can be done or included in the code to do better EDA, to do better feature engineering, okay, something in your business sense or something, let's say based on your understanding, might be better than even what I have done. Okay, so please suggest that, and I will be more than happy to write that in code, or even give me the code and we'll include that. Okay, so for one more thing which basically I would like to share, because few people are asking on the same. Actually, let me okay, so data science foundation, if we go, so let's say for the yesterday's class, if you will go on data science case study, then here are the resources. Okay, so here are all the resources which I use. Please feel free to check them out, download them and use them. Okay, so you can make your notes, doubts, feedback, all these things also you can give and basically make sure. Okay, else you can also reach out to me on my mail ID. It's mayank@iNeuron. Do give a good feedback as well, so that we are also motivated. You can make your notes as well. So yeah, I think it makes a lot of sense to also see these videos whenever you are revising or anything on the iNeuron platform. Okay, I hope everything is clear now. Can I get a quick yes if all is good and we are good to begin? Everyone, can I get a yes if everything is good? Thank you, Mr. Strange. Ideally, I think it should have been Doctor Strange, but anyway. Thanks, Divya. Everyone else. Give me a quick yes if all is clear, and also just let me know if you're able to read what we have in the screen. The code is visible. Okay, that is also very important. The full code should be visible to you because, of course, we will be doing everything with respect to code only today. Okay. Thank you, Debashish. I hope everyone is able to see the code and everything is fine. Can I get a quick yes or thumbs up? That will be a lot helpful. Great. So yeah, let us now start with today's project. Okay. So before actually starting any project, what I normally suggest you to do is actually to go to the data. Okay. And let us see, this should be the real data which we have. Okay. So we will actually take this project the way I will expect, or I will actually do this in a company. Let's say if I'm given the same, or let's say for a professional setup. The very first thing is we will see the data. Okay, that is very important. Like, forget you are a data scientist, forget everything, what you know and what you don't. First, go and see the data. Okay, that is the most important thing. Okay, don't just rush into loading the data and running Python commands on it. No, I normally suggest to spend a good 1 or 2 days on the data, try to understand what everything is. Okay, for example, in this thing, gender is given, pretty straightforward. Race or ethnicity is given, and we see that okay, few groups are there. So this, now if I have the intuition, I will say that race or ethnicity might play a role, might not. Depends a lot from where data is. Okay, in real life that happen, but I won't let that creep in. Okay, I will just think on the same and keep that in the back of my mind. And when the data will actually show me the insights, then is when I will basically get them confirmed. Okay. Parental level of education, of course, very important parameter. Okay, some college associate degree, high school associate degree. Okay, then again, normally how it happened. So this is very, I would say, kind of a data set which I discuss a lot in my examples as well. That student few details are given, and then we have to tell what score he is getting. Okay, so we'll see the same as well. Now, parental level of education, of course, it's an important role. Normally, what happens is that if parents are educated, then it is more likely that they will be stressing upon child education as well. That is something which we know or which we have seen. But again, that intuition will get, I would say, confirmed once we deep dive and do ED on our data. Then lunch, standard, free, reduced. Okay, it is basically how the lunch is served. Okay, let us move a little forward. Yeah, pretty straightforward. It's pretty easy data, I think. Then math score, reading score, and writing score. Okay, so these are few courses score which are given, and test preparation course. Okay, if he has completed or not. So ideally, one would understand that if a particular student has completed this course, then he will basically have a better chance of scoring good. Okay, that is something which we have an idea, but let us see. Okay, like let's say none and completed. Here it is almost equal. Here it is greater. Here it is also greater, right? Then let us take these two examples as well. So here it is greater. Here it is greater. Here it is greater. So this seems like this is the case. Anything else which any one of you is able to make from just seeing the data? Can you let me know in the comments anything which you feel is basically an intuition or an insight from the data as of now? Let us make this, okay, so I want to make this two-way communicative, okay, not like some movie where you're just seeing me doing or running the code. Please suggest your, I would say, insights. That would be a lot helpful, because that is what you will be doing once you take up this project, right? Or any project like this. Let me know. I'm waiting on your insights, everyone. It's a very easy data, I think. Anyone can have few, like can have few insights. Even I have seen the data after a lot of time. It's very straightforward. I think we have 1, 2, 3, 4, 5, 6, 7, 8 columns. Okay, so we have 8 columns. Let us see what is basically your overall target variable and everything. We will see on that. So everyone, can I get a yes or thumbs up if everything is clear? That's the first thing. Second thing is, if any one of you have any insights, please let me know in the comments so that we can have that to basically those who completed test prep may have scored high. Uh, that Mr. Singh I have actually covered already, right? Any other insights? So we saw for two examples as well, right? That if these are the two cases I took, and then these are the two cases I took. Okay. So everyone who is doing this, please, I will suggest highly to do the same with me. Okay, so that we will have an idea. We will basically get to understand these things together. Don't want it to be just a single like I'm doing all this because I've already done projects way complex than that. But what I want to understand is where you are thinking. Okay, how your insights are basically helping you. So that is the thing which I'm interested in. So let me know. Meanwhile, I think it's better to move forward with respect to time because I intend to cover two projects. Okay, two entry-level data science, full data science project, which will be a lot helpful to each and every one of you. Okay. So now let us go to the code. Okay, the reason I normally load the code is because it's better. Like in this setup, it's a little difficult to write the code, but let's say from the next time, although I think it's better only because I'm able to explain a lot better. Okay, it is way better than me sitting writing the code and then explaining. It just takes a lot of time. Okay, but anyway, I have given the full liberty that any one of you is not want me to like include any code, have any issue understanding any code. Okay, although normally I try to basically explain everything, so please feel free to jump in and suggest me the same. Okay, we are not doing this case study as a one way. We will be keep this interactive and discussion based. Okay, so cool. Let us now first understanding this is the life cycle of your machine learning project. Understand the problem statement. Of course, this is what I say as business understanding normally. Let me remove this. Yeah, this is normally what I take as business understanding. Okay. Then next one is your data collection. This fortunately have been done for us by the data which we have. Though it is still will be better if let's say anything data which we want from outside. Though I don't think that case is there. So I normally treat it as internal data and external data. This seems to be very straightforward case. So I don't think external data would be required. Then data checks to perform, we will see on what exactly to do. EDA is there. Then data pre-processing. I think these all things we have already done. Okay, what all these things are. And then your model training. Somebody asked me yesterday if we will be doing model training as well. So yeah, we will try to do the model training on this data today. And choosing the best model, which is basically giving the best results, right? So these are all the steps. I hope each and every one of you is clear on these steps. I have covered them a lot of time in my data science foundation, machine learning foundation, and normally also. I hope everyone is clear with this thing. Can I get a yes or thumbs up if everything is clear? Great. Meanwhile, keep on giving your insight as well. That would be helpful. Thanks, Mr. Strain, Divya, and Devashish, Praveen, everything. Thanks a lot. So yeah, let us move forward and see what is the problem statement. And one more thing, I will suggest each one of you highly, please make your Jupyter notebook in this case. It should just not have the code. The reason is if we have to write a code only, then we do have other IDs. Okay, Jupyter notebook. The reason we choose Jupyter notebook in data science project or for ED and everything is that we have the liberty to basically include a lot of insights and everything. Okay. So now if you will see, this is the problem statement. Problem project understand how the student performance test score is affected by other variables such as gender. We saw the gender, ethnicity. We saw ethnicity was there. Parental level of education, lunch, and test prep. So I think it seems like there are 3 dependent variables. That is what I have the idea, and 5 independent variables. Okay. So what is happening? Your 5 of these variables are kind of affecting 3 of your scores, which kind of makes sense. Like these are the, I would say, features, okay, which will have an effect on a person's score normally. Okay, so it can be different exams, but normally I would say the input for that remains the same. Okay, so for example, if let's say this particular student, he is good at studies, normally the case will be that he will be scoring almost equivalent or good in all the subjects, right? So don't get confused if let's say 3 variables are there. You can even take this as single. Okay, that should also be fine. So for your model, just take it as a single variable as well, because these features are more or less the same, like which will affect all the things, I would say equally. Okay, I hope this point is clear. Can I get a yes or thumbs up if everything is clear here? Great. Just because this data was a little bit, I would say different, like normally we have more than one target variable, so that thing is better if we clear this out. Normally, anything which we start, we import our libraries. Pretty sure you must have an idea on this. Ideally, what happens is that we first start with Python, understand these libraries and everything. Then we basically get to your data science, then machine learning, then deep learning. That is the thing which we take. If not, let me know. We'll can plan I think a community class on Python as well, but I think it has been already being covered by Prince sir and everyone else. So do check out our YouTube channel, or let's say the course on that. Okay, that should be helpful. Now NumPy imported, Pandas imported, SNS Seaborn for plots, Matplotlib for plotting, Matplotlib inline I showed you yesterday. Can anyone know, like tell me what is the use case of this slide, Matplotlib inline? Then something for warnings and filter, like warnings we are ignoring. Okay. Can I get the use case of your matplot inline in this thing? That would be helpful. So let us load all the libraries. They are loading. Here is where we see the code is running in the backend. Okay, so that is very important to know again. Just let me know what this line does, everyone. This is very important to understand. Then we read the data. Okay, and the df.head is basically the case where we see the top 5 records. Let us clear everything. So just let me go a little bit above. I'm still waiting on matplotlib inline. I covered that yesterday. Let me know on the same. So we have already seen the data, but yeah, like just let us have a quick look again. So if one more thing, if I see, I think these all seems to me like they're categorical variables, right? Qualitative variables, right? And the target ones are basically your what we say, the numerical variables. The very basic idea which I get based on my understanding is that it will be a very good use case for a decision tree or random forest type of algorithm, right? Because few if conditions will be there, and based on that some score will be calculated. Okay. So let me know if everything is clear till now. Meanwhile, let me look at the comments if anything is there which you are not understanding, and hopefully someone would have explained on the matplotlib inline, because that was covered yesterday. Okay, so let me see. Can we sum all target column values for a student? No, Rajkumar. I think that is not the thing which we need, na. If we even sum this, that will just confuse our model and everything. Maybe the way I actually would like to see is if I can. Okay, if I have these variables for a particular student, okay, all the 3 I have to basically predict most probably, right? So we will see, but I don't think summing will help. We need to basically get the data in this format only. Okay, so that will basically be required. So let us not sum up this. Let us keep it the way they are. Okay. Enabling the drawing of matplotlib figures in the IPython environment. That is true. Figure will be open in new, but if we use inline, it will be yes. Divya and Mr. Chain, that is right. Okay. So let us quickly move forward. I hope this thing is clear. Then just let us see df.shape. Okay. 1008. We are pretty clear on the same. Now quickly understand the data set information: gender, sex of student, race, ethnicity. So it is a very nicely given. So it has 2 categories. It has 5 categories. Then 1, 2, 3, 4, 5. It also has 5 categories. Lunch have 2 categories, and test preparation is also have 2 categories. So it is a very good data, I would say. Like the way they have provided us each and everything, that will help us a lot. And I think it's a perfect data if anyone wants to do their first project. Okay, because it is pretty simple, right? You are not just unnecessarily getting complicated into things. You will be better off not spending your time in ED and everything than seeing the missing values or finding these things out yourself. As you move forward, it will be better if your data set or project become more complex then. Okay. So let us now move forward and see your data checks to perform. Okay. 1 second, let me clear everything. Check missing value, check duplicates, check data type. Data type already we have checked though, but should be fine. Number of unique values of each column, that also makes sense. Statistics, we do that. Ideally, this can come first also. And various category present in different categorical columns, okay? So they have given us, but still we have to see that, okay, how many of them are, let's say, race A, how many of them are race B. This thing we still have to check, okay? So let me clear everything. Now let us quickly see check missing value. So pretty easy. df dot is na dot sum. It is giving us all the missing value. We see that there are no missing values. If there would have been missing values, which I would say, let's say if the missing values were in top 5 columns, okay, the first 5 column, which thing would I be using? Mean, median, or mod? If let's say it was present in column, like not these columns, if it was present, which thing we would have been using? If that would have been the case? Yes, nice, Rajkumar. It will be mod because they are all categorical variables, okay? So these things should be very quick and I would say remembered by you, because when you will actually be doing your projects, okay, so these kind of decisions you will have to take a lot quickly, okay? Divya, it won't be median. Please don't make such mistakes. These are all categorical variables. Median won't be very helpful here. If for these 3 it is present, then it can be median. If let's say for these 3 it is present, then it can be median or mean. But categorical, mod, or KNN basically we will be using. Now let me remove everything. Okay, similarly, let's check duplicated values. So df duplicated. So what exactly duplicated values are? I hope it is pretty easy to understand. Let's say some value is basically added 2 times. Okay, let's say student ID 1, male. Okay, let's say parents are high school. He's getting 39, 39, 39. So same value is present. Okay, so it's better like we remove these values because they would just be like adding more, I would say, complexity in the data or collinearity in the data. It doesn't make sense to have multiple values which are exactly the same. Okay, so in any data set, it is very easier, I would say, straightforward to remove these duplicated values. Okay, quickly let us check the data columns. Pretty easy, I think it is. Your objects, everything is object and others are int. Okay, let me know, see the code. If you want me to do anything, if you want me to include any other code, please ping that in the comments and I will be more than happy to include that. Okay, so number of unique value in each column. So that also does makes a lot of sense. Gender too, we are already provided with that as well, like above we were provided. Score, it doesn't make sense. We know that it is not your categorical variables. Okay, so it is expected that scores will be a lot. So df.nunique is your function by which you can do the same. Okay, gender is there, race is there, parental level of education. So seems like a pretty good data. Okay, so let us move forward. df.describe, one easy function to get all your stats out of the data. Okay, so count is 1000 for each and every one, of course. Okay, it will be just giving, we will be getting these statistics just for numerical data. I hope each and every one is clear for the same categorical variable. We cannot get the mean, right? Can I get a thumbs up if this thing is clear? Because once someone asked me, sir, why I'm not getting the mean for your, let's say, gender, it doesn't make sense, right? So if we see, we have the mean math score. So seems like mean is pretty straightforward for each and every one of these. Okay, that should be fine. Then 50th percentile is very close to mean. So it does seem like it is a kind of following a normal distribution, which kind of makes sense, like because mean and median are pretty near. So it makes sense that some data would be something like this. Okay, like mean is there, median is also somewhere here only. So few people would be scoring very less, few will be scoring very high. Okay, so kind of seems like that would be the case. Data is also basically suggesting that. Max is 100. So we do have some students who are doing pretty good at all the scores. Okay, so for all the scores, we have max as 100 and of course 75th percentile as well. Okay. Now we have the insights. Please make sure that you also write those insights wherever you are working. Markdown is a format in which you can write those insights. So please make sure to check that out and make sure that your Jupyter notebooks are very properly documented. Okay. So numerical, all means are very close to each other. Then standard deviation are also close. Well, there is a minimum score of 0 for math. For writing, minimum is much higher, and for reading, it is also. So maths, one student is actually doing pretty bad, or basically we have messed up. Maybe the data is not right, but kind of seems that some student is doing pretty bad, or he have missed the exam. Okay. So let us now explore the data. We will see each and everything what we are doing. Pretty straightforward, very easy code. Does seems to me as well. So categories in gender variable, basically we are just seeing each and everything. That should be pretty straightforward. It has already been given to us in the starting as well. So in this all information we have in the data understanding as well. Then let us now see for the columns. So pretty easy. I told you yesterday, D type O and D type not equal to O for categorical and your numerical column. That should be straightforward. I hope, I guess. Okay, so now we are adding your column for total score and average. Okay, so this column we are adding to enhance our data. Okay, it is not, we will not be predicting it. I think someone had a question, so I thought that he's asking for predicting that value. We will be predicting our 3 values only. That should be fine, but we are just adding that to get more insights. The case is that in our test data we won't have these 3 scores, right? Let's say when we get our test data we won't have these 3 scores, so based on that we won't be able to find out the average or your total score. Okay, but in your EDA that can maybe provide some insights. Okay, so that is why this thing is happening. If you cannot do that in tests, so you should not basically try to not train your model on that thing. Okay, now great. So we have just calculated your total score addition and your average score. Code should be straightforward, pretty straightforward code. That I think all should be clear. Then we are taking that, okay, how many students got the highest marks. So df writing is equals to 100. 1 second. So we are also seeing full marks. How many students got full marks? So it seems like writing and reading people are pretty good. Maths, everyone is kind of struggling. I think that's the case. Then we got how many students got less than 20 marks. Again, same seems to be the same case. So what inside from above we get students have performed the worst in maths. Seems pretty intuitive, and best performance is in reading section. Okay. So let us start with histogram. Everyone, exploring the data. Everyone, can I get a quick yes or no if everything is clear till now or not? Give me a yes thumbs up if everything is clear. Straightforward. We have targets, so it is supervised learning. Yes, Rajkumar, that's the case. It is a supervised machine learning algorithm. Great. So yes, everything is clear. Let us now histogram and kernel distribution function. Let me explain what normally KDE is. So let's say whenever you are making a histogram, to now see that what kind of particular, I would say, distribution my code is following, and I think I have showed each and every one of you most of the graph which we get in statistics, right? So to see the same, actually, we use KDE, which basically kind of gets the rough estimates of our data. So it draw a line like this. I will show you with both the things so that it thing is clear. First, let us remove this KDE is equals to true. Okay, from one of the column. See the difference if you will see. So this is just your normal graph which we have got. I think it's a little bit skewed. Let me use red pen still. It's a little bit skewed, but it is kind of following a good normal distribution. Okay, and let me remove everything so that this side is also clear. Let me remove this thing. So this is a little bit skewed, but similarly on your average as well, if you will see, so the graph is, this graph is same, but here the KD is basically based on gender. Okay, so for different gender, what is the case? So now if I see with respect to that, it seems that female on average seems to be scoring a little bit better, like the count and the average is pretty high. Okay, so if you will see, it is coming somewhere like here and somewhere like here, and the count is also high. Okay, so if you will see, so it seems like female are scoring better than your males in this case. Okay, so now let me remove that KDE function. Let me add it back. Okay, so we will get this thing again. Now just one thing you have to remember, KDE true, hue gender. Okay, that's what we selected here. Then I think color we can also choose red here. That should also be fine. See, okay, I think for line already you have to choose that, but anyway. Okay, so that's how we. Aditya Singh is asking, can we provide the CSV data or give link to add data set. Aditya, I will be actually providing you with everything, the code, data, and everything. So should be fine. Right now in the community class, I will suggest to just focus on what I'm doing, and if anything is there which you want me to add, please write that code in the comments, and I will be more than happy to include that. Okay. Once you get the data, you can do all the work on the data, and everything should be fine. Okay. Can we create bins for target like low score, medium score, and high score? Yes, Rajkumar, we can do the same. That should be fine. Okay. We can maybe see that where the percentiles are following, and based on that, we can do that. We learned two cases for creating the bins. If you remember, that one was equal frequency, one was equal width, right? So I hope this thing is clear. So yeah, this seems to be the insights that female students tend to perform better than male students. Then few of your other graphs with respect to average, we are seeing that other categories what effect they are having. Okay, so for average, okay, hue is lunch. Then for particularly female, average and when lunch is there, so something like this is what we are doing. Okay, so if we see here, average score is there, and when the lunch is standardized, okay, the count is more, and student also kind of seen that he is doing better. So that is how we get the insights from the data. Okay. Then in the next graph, we have his plot. When gender is equals to female only, X is basically average and your hue is lunch. So for females, also I think we see the same kind of a thing, that when it is standard, okay, we are getting it the same way and in a similar way. So in the first case or DF, and for the male as well. Okay, the male it is I think standard. Yeah, okay, it is same, just the color I think is inverted. That should be fine, no worries here. So male also the case is same. It seems like by gender and by lunch, if we see the same standard lunch, normally if the lunch is standard, it is basically giving you overall, I would say, better results. Okay, that is the case. I think if you each and every one of you basically see the thing, right? Can I get a quick yes or no if everything is clear till now? If any comments are there, please feel free to ask them in the basically comments or anything, or if any code which you want me to include, that should also be fine. Aditya, I hope your data query is solved. We'll be providing everything, that should be fine, right? Meanwhile, yeah, please write in the comments if anything is there. If any code you want me to include, all this should be fine. Okay, so I see one question is there from Aditya. Can you disk plot explain the difference between hits? Aditya, I didn't get your question. Can you disk plot explain the difference between his plot? If you are asking for the difference between disk plot and his plot, I think that's your question. If I'm pretty sure, can you just confirm me if that's what you are asking? Everyone else, means fine, just let me know if anything is not clear or anything. That should be helpful. Aditya, can you please just write your question again? Akshay is saying, sir, can you please tell us how statistics help us for building the model? Akshay, if you will see the first video where I've covered the linear regression, it is basically fully based on statistics. I normally say machine learning is just stats on steroid. Okay, like that's how exactly it happens. So what happened is that in every model of machine learning, and majorly every model, what happened is that based on statistic and everything, we try to fit out something, make out some if conditions, okay, or let's say try to fit some line or something. Let's say line equation is your, let's say mx plus b, which is very common in your linear regression, logistic regression. So we just try to basically enhance or optimize on these variable. Okay, so the thing which happened is that based on different statistic things and everything. So let's say I will get, okay, what is the mean, how my error is basically far away from mean, and what is the actual, and all these errors. So based on that, basically we try to come up with what will be the best fit line, what will be the best if condition and everything which can fit my data. That is very complex if you try to do it one by one yourself, but via maths, basically it becomes easy. So stats, like there are statistical models like linear regression, logistic regression. Then on probability there is naive Bayes. Okay, so these kind of models are of course helpful, and machine learning is actually just maths on steroid. A lot heavy on maths in the backend if you will go, but that is how we come up to this thing. To understand exactly, I will suggest very properly to go and check out my videos on machine learning foundation. I have covered everything that how we came up with the derivations, because once you understand the derivation, then you will understand that how maths is involved in the same. Okay. Great. Okay, Akshay, I was able to. Mohammed is asking what can we infer from the graph. Aditya, I'm still waiting for your question. Can you let me know if that is the question? Normally, I can just tell you on the his plot and bar plot, Aditya, that what happens is that we use both for your continuous variable. This plot just uses some other, basically your function, and doesn't normally show more than 50 bar. It kind of, I would say, normalizes that. Okay, but his plot basically just continue. His plot is histogram normally the way we have studied, right? So it will just for continuous variable, it will just try to basically plot them, and then based on that we can basically get our insights. This plot is basically more or less a little bit version which has been modified. I forgot the name on something it was built. I didn't get it. I'm not able to remember it. Maybe we can Google and just search for the same. That should be fine. Akshay, I hope your question was clear. Mohammed is asking what can we infer from the graph. Mohammed, just please please pay very close attention. I'm choosing green for this because green we are not using. See, this is your average score. Okay. Now, these are the few things which you have made. With respect to lunch, you have made your KDEs. Okay. So now, if my standard lunch is there, I see that my count is high. Okay. So I have more people who have standard lunch, and similarly, my average is also high, right? So what is tell us is that your average score is better when lunch is standardized. Okay, you cannot, just don't get confused with this thing. This we have just done by a graph because that is pretty straightforward and clear. What you can also do is you can take, let's say, your standard, your lunch, okay, standard. Actually, let me show you this thing by writing the code. That would be better. So let us just write few code. Okay, df lunch is equals to standard dot info. I think will be better, right? Yeah. Okay, not dot info, dot describe. Great. And so Mohammed, if that thing is giving you a little issue, then let us take a look at this. So I will explain you what I have done here. Okay. Lunch is standard, then I'm getting all the describe. I'm describing everything. Let us see what is your average score with that. Okay, so average seems to be around 71 something. Okay, and all the scores is around the same only. Okay, kind of it should be ideally also. Then let us see if it is not standard. So here what I've done is it is not standard now. Let me remove this thing. Like that's one thing I think like the drawing should also move a little forward. But anyway, uh, if it is not standard, if you will see here, it is not standard now. So in your describe, your median is basically aiming out to be like this. Okay, and your mean is also basically following. Okay, so what is happening is that for the cases where lunch is standard, you will see it is 70. Okay, so standard, when the lunch is standard, let us write your mean and not standard. Okay, I'm writing like this, not standard. So your mean is there, right? And let's say median is there. So when your mean for your standard case, the the mean is around 70.83, median is around 70, so this is median, this is mean, 71.33. When it is not standard, mean is around 62 and your median is around also 62. So just forget everything, Mohammed, now and just see this thing. See how much difference is there, right? So what does this tell us? Standard lunch is better. I hope this is clear. Mohammed, can I get a quick yes or no if this is clear or not? Just explain you why another way, just seeing the numbers instead of the blot. Can you plot a student is female and receives standard lunch and parents are educated with university degree and considering effects of all variable together? Rajkumar will do the same. So the thing is that we move in steps, right? So univariate, then we include variables. So everything we will be seeing, that should all be fine. Straightforward and easy to do, that is not the case. Like we won't be facing any issue. Okay, the way I have, so see what you are doing normally. Just it is very easy. df dot lunch, df dot gender is equals to say female. Okay. I think it takes in Python. So something like by adding these conditions, we can actually create a graph. Like we can have this data separated, and then we can plot this. Okay, so you're saying student is female, receives standard lunch, and parents are educated with university degree. Okay. So parents are in university degree. What were the parents? I don't even remember what was the parents' degree, but anyway. And df dot parental level of education. I think it will not take this as that. df of 3. 1 second. It is not giving me that thing because, yeah. So I will have to take it on the basis of log. So df parental level of education. Level of education. So something like this by using this thing. Basically, who was the question? Yeah, Rajkumar. So what you are suggesting, I hope this is clear. If we basically keep on adding a condition like this, you can then separate this data set out, or you can basically pass this data set instead, and then you can see the effects. Okay. I hope this thing is clear. So can do that. Rajkumar, pretty straightforward thing to do, but let us move in sequence only so that it is helpful. What is the concept of handling multicollinearity? Akshay, I don't know. I won't like to include this as of now. We have not got multicollinearity as of now. So let us not get distracted on things which are not present. But still, I will try to explain you. The easiest way to remember about multicollinearity is that if you are sending very similar things to your data set, for example, I'm giving you side of square. I'm giving you area of square. I'm giving you diagonal of square. I'm giving you parameter of square. Okay. Now, if I ask you to remember each and everything, get the patterns and everything, you will get a lot confused. The reason being is everything is same. You can get each and every one of these things by just remembering the side. Same is the case with our model. If you will just send him the very straightforward things which are highly correlated, if you know about collinearity, these things will be highly correlated. Now, because these are highly correlated, they will basically confuse our model, and if our model will get confused, it will not give us good results. Okay. So I hope this thing is clear. Akshay was the one, yeah. But let us not get confused on this thing. We are not facing any collinearity. We will check if collinearity or anything is there. Okay. So I hope each and every one of you, these things are fine. So these are the few insights. Standard lunch helps perform well in exam. Standard lunch helps perform well in exam, be it male or female. So it is independent of that. Okay. Now let us see the other graph quickly. So let us see what we are doing. Data is all DF. X is your average. Okay. And now we are seeing parental level of education by male and female both. Okay. So little bit complex graph. Let us try to make few sense out of it. Okay. It will be difficult for me as well, but let us try to make it. Let us use, okay, all the pens are used. Let me use the, I think blue is the least used one here. So a lot of colors we have. So let us see the first one, which is this thing. This is your sum college, okay? So when the college is sum, it seems that most parents are having your sum college. Okay, something like this is happening. It kind of seems that, okay, count is still fine, but if I see here, I think most of them are kind of having the same kind of a things, just this green one. This master's degree, when the master degree is there, then I think somewhere the score is high. Okay, that is some case in your normal with male and female both. Now, second one was your male. Okay, for male, let us see the same. Okay, there's a lot, but let's say this red. So, master degree helps better in male. Okay, then your which is this. Okay, the associate degree is also kind of helping better. So, what I'm saying is the score is a little bit better for these things. Here, the score seems to be a little bit similar only. So, for these three, I would say just this bachelor degree helping better. Some college, if it is there, then it is. So data do gets complex like this. So okay, you will have to as a data scientist work on that data. So this was a very easy data when we started this out, but now the graphs and everything is showing us another picture. But the benefit is that graph help us to basically, I would say, evaluate everything at once, right? So what is happening here again? Now if you see, so let us write for this red thing. Red one was your master degree. Okay, and your blue one. So blue was your associate degree. So as of now, it seems like this is helping perform a little better. Then bachelor degree is also giving us a little bit better score. See, one thing I have to explain you guys that this is not something which we have in our hand. Okay, this we have already given. Okay, count is actually how many of these is in the data. So for example, around 23 or somewhat, I think by percentage is basically your this some college. Okay, for your some college around 23 or something is something like that. Okay, so we don't have to work on that. Let us see on the score, like how is the average is changing. Okay, let us now go to female and see the same. So I don't see a lot change here. These three are same, and this seems to do a little better. Let us see what the brown line is. Okay, some high school, and your blue line is bachelor degree. Okay, so this seems like a lot. I would say, well, not a lot of difference is there. Okay, in this thing there was a very huge difference in the score. So the insights basically I would suggest is that in this data, okay, normally we also discuss how in the real life it can have an effect, but my insights would be that it is not having a very major impact. Okay, this data like parent education as a whole doesn't seems to be a very good impact. For male, it seems like master degree and associate degree. Okay, that is a little bit better. And your bachelor degree is also helping a little bit. For females, some high school is basically giving a little better, but overall the case is fine only. Okay. I hope each and every one of you is clear with this thing. Can I get a quick yes or no if everyone is clear? And you will be getting all the codes, all the files and everything. Just right now, stay with me so that you understand everything. Can I get a yes or no if everything is clear? Getting all the insights right in front of you the way you should do so that you know. And believe me, even I have not like seen this data set or I don't remember these insights by heart. I'm just doing this and right in front of you so that you have an idea how you have to do that when you will get this project. Okay. So very important to focus on that thing as well, that how you will be doing the same. Seems like an easy data, but this is also becoming a little bit complex as we move forward, right? Everyone else, I hope this is clear. Can I get a yes or no, thumbs up, everything in the chat so that I'm aware and we are good to move forward? Great. So these are the few insights. Let's say what are the insights normally written. In general, parent education don't help students perform well. We have seen this. Second plot shows that parent was education of associate degree or master degree. That is also which we have seen. Third plot, we see there is an effect of parent education on female. Okay, it has taken no effect, but we saw that some high school was kind of helping a little bit. Okay, not a lot. Okay, it was yeah. Oh, 1 second. It is same. Some high school. Okay, it was little bit better, not no major. So that's why we have written it. Should be fine. Let me clear each and everything. Great. So now I think the same graph, but for race and ethnicity. Okay, this seems to be fine. Here, I think this race is performing a little better. Bad group B, and this group A. Sorry, group A. Yeah, B and A are performing a little bit worse. Then, if we go for the same in female, This seems to be equal only. This also seems to be around the same. Here also this green is group A, seems to perform a little bit worse than others. And in male, these are your middle points. So here also it seems group A is performing worse than group B is also there and group C is also there. So I think this A, B and A, like these are the insights which I will actually get from this thing. Okay, so if I see student of group A and group B tends to perform poorly in exam, that seems fine. So with respect to whether they're male, okay. So we have seen that A and B. Okay, let's see for the B thing. B is okay, so it has taken this as bad as well. So these are the bad thing which we have taken. And for example, A and B, this thing is A, and okay, this thing is B. Okay, we missed it actually. So here we can see actually there's a very bad performance on the average score, right? So in all the things, A and B is basically having. So some in the ethnicity part, A and B are facing issue irrespective of gender, and normally also we see the same. Okay. Let me clean each and everything. So maximum score of student in all the three subjects, that actually we have already seen. That is pretty straightforward. This graph again. So very cute graph, then figure, title, math score. Okay. So data, DF, line width, everything which we have taken. So this is nothing but just kind of your how the your this gonna basically we are just change the graph. So it happens a lot. I've included different graphs so that you play around with them and you get comfortable with them. It's not that you will be always, I would say, making histograms, bar graphs, and all just basic graphs. Okay. So in this, I think it seems, so the way we see it, everything is also all the scores are there, math score, reading score, and everything, and the math score and everything is there. So these are all the from the word. It is clear that most of the students score in between 60 to 80. So how it is extracting is that, see, this is something around. So most of the weight of this graph is coming around here. Now here you will see that from 80 to around here, so around maybe 50 something is weight is coming around, and similarly here. Okay, so major weight is coming around here. So that is something, yeah, that is the same thing, 60 to 80. So if you will see 60 to 80 for your maths and around 50 to 80 for your both the other subjects, right? Pretty easy, I would say, just getting the insights. That is what it is. Please go through all the code. I will share the same. Understand what are these graphs and why we are making this. Okay. So now we go on the multivariate analysis. So till now we were doing bivariate analysis. I hope everyone is clear. So there are normally three kind of analysis which we do: univariate, bivariate, and your multivariate. So univariate is when you do this all on a single variable. Okay, pretty straightforward. Bivariate, when you take two variables, like the way we were saying, we were seeing the average score, and then your race, gender, ethnicity, like we were taking two variables. Okay, then let's say we had the filter on the male, females, average score, and then the ethnicity or parental education. All these things were happening. Okay, so I hope each and every one of you is understood with this thing. Please give me a yes or no. If all is clear till now, then only we will move forward. Everyone, can I get a yes or no if everything is clear till now? I hope you're enjoying this study. This is a very easy case study, but then it helps you to, like I would say, clear most of your concepts, especially with regard to your this doing this. I would say ED and everything. Okay. Everyone else? Praveen will be sharing all the codes with you. You will be getting them in the. So see, 1 second. I think I just wrote something. Yeah. See, if you will go here and you add a filter for my name, Mayank Agarwal, and you go on Data Science Foundation. Let's say we enroll again. We have enrolled. This is removed. Then if I go on this day 6, if I go on resources and I click resource, so again what I'm saying, you have to go on iNeuron website You have to make sure that you enroll yourself in that. Okay, if any videos, anything is not clear, you have to do that. So yesterday also we did the same case study. So in the case study, when we go, we have the resource section. In this resource section is where the resource is, and you can download the same from here. So once we complete this class, I will share each and everything, whatever I'm using, so that you can also then do some analysis and everything on the same. Right now, there's a reason I've not provided you before. Like, of course, it is very easy for me to just upload and give you the any link. The reason is that I want you to focus on class and give me the code or give me anything which you want me to write or anything. Okay. If you will have the code, you will just click on pressing control enter, control enter. You will understand very less. Okay. So it's very important that you first get your doubt clear with me. Okay. Nice. So let us make few graphs. Okay. It has made a lot of graphs. Okay. Let me try to explain one of the graph, and I think it should be pretty straightforward for others as well. We are just making pie plots for the multivariate thing. Okay. So PLT subplot, then size is gender, value counts. Okay. So the counts of gender, labels is female, male, and we are just coloring them. Okay. Similarly, size, then plot, okay, size and everything which we have already defined, colors, labels and everything we have done. Then your gender, okay, and everything. So we are doing this thing on your graphs. Just let us see the output. So pretty straightforward, like how many male and females are there, what is the race and ethnicity type. So we can get this via any other simple code as well. Okay, just we have used graphs here, so because it looks a little better. But I think you are all able to understand. Okay, so the insights in this case is almost equal, 51 to 48. Then we see that A and B were the kind of bad performing classes, they're around 20%, and then others are there. C is basically the highest, C and D seems to be the highest. Standard lunch is the predominant here. Okay. Test course, none completed. So most of the students are with none test course, and parent degree seems to be fine only. Just I think master degree is something where most like the least kind of a thing. Okay, so let us get on inside. We have written number of male students almost equal. Number of student greatest in group C. Yes, that is also the truth. For student, we have this thing. We have standard lunch are greater. We also got the same. Not in university prep is higher. Some college is greater. It is the like we have taken this case. So some college is the highest and this kind of a thing. Okay, I hope you get all this thing pretty straightforward, very easy to do. Okay, you can take each and every variable as well and then also see the same. Okay. So one more thing which you can do this if you don't want to make any of your, let's say df dot gender. Okay, 1 second. Df dot gender. Let's say describe. So unique are 2, top is female, frequency is 5 minutes. Okay, so it is coming out to be 51.8 because 1000 entries are there. So this way also you can see the same. Okay, so that should all be fine. Let me see some comments if anything is there. Whether we can write in pen and paper like what all variables need to do univariate, bivariate with business problem and then start with code, or we need to practice to code directly, sir? Divya, what I normally do is instead of pen and paper, have I would say a Jupyter notebook ready where you have everything which you discuss, you learn, you I would say understand from someone. Like I have told you a lot of things to be done, right? I normally suggest following this DM methodology. Then in this, you have different steps to be performed. As and when you will do more and more projects, you will get to understand more on these things. Okay, these are the very basic steps which everyone has to do. Understand your data, univariate, bivariate, multivariate analysis. Okay, then graphs which can be used, all these things, and then follow that and see if that particular thing is following on your data sets. Okay, like let's say the data which you are getting. That is the best way to understand on the pre-processing thing. Okay, so all the steps you keep on writing there, and basically add reference also there. So you should have a master Jupyter notebook. Okay, I also used to maintain the same so that any problem I'm getting, I can basically run all the thing via that and see which is active, and I add the reference as well. Okay, so that thing is what I will suggest very highly for each and every one of you to do, because in different projects we get different things. Okay, and ideally we should also get. That is how learning happens. If you will be making same things, if I would have just give you the code by this describe or info and everything, you would have got the insight, but then it's better if we have the graph as well, right? So tomorrow, if you want to make it somewhere, we can just make these graphs. You can refer to this and make these graphs, okay? So let us now move forward feature-wise, gender column. Let us see quickly. Pretty straightforward. I'm not just doing anything on this. You can see the code as well. Very easy code. It might be seeming difficult if you don't have an idea on this thing, but believe me, it is pretty easy. Okay, the way we have done. So just exploding point one, we have added the difference and everything, colors and all are added. Okay, so pretty straightforward. Gender has balance, and let's say see by variant analysis as well. 1 second, there's a mistake. Let us see. String to flow. Let me see what we are trying to do. df dot group by gender. I think this is what we should do. So now let us see the gender group. Okay. 1 second. Why am I actually storing this? Just give me a second. It is giving me a panda score group by generic. Okay. I'm using this 1 second. So it wants this gender group. Here the error it is giving is. Okay, so I'm actually able to define this thing. That is not an issue. Okay, it is giving us an error. Let us quickly see why it is giving us an error. Should be straightforward. So df dot group by gender, it seems fine. Okay. So maybe if we try something like this, maybe it will work. Okay, so I think I will have to see why this code is wrong, but should be fine. Meanwhile, let me know anyone if any question is there or how you can correct this. I've just kept this to make sure that I can also show how we basically come up with this error if we are solving. So anyone who can help me with the same, that how we can solve this, the error which we are getting. So normally any error which we get, we have to then see that, okay, what exactly we are getting as the error, and we can normally search on Google and understand. Okay, so it is giving could not convert string to float. Okay, so we have the gender. Search for this as well. Okay, so we can actually see this thing. That should be all fine. Yeah, it is trying to actually, I think we should be taking that thing, but ideally in this case, it normally works, like it converts that meanwhile. But let me do one thing. Convert gender to numeric pandas. Let us use this code instead. This is a straightforward code which we can use. There is something .as type also which we can use, so that should also be fine. But yeah. It is giving me the same error. So let me see what is my df as of now. 1 second. Okay, it has basically made my df none. Just a second. Okay, I think I have to now run everything. Should be fine. Restart kernel and run all cells. 1 second. DF is basically gone. So yeah. Yeah, numeric column basically some data I think got. I actually was doing something on Excel. I think data got pretty bad there. So yeah, no worries. Let us just quickly run this thing and we should be fine. Anyway, I think we are just close to the data, so should be fine. Yeah, it is failing here only. No worries, let us try some other way meanwhile. I think the function, basically the library issue is happening. I ran that on another code. But anyway, let us actually move forward. I will see the code and correct that and send that to you. That should be fine. Meanwhile, we are just trying to get the plot. So let us go on the insights. I will fix that and that should be fine. So on average, females have better overall score than men. We already also see that in the one of the insights, and males have higher maths score. So basically what we would have tried to do is we would have just basically made a graph, okay, where based on the total average and the maths average, okay, we would have tried to now plot based on our I would say this thing, okay. So the same thing actually we were able to get from this thing. I think the library version issue is there. The code seems to be fine, but anyway, uh, when we were seeing your score, and let's say by gender, when we saw the same, so what I can actually also do is, if my average is your, let's say, math score, so on that I also see the this is basically the same thing. Your male have a slightly better I would say score than female, okay. That is something which we see. And if we see the same for the normal score, average score, we see that females are having a little bit better than your males, okay. So this is the insights which we were getting. I will correct the code, that should be fine. I think it is just due to some version mismatch. It was working in the different laptop which I had, but should be fine. Okay, then let us go to the race and ethnicity part. Yep, this is actually the overall division of the race and ethnicity. We have already seen the same. So based on, let's say, this is the total count and everything, these are the variable thing, already seen the same. Most of us belong to C and D. Lowest number belong to group A, and we also saw group A and group B were pretty bad, basically, in the way they were actually giving us the thing, okay. Now this is actually another graph. You can go through this code, just a pretty easy one only. Like, I know that this will be seeming, so if you don't have an idea on your matplotlib and libraries, you may be facing that this is a little bit, I would say, going towards overall a little bit heavy side of code, but it is pretty straightforward only. So we are just plotting the bar graph where group data 2 we are taking the math score dot mean, okay, and why we are taking the mean values of this, then palette is this, and basically what we get is something like this. So see, these are your groups and this is your math score. So we see that group E is pretty good in that, okay. Similarly, group E, seen that group E ethnicity is doing pretty good. AB is pretty bad in both the cases, and it is basically going like straightforward only. So A, B, C, D, E, A, B, C, D, E. Okay. Is everyone clear on this thing? What we have just seen now? So it seems like E and D are the best performing ethnic groups, and A and B are the worst parts. Okay. E seems to be the highest, A seems to be the lowest. Students from lower socioeconomic status have lower average in all core subjects. Okay. I hope each and everyone this thing is clear. Then actually we will just see another thing. Like, we have actually already seen these things by your graph as well. Okay, so the KDE graph which we got, but yeah. String to float. Okay, here also we are getting this error. Parental level of education, that seems fine. 1 second. Okay, here also we are getting the large number of students are from some college. So this is also just the same analysis which we have actually done this thing. So let me instead actually draw some graph which is other graph. So let me just actually to see the same, let us draw the graph which we were drawing earlier. So one second. So if we focus on this graph, I will check. I think the I was doing some project yesterday, so messed up the libraries version, so that would have been causing this issue. Was doing actually some project on big data, so that might have caused the issue. Now see, in your some college, we see the maximum count, right? Some college is giving us the maximum count. Now this gets reduced on the associate degree. Then let's say on your this the violet one is your high school. So that is what we are trying to see in the last data. Okay, I was able to run everything yesterday. Actually, I just was working on something on the big data, so I think that would have just messed it up. But should be fine. I will give you the working code only. So categories and everything is messed up. I think I have changed the version of pandas or something if I remember it nicely. But anyway, so this is your thing. Then if we go on, okay, I think a lot of these codes will now fail because of the integer thing which I've done. One second. These are the same inside. That should be straightforward. But I think everyone this thing is failing. I have changed the version of Python, so should be fine. This is now with respect to your. I will provide you with the working code. That should be fine. I think the changing of your Panda version is just giving me the issue, so that should be fine. Now, this is based on your student versus test preparation course, okay, and what degree their parents have, okay. So based on the student who had standard lunch tend to perform better than student who got free lunch. Okay, we saw the same in the starting also, that how standard lunch is giving us the better results, okay. And if test preparation course has any impact on student performance, so let us see the same. So the way we will be getting insights from this data is, this is my math score, okay. So this is the lunch. Now, if they have completed some score, their score is better in maths. Similarly, if we go in reading, with respect to standard score, your this is better. And it is better. So what I can say is that across everything, if a particular student has done its standard course, he or she is performing better and getting more marks in across all the three subjects. Okay, I hope this thing is understandable by everyone. Then a very easy code to just check for the outliers. Everyone, can I get a quick yes or no before we move on outliers? So few graphs which are not working, I will just check them. I think the pandas version messed up, basically caused that issue. Meanwhile, give me a quick yes if everything is clear. I have shown you like what insights they were showing, so that should be good enough. And we can also make all the graphs. So give me a yes or thumbs up if everything is clear. If any doubt is there, please feel free to ask them in the comments. Let me check the comments meanwhile if anyone has any doubts till now. Okay, thanks a lot. So now let us check for the outliers. Again, very important thing which we showed. So what is this known, everyone? What this thing is known as? Can anyone tell me? What is this thing? We have studied on this properly in this thing. Praveen is saying, sir, how to decide the graph we have to plot? Praveen, that is actually based a lot on your experience and I would say the projects which you have done. So normally it's better that we plot the graph where data is very, I would say, clearly visible. Okay. So what happened is that your pie chart bar and everything, these are understandable by everyone. Okay. And then you are able to basically make sure that multiple things you are able to work on that. But the way I do it is, let's say I see that how many variables I have to deal with. Okay, so if I'm dealing with multiple variables, I will see then and decide that, okay, which graph I can go forward with. For example, pie chart is pretty good for a single variable. Okay, or in worst case, two variables. Then your histographs and this KD and these lines are helpful for your two variables. Okay, once this thing increases, then is how we have to basically make sure to see that okay, which graph can be better helpful to us. If we are comparing three graphs, three variables, four variables, so based on that we basically get this thing. Mohammed is saying, please don't forget to upload this notebook in the research section. If there are any errors in this code, I will fix them. No worries, Mohammed. I will not make sure that make you do that work. I will fix the errors and then upload the code. Okay. So these are very minor errors compared to all the errors which I have already fixed in a lot of code. So believe me that those things I know, like due to some version or something, it might be happening. So I will fix the code and then provide you that all of you that so that it works. I know most probably I was checking something yesterday on Kafka and some I think Panda version I have changed, so that might I think be the case. It is giving error. Okay. Great. Let us move forward. So first, let us basically see on this thing. Yeah. So we do have outliers, I think, in the data which is present. So math score, we see that few outliers are there, and that's towards the lower side. So I think people are basically just scoring a little less, and I think okay. So on all the cases, these are our outliers. Okay. Average also it makes sense. So something like this, our data will be coming as okay, like this, because students have scored less. So those seems to be the outlier. Towards the maximum side, it seems to be within the limits. Okay. So I hope this thing is clear to each and every one of you. Yes, this is box plot. This is your 5-number summary. Praveen, I hope your doubt regarding how to decide which graph we have to plot is clear. Can I get a quick yes? We normally see that if you are moving to 3 or 4 of these graphs, then we have to see that okay, what will happen. Okay. Then this is your very important function, pair plot function. Okay, it basically helps us to. Okay, I think I won't be able to show you the same properly. It just help you to basically come up with the insights and dividing every basically comparing each and every column. So for example, your math score, the bottom here will also be the math score. Okay. So all the numerical columns are basically we are getting that okay, how much they are related. Or so for example, your maths and reading score, okay, they seems to be following a relation, and the relation seems to be that if one is increasing, other is also increasing, right? So it is kind of they seem like they are related to each other, and a good student, he scores good in almost all the subjects, right? So this is usually your math score, reading score. So it is actually the same here also. Okay, math, then we go reading, then we go writing. Okay, so like this, it is basically happening, and we do see that okay, the same line is kind of getting made. So it does make sense that okay, something like this is happening. This should be your average, and this should be your total score, I think, and the last one should be your average. Okay. All the score increase linearly with each other. So what does that mean? That there are no students, let's say, who is very good in maths and then worse in other subjects. Okay. So then we can just save it in a clean way. That should all be fine. Should be not an issue. Few conclusions. Student performance is related to lunch, race. Lunch, how it is related? Standard lunch was better. Race, how it's related? D were better. Parental level of education also was having an effect. Females lead in pass percentage and also the top scorer. That makes sense. Student performance not much related. Test preparation. We saw the same, but the case was if they have taken the same, then they were getting the highest score. Okay. And finishing preparation course is beneficial. That we have already seen. Yeah. That if someone finished their preparation course, that overall is beneficial. Okay. I hope each and every one of you is clear with this thing. Can I get a yes or no? Great. So we'll share the same with you. Now let us do some feature engineering. Same data set. We will be doing feature engineering. Okay. I hope everyone is ready for the same. Let us move a little quickly because I explained that in a little bit depth. So to complete the exploring feature of the data set, hypothesis testing, checking for normal distribution using transformations. Okay. So we'll do all the things. That should be straightforward. So we first import all the libraries. Pretty straightforward. I don't think anyone has an issue. This time, please make sure to load the clean data set instead. So we will load the clean data set. We will just see the df.head. That thing should be clear. Okay. Here also, okay, I think the issue is basically covering. 1 second. So let's quickly see the error. Okay, I think yeah, that is the full issue which I'm facing since Panda version 2.00. Great. I think if we solve, if we see this here. So if you will see since Panda version, it has changed a little bit, right? So maybe that was causing the issue. No worries, we'll fix that. As I said, I think I changed the Panda version. It was something else, and like I will see the same. So that should be the case. But anyway, I hope this thing is clear now. Correlation metric. I hope each and every one of you remember this correlation metric. It is one here. Okay, 0.81. 0.81 seems to be highly correlated. Mass score highly correlated with total score. Okay. Reading score also highly correlated. Writing score. So all the scores seems to be very much in correlation, right? Then let us make some pair plot. We have already seen this as well. Okay, I hope each and every one of you remember this as well. So we just saw this pair plot. Pair plot is very nicely used to make this kind of a thing. So seems to be high correlation seems to be there, which we can see from graph as well as from the value. Okay. Linear relations with other variables. To clarify, we will plot the correlation map. That is also one very good thing. Okay. So then let us move forward. Shapirovic test. So this is some test. Okay, I think I can move forward with that because I'm not taught you all this. So like just some test to basically make sure that confirm our hypothesis. Okay, and if it is normally distributed and everything. Done a lot of test. Okay. I will share this, read about it. I have not covered these things because they become a little bit advanced. Okay. So it will be better if you know the theory and then you run. As I said, I don't support that you are running these things just because it is present. I intend to always, so what I do is in every of my case study, I intend to just make sure that 70 to 80% of what all I have taught, I will be covering, and will be there something 20 to 30% will be there, which I have not taught. Why? So that when you get the code and when you basically understand all these things, you spend that effort to learn about this thing. Okay. I always suggest in all of my community class also that we should not stop our learning on the basis of what just we have learned. So please read about these tests and understand about them. And I think they will be highly beneficial to each and every one of you. Okay. So just few basically things they will be giving. Spearman, so we have actually already seen. 1 second. K-square normality test is there. Then Spearman test is there. We are just seeing Spearman coefficient. So I hope each and every one of you. So there is Spearman coefficient of correlation as well. Just read about it. Okay. Let us quickly create few graphs. Okay, so Pearson test for our one thing. So these are all the things I will actually. So I have already said that I will be covering a lot about your hypothesis testing in the next community class, which I'm most probably thinking that I will be making for hypothesis testing only. So we'll see the same. We're just checking if the scores have correlation. Then chi-square test, as you all remember, chi-square test actually we have learned a little bit. We do that on just the categorical features. Don't be afraid on the above thing. We'll explain that properly in the class. But meanwhile, when you get the code, just try to understand the same yourself as well. Okay. So chi2 contingency is basically something. Then we try to just run this and see. This is what we are getting. So it kind of seems that this is dependent and dependent, while all these are all the independent things. Okay. So let me just, okay, I have actually, okay, I think just included few of the things which were these are giving. So just read about them. I am just going forward with them because I don't want that this becomes C. So DF correlation, we are facing this error again. Now this error is gone. So Muhammad, I hope you got why I'm getting the error. As I said, for the pandas version, same thing. Just for the score, I'm getting this as this your heat map. So that should be straightforward as well. All these are highly correlated, we have seen. Now let us see for the transformations. So can we say that these are almost following the normal distribution? We have seen the normal distribution, everyone, right? Can we say the same? Can I get a yes or no on the same? That they seem to follow the normal distribution but are left skewed, kind of, right? I hope this thing is clear. For the hypothesis testing part, I know I've just covered that a little bit. The reason is because I don't want your course to basically stop on that way. So we'll take another community class and cover all of these things, okay? Meanwhile, just when I will give you the code, read about them yourself. They are a little bit advanced concepts, so which I normally suggest that either I will be taking this separately or then explaining them. So it should be fine, okay? So this just also seems to be a log normal kind of a thing. So let us now see the log transform as well. So kind of seems, this do seems that yeah, they are following the normal distribution overall. That should all be fine. So what I've done is I've just taken log df of average, okay, and checking the skewness as well. So 1 second, we see that we have a skewness value. So negative skewness value tell us that the data is negatively skewed, right? So a negative skewed, also known as left skewed distribution, a type of distribution in which more values are concentrated on the right side of the distribution graph, while the left tail of the distribution graph is longer. That is the case, right? See, more values are on the right side, while the left tail is longer. I hope this thing is clear to each and every one of you. Can I get a quick yes or no? If this is clear. Everyone, yes, no, thumbs up, anything, so that I know this thing is clear what we are doing. Okay, everyone else, thanks Praveen, yeah. Great, everyone else. So see, one thing is that as a statistics or data scientist, okay, I also like to call us as statisticians, though we are on the basic level of this, statistics is very deep. See how much we can get from the very easy data, right? Now, think that if your data is complex, how many things once you work on easy data like this, okay? So this is one thing which I normally always say, that if you're working a lot on these easy data sets, right? Let's say you do 10 of these projects. See, when you will get a difficult or complex data set, what all you will be able to extract, right? What all insights you will be able to extract, right? Divya Ramesh is saying that is not normal. No, Divya, this one I'm not talking. This we have taken the log transform of them, right? See, these are the normal distribution kind of, and all of them are skewed towards left only. So following the normal distribution and left skewed, okay? So this I'm not saying, this is towards your left only, okay? I hope this thing is clear. The skewness also we have calculated. See, it is negative, this thing, right? Great. So yeah, what I was suggesting is that once you do so many easy projects and try to basically get into the depth of the concepts, then just think that how good you will be when you will be getting a complex project, which like we will also be covering. But overall, you will have a very good, I would say, confidence when you will get the project in the industry and everything, right? So if any project is easy, please don't skip that. Rather, I think easy projects are better to do because then you get more understanding. If you have a similar column where, let's say, a similar data set where, let's say, now 80 columns are present, you will never get to the depth of it. You will just write code, for loops, and everything. But an easy project where, let's say, handful of columns are there, that is where your expertise will get, I would say, more polished, and you will be able to work on the same, right? So it is very important to understand this thing. So there is something known as square root transform as well. So just get it done. So see, what we are doing is just we are taking the square root. So we took the log. So now we are just taking the square root similarly, okay? Idea of this thing is also clear to each and every one of you. This is also just some kind of a graph. So we see the log transform. We also have the square root transform graph, okay? Now this should be, skewness level is also there here. So that should be fine. We are seeing the skewness every time. Okay. So QQ plot actually I have not also taught. So let us move forward with that. I don't want to confuse you guys. So see what is happening. Let me try to explain you a little bit on this thing so that you are clear on this. See, this is your kind of a normal distribution line. Let me take green color because it was being used. See, this is what your kind of a normal distribution line. Okay. So what happened here is that around -2 and +2. Okay. Below these values, your normal distribution is not getting kind of followed. Okay. So this is how we kind of check it. So see, a lot of values are here around 100. So a lot of people have scored 100 maybe in the reading score. Similarly, here as well, that is the case. I think almost in the writing score. And this one is your average score. Okay, so somewhere here also same thing is happening. So this is what is happening. So for range -2 to 2, average score and math score follows normal distribution. But for values less than and that, it doesn't follow normal distribution. Something which we were able to see as well, but I hope all of you are clear with this, right? So to learn more about, just see QQ plot and learn about it. Quantile plot, so you can learn about the same. That should be pretty straightforward, right? That is how we normally learn about plots and everything. So read 3-4 of these articles and you will get an idea that okay, how it came into being, where all it is used. And I will just suggest one more thing. If you're doing any project, okay, if you are doing any project where you think you know more than 90% of things in that project, please don't do that. Okay, or either keep that towards the last. You should always do a project where you know around, let's say, 80% or 70-80% of the things, so that rest of the things you will work and learn upon. That is how you will always grow. Okay, if you will just do a project where you have an idea about everything, if I'm just using the graphs or if I'm using the things which I already done, see, we have already seen all these things. Okay, from the same graph, this is available, right? So if you see this thing, all these things are available, right? That around -2, this is skewed. Then this kind of data around 100, it is there. It is not kind of, I would say, smothering down here. So once we make and understand by other things, that is when you will basically move forward. So now because you know QQ plot, and that is the reason for me even to introduce all these things, so that you will know about different things as well and try to include them. Okay. So I hope each and every one of you clear with this thing. Can I get a quick yes or no? So these are all your QQ plot again, and there exists correlation between student score and normal distribution line. This means that our data set is very close to Gaussian. I hope each and every one of you agree with this statement. Can I get a yes, no, or thumbs up? A quick yes, no, thumbs up, anything will be very helpful. So I hope you are liking this data. This is very close to what I normally take when I explain things, as well as it's pretty easy data, but then when we do complex things on easy data, that is where the fun lies, right? So can we see the comment? Yes, yes, yes. Okay. So let me know if any doubts or anything is there. Meanwhile, guys, we'll see the same. Let us quickly cover the outlier detection as well. That should be fine. See, identifying outliers with visualization. Normally, we use the box plot. Z-score method is there, comparing skewness, and then interquartile range, IQR method, right? We have already learned about the IQR method, right? So let us just import the libraries. Going a little bit quick because this is very easy. This is what I've told each and every one of you. So DF head, we normally just see that. So making this box plot. So for different each one of our scores basically. Okay, num DF columns we have. So these are all your num features. So which are math score, reading score, writing score, average score, and mean score. Okay. So for all the things we are seeing are what are the outliers which are lying. Then let us see the distribution. Like we have seen this already, but again let us draw this so that we know that okay, it is leftly skewed, and that is the reason. Like the outliers are present. We have already now learned about the IQR, median, all the, I would say, 5-number summary and everything. So I hope you all can also now draw this this part basically, right? Pretty straightforward. See the distribution for the same. So let us just quickly count the outlier. That should be straightforward. Like we can count here as well. But what we normally do in, see how it is counting the outliers. I normally, so what I do when I'm testing, or let's say when I was in industry, like I used to ask students on writing this kind of a code. Okay, so if you will see the code, it is very straightforward. Count outliers. We calculate the Q1, Q2, Q3, Q4. We calculate IQR. Okay, then we define the LLP and ULP. Okay, so if you remember, this is the range which we decided, right? Now we just basically saw that okay, if outliers are there or not, and then we calculated them. Okay, count of outliers are this. So see, I hope this thing is clear to each and every one of you. Very important, straightforward, and everything. Like this is what we have learned in our theory as well, right? So you can be asked to write this code. Okay, that is what I expect. If you have studied from me, if you know the theory, you should be also good to write the code. If tomorrow, let's say, outlier library is failing, okay, and you have to do something quickly, then you are good to understand this thing. So that kind of thing is very much important. So based on that, we will actually just get the number of outliers. So this is the function which I define, count outliers. We'll be sending the data in the column. So see, for I in X columns, count outlier X and I. Okay, so that is how it is happening. Great. So math, there are no outliers in math score. Sorry, there are outliers in math score. Outliers are 8. Outliers in reading score, outliers in writing score, total score, average. Everyone we have the outliers, right? So let me remove all these things. Then again, z-square is a method. Read about that. Highly recommended. It will just replace your outliers. That should be fine. See. So number of standard deviation away from the mean that a particular observation is. We have already scored about z-score, right? What was the formula? Can anyone tell me? This was the z-score we defined, right? We have already done this in the standardization normalization case. Can I get a yes or no? Let me just zoom in this a little bit so it is more clear. Yeah, you can read this now, I think better. Everyone, can I get a yes or no if you remember about the z-score? We did study about it. Yes. Anyone has any doubt or anything which is not clear? Let us take a 1 minute break and understand. If anything is not clear, you want me to explain on the same. Okay. I know it's a lot of code, but I intend to do the full case study. And I also didn't want to basically do that, the case where, I'm just covering few things from the very top up and then like just showing you the case study. So I know a lot of things will be uncleared, but that is how I intended it to be, so that you study on those things. Okay. So it would have been a lot easier to just remove all these things, but I have kept this because when you will be getting this code, when you will be getting this thing, you will study about them, right? So my aim was actually to make sure that we are getting a simple case study, but we are doing complex things on that. So simple data, complex things, right? Anyone, any doubt till now? We are taking a minute to understand if any doubt is there. Please let me know in the comments if any doubt or anything is there. Okay, if no doubt is there, then I think everything is clear. And for the rest thing which I'm not taught, pretty hopeful you will do the same. So again, we are just doing the outlier threshold, quartile 1, quartile 3, IQR, up limit, low limit. See how we are, this time we have taken it 0.10 and 0.90. Okay. So what is the normal Q1 and Q3 which we take? Okay, what is the end goal with the data set? We have to keep in mind while working with it. I need to practice, sir. Hope doubt will become while doing. Divya, please feel free to reach out to me if you have any doubts. You have my email ID. I will be taking further community classes as well, course as well. So that thing overall should be clear. Understand everything which is written in this code which I will be providing with you, and let me know if anything is not clear. We can connect and I will explain you this thing. So overall, see, the thing is that what we have done with this data set, right? In the last around 1 hour 45 minutes, I normally expect someone to do that in a one and a half week. Okay, in a industry thing when you do that, because it's a lot of insights and everything. Because I have to show you these and cover full case study very quickly. That is the reason, like, we are doing. So it is never the case like, let's say, uh, you know hypothesis testing, you will just be applying one hypothesis testing or two which you know. No. What you will do is you will applying 5-7 of these things so that you can be sure that okay, you are getting similar results with everything. Same goes for your outliers. It's right that we have studied about your box plot method, five number summary and everything, but we will still check with different things, okay, different cases. So in the Z score, you will see that it has taken the quartile one as 0.10 and 0.90. Okay, so we took this as overall your 0.0, like quartile we took as I think 0.25, right? Q1 we took at like this, right? So different methods are there, which all of which we have to use. Same goes for the modeling. It is not that if you have studied 3 algorithms, you will just do that. No, you will learn about the other one and then apply and make sure that, let's say you're applying 7 or 9 of them and getting most of them are giving you the same results. Okay. Then one more question I have: what is the end goal with the data? What you have to keep in mind while working on it? Praveen, the end goal is that all the statistical and all the approaches which we have done, we are applying them. So we are handling this missing values outlier, we are doing feature engineering, EDA, and before we send our data to the model, okay, we are able to extract maximum things out of it. Okay, I told you yesterday also about how you can do that. So let's say take up some other case. Okay, let's say if someone has done analysis on GMAT score, SAT score, or let's say your GATE score, okay, or let's say JE score. We might have some data where someone has done that analysis, right? Try to see if you can extract anything from there which can be applied to your data set. Okay, so our main aim always is that, let's say for the next 1 week now, I will work on this data and I will try to get as much insights as I can from this. Okay, so you work on the data, let's say for a particular period of time, you take references, you basically then apply different things so that when you send this data to your model, okay, it is able to basically give you the results. Now you can of course have to go back there. That is also something which we learned in a CRISPR methodology. But then again, you have to make sure that in the first go you are getting 80 to 90% of all the insights which you can get. The thing is that you can always keep working on the data. That is not something which you have to do. I normally suggest based on the data volume, like for example, for this data, 3 to 5 days is what I will take to do all the EDA and then pass the model. Basically, model just to run in the model is very easy thing. Okay. So I hope, Praveen, your doubt is clear. That is our end goal. Okay, we have to define that, okay, for how much time I will be doing what. That is our overall end goal. Great, I think let us quickly move forward. So we are just seeing some other ways to do that. So you have seen that we have already counted and did all the outliers things, right? This is what we have studied, but still other things we are also checking to see that, okay, if they're actually outliers, will someone say that it is not? So this kind of things we are still doing, okay? So let us quickly define and replace with threshold. Above box plus outliers are not removed properly. So see what it has done. Okay, let us quickly see. Quartile 1, quartile 2, IQR it has calculated. It has taken different quartiles ranges, that should be fine. We have defined upper limit and lower limit, that is all fine. Replace with threshold. So for variable, numerical variable, low limit and upper limit, we get from here low limit and upper limit. Now if it is low limit, we are changing it with low limit. If it is less than your low limit overall, okay. And in a similar way, if it is greater than upper limit variable, we are basically doing this. Okay, so we call replace threshold. It called low limit and upper limit for outlier threshold. Okay. But still we see that it is not able to basically remove all the outliers. Okay, then let us go to the IQR range. Okay, this I think should be pretty straightforward and easy for each and every one of us. Okay, now let us see what we have done here to remove the outliers. Percentile 25. Very important. Here in the last one we took 0.10. Here we are taking 0.25. 0.75, 0.25. IQR, upper limit, lower limit. Where upper limit greater than upper limit, less than lower limit, then lower limit. Now the question is that in what it would have happened is that in the last one, let's say the sum of the values are present, outliers were present here, our lower limit was actually a little down. So we corrected these variables, but these were not done. Okay, let me actually just explain you by going a little bit away. I'm sorry for that. See, what is happening is that in the last Z score, what would have happened is that our lower limit might have come from there because we saw that we are taking 0.10. Okay, So if let's say few values are present here and few are present here, we were able to correct these values, but these were not corrected. Okay, that is why even after doing that, we were able to see that outliers are present. Okay, so we are not doing IQR range. So let us remove the outliers. One second, let me define this function. And now it seems that okay, few of the outliers are basically removed in the math score. So we are just comparing. Okay, just see the functions, pretty easy functions I have written. So df and this thing. So see, initially outliers were there. Okay, now we have removed the outliers. So we will do the same thing for all the things, right? Removing outliers and creating the plot. See, similar thing. Removed our outliers, got a little bit more Gaussian distribution. Okay, and then same thing in your this thing. Now see one thing here, the upper limit is 110. Okay, so we won't be doing anything to your 100 score. And of course, 100 is the maximum score which one can get. Here the upper limit is 109. Here the upper limit is 107. So it is the lower limit only which we have to correct. Okay. So now outliers are also done. Average, like okay, I'm doing this just on the same all the variables. And then skewness is getting compared. That should all be fine. I think okay, I will have to do the same thing again. It's like the error is very big, right? So normally you see that okay, what we have missed, but anyway, I think it is very easy. So skewness. So DF was our initial data set. DF1 is basically what we had. So you will see that how skewness has reduced, right? After we remove the outlier using IQN method. Okay. I hope each and everyone is clear with this. Skewness, what is it? Earlier it was skewed towards this thing. All the data, let's say, which were falling around lower than 25, we basically said, hey, let us move them and replace them with the lower limit. Because of that, what happened? Your overall skewness has decreased, right? That is what we are able to even see from the data, okay? So really nice. Let us save this data and let us quickly go toward the model application stage. Ideally, everyone, this is where our EDA feature engineering and everything kind of ends. Okay, now we will be going toward the model application so that we actually are able to apply our model as well. So see, let me just run this. Okay, a lot of libraries. Let me quickly explain you. I think we have good 5-7 minutes left. NumPy, Panda, Seaborn, all these are fine. Model selection, train test bed. We have already seen this thing. sklearn metrics. Let me remove everything. Train test bed, mean squared error and R squared error. We are aware of this. We should be good to remove outliers based on the data. Like we are good to remove the outliers if it will help our model to train better. Of course, that depends a lot on data. Okay, but in a normal range or anything, we should be good to remove our outliers if you want that. That should not be an issue. We do remove them and calculate them like this, or we can maybe calculate them by other methodologies which we have. Okay, great. So column transformer, pipeline, basically all these are normally used in ops. So, but anyway, k-nearest neighbor regressor. We will be using regression based algorithm. We're not encoder, now you all know about that. Power transformer, standard scaler, min-max scaler. Okay. Scaling also I have told you, okay, about the min-max scaler, standard scaler, everything we have done. Then decision tree regression, random forest regression. SVR. There is an SVD and SVR, right? Support vector regressor or regression, I think is the so that is the algorithm. Then train test split, linear regression, ridge lasso. It is room for randomization. R2 score, mean score. I think we are already okay. We got the R2 score again. And then again, randomized search CV, grid search CV. A lot of ML here. You might be aware of them, might not be. If not, go to the course of machine learning foundation. You will understand a lot of these things. Okay, and those will be helpful to you, right? Let us quickly apply them. This I will just take very quickly, so that I just want to show because someone asked, right? So we are dropping the total score. Okay. So we have the average num scores. OHE is one hot encoding columns. All of my basically all of my this categorical variable will come and fall into that, right? So let us now do the scaling as well. Column transformer, transform scale, standardized scaler is there. Don't get confused into that. Might be a little bit daunting at first. Simply applying the linear regression, we did the train test split, took 0.3 as this random state also. Okay, Then your scaling we are applying. So pipeline basically just kind of define your steps. Okay, which model I will be requiring, then transformer, and then scaling. Okay, so I have defined your column transformer here, which is TNF. Scale is your column transformer and a standardized scaler. Okay, and then one hot encoder. So the pipeline help you to basically, instead of doing things to your data like this, what happen in pipeline, it makes a pipeline. Okay, you send your data via this, and then you get the results and everything. Okay, I hope this is straightforward. Just don't get a lot confused in this power transformer and everything. What is it? Please, as of now, just on data science. I know there are a few things which might not be clear, but let us go step by step only. Okay. Let us see the mean square and everything. So we get the R2 square as 1 and mean absolute error as very low, like 3.9, and is e to the minus 15. Let us just use a ridge regression as well. I will just quickly run through this. Ridge regression, lasso regression, they are randomization techniques. Okay. Praveen Pandey is saying, I have little idea on ML, sir. Nice, Praveen. I have done Algerian forest fire. That is good, Praveen. So if you have an idea, just go through all this code. If anyone doesn't have an idea, this code will seem a lot heavy, but I believe me, it is not the case. So we'll just quickly run through few of the cases. Okay, we are seeing that, okay, what is the MAE and RAE we are getting. Then SVR is also there. So it is very, like I always say, model applying is very easy thing. So you will see that in most of the cases, I'm just changing this thing. SVR like this, you have to understand this, what is kernel, what is this gamma, what this C variable is, but and what is this maximum iteration, everything, but still it is a little bit easy. Okay, you just have to specify some code and then work on the same. Okay, so just moving very fast now. Okay, it is giving us some error. I think for the library max citation parameter must be in the range of minus 120. Okay, let us move, change it to 5000. Not sure why it is less than infinity. Okay. K-neighbor regressor is also pretty easy. I told you about the K-neighbor, I think decision tree regressor. Then random forest regressor, pretty straightforward, very easy code. Okay, we are just doing different regressor. Okay, pickle is a library by which we save the code. Okay. And I think, yeah, preparing data to create batch predictions. This all I think you can just lose for the timing. That should all be fine. Okay, based on where you are getting the errors, I think we can compare all the models. So a simple code can be written for that, and then you should be good. Like I don't want that you connect to MongoDB and everything as of now. So we are just preparing data to create batch prediction. Then database connection, we are connected to MongoDB here. All this should be fine, but yeah, just ML model also I have applied. You can just see for the code. So we are getting very less MAE here. R2 is 1. So I think pretty straightforward. We can see that, okay, which is the best algorithm and everything. But I'm not going a lot into ML algorithms. That is not what our community class was. It was for data science. But because after all your data science, your ML model applying things come, that is why I just covered it. And you will get that in the code as well. But yeah, I hope overall, till the first 3 notebooks, everything was clear. Right? Can I get a yes or no, everyone? How did you like the case study? Like how easy it was, and still we were able to basically cover this in a very quicker, faster way in basically, I would say 2 hours, right? Divya is asking power transformer means power law distribution. So no, Divya, that is not the case. Power transformer is basically something kind of done to make our data like a lot like Gaussian, like so, because we have few assumptions. If you would have attended my ML community class, you would have learned that basically we assume that they are following Gaussian distribution and everything. So that is kind of some transformation which we applied. Okay, just read about it a little bit and it should be fine. Okay, everyone, I think, can I get a yes or no if everything is clear? This was actually the last class for this data science foundation course. Okay, next I will be coming up with some other community class. Can I get a yes or no if everything is clear? I will be sharing each and everything which we have done here so that you can work on the same. Just read about them in your, like when you will be working on them. Anything which you're not understood, please feel free to reach out to me as well. My email ID is Mayank and then @ this iNeuron.ai. Okay, so this is just my email ID. I hope you all enjoyed the things. Thanks you a lot, Praveen. I will highly suggest that you see my other session as well, where I've taught about data science foundation and your machine learning foundation. That will be a lot helpful. Okay. Divya, hypothesis testing, I intend to do that. This data science foundation also really gave knowledge, learn about myths and how can I practice. Thank you, Divya. I intend to make it a lot industry based only. So hypothesis testing I will try that. I'm able to take a community class for that as well. Okay. Great then everyone. Thanks a lot. If no questions are there, we'll be closing the stream. You will be getting the recording, of course, on YouTube only, but the resources will also be available on iNeuron challenge. Okay. So thanks a lot for your time and attention, for staying with me for the 7 classes. And I hope you are a lot clear on a lot of concepts, right? We have gone into the depth of a lot of concepts. So they should, I hope, be clear now. Okay. So just in a minute, I will close this. Thanks a lot, everyone. And please make sure that you follow iNeuron channel and any other community classes I am taking. Please be part of that so that we can learn and grow together overall. Okay. सर अभी टीचर्स को एआई पढ़ाना ही नहीं आता. Vlogs pretty sure कि AI से पहले there are few things which we can learn. Okay, believe me, teachers can teach you everything. And overall, I think there are good teachers. Okay, like in iNeuron only, and AI is actually not that difficult to teach or apply even. It is pretty straightforward. So if I ever take a class, community class or anything, please reach out to me and I will send you the link. And I'm pretty sure that you will get everything clear there. Okay. So yeah, thanks a lot everyone. We'll be closing the stream. Divya, that is my aim. I actually try to make sure that anything which I'm making that is for high school students. For real, like that is the approach I follow. Okay. Glad you were able to understand the same. Great. Thank you everyone. We'll be closing the stream. So yeah, thanks a lot for your attention.